Hi, hello everyone. I am Prashant Nandam. Welcome back to our YouTube channel. As you all know, we have three playlists in our YouTube channel, which is version control system, where we have discussed Git, GitHub, GitLab, and Linux most used commands, where we explored to Linux commands, and we recently completed AWS Masterclass series, where we have explored to multiple AWS concepts and services, and overall we have 20 sessions covered, and each session provides a detailed information of AWS cloud. And today I am going to prepare a single video combined with all videos together. Initially we have session 1, session 2 videos, right? Now what we are going to do, I'll be preparing a complete series into a single video and I will be uploading that into our YouTube channel, and you can find them in and I'll also creating a new. Now if you see here we have playlist, right? I'll be also creating a course section where you can see complete course. I mean, if you are interested in watching continuously uh, complete video or complete tutorial sessions, not a single session one by one or something like so, I'll be preparing a new course playlist and I'll be adding complete video over there, and you can all go through the complete sessions and play with the AWS services and enhance your knowledge on AWS cloud. So without wasting our time, let's proceed. We will cover AWS Masterclass series. As I mentioned earlier, we'll be covering AWS series in our upcoming sessions. And AWS series, we will be covering total we have around 19 sessions and 2 hours of complete architecture demo. We will be deploying a 2-tier architecture and 3-tier architecture. And in our session 1 we will see basics of cloud, and in session 2 we will see software development cycle, and from session 3 we will be going deep into AWS resources. And as a part of session 1 today we will be covering what is cloud and cloud providers, cloud deployment, everything. Let's begin. Now, first thing we will learn what is cloud. Just a moment. What is cloud? Now, you all may have heard cloud in our day-to-day life or day-to-day activities. Now, cloud is like cloud is a word which refers to servers that are accessed over the internet. Uh, and if you see, just give me a moment, we'll try to. Now this is cloud. Okay, and in this cloud we can access the servers over the internet. Now let's say you are the user here. Oh, it's very big. Let's say you are a user here and we have cloud servers here. Now what we discussed, cloud is referred to servers that are accessed over the internet. And now we will use cloud for storing data and using things like software servers on the internet instead of keeping them on your personal computer. Okay, now for suppose we have a we all have mobile phones, right? And whenever our storage increases or our storage becomes full out of space, what we'll do, we will move our pictures or any other data to the Google Drive or iCloud or OneDrive. Now what is happening here, the Google Drive photos, I mean whatever we are uploading to the drive, where it will be stored, that is stored in the cloud. Okay, now if you see user User is here, and with the internet he can access the cloud. Okay, and he can use the services provided in the cloud. And uh, to make it more understandable way, now if your phone is out of space and you will be moving your photos to the Google Drive or OneDrive or any other, now these will be moved to Google Drive or OneDrive, but where they will be stored in the cloud. And how they are stored? We have photos, we will be saving them into the drive. Let's say drive, let's make it small one. Let's keep it here. Now drive is in cloud, and user will be accessing the services via internet which are in the cloud. And here cloud refers to the servers that are accessed over the internet, and now you are accessing the drive, which means you are accessing the cloud. And if you out when your storage is out of space, you will be moving your photos to drive. And where now when you move your photos to drive, where they are saved in the cloud, which means you are accessing a servers which are in the cloud. That's how what cloud means. Now we will see what is cloud computing. Second thing we will see cloud computing. Okay. And now cloud computing is like the practice of using network of remote servers hosted in the cloud. Now you all came to know what is cloud. Now the practice of using the network of remote servers which are hosted in the cloud is called cloud computing. That's what it is. And to make it is more simple way, cloud computing means using computing resources which are like servers, storage, database softwares through the internet on demand, which means we are here we are using the drive, which means it is a cloud computing. Why? We are using the network of remote server which is hosted in the cloud. That's what it is. Hope you understood. Using network of remote servers hosted in the cloud is cloud computing in simpler words. Okay, hope you got it. Now we come to know what is cloud. Cloud is uh, it refers to the servers that are accessed over the internet. And in other way, cloud is a uh, cloud is like storing and using things like data and software applications on the internet instead of your local computer. Now the drive where it is in the cloud, and how we are accessing via internet. And what does it mean? We are accessing a server which is in the cloud. Now, what is cloud computing? The practice of using remote servers which are hosted in this cloud is called cloud computing. Okay, and we can use in this example we have seen only drive, and we can also use computing resources like servers, storage, databases through the internet, and this cloud can be accessed via internet only, through the internet. And to make it more understandable way what is cloud computing means, now you want to play a game, and instead of buying the expensive gaming PC, you rent a gaming machine online, like you in AWS or any other resources, you rent a machine and you download an application and you play the game in your remote machine instead of your local laptop. Okay, similarly companies will provide their servers over the internet, and we can rent them. We can use them by paying rent. Okay, include. Now we come to know what is cloud computing. Now we have cloud providers. Cloud providers. Okay, cloud providers. Cloud providers. Cloud providers are the companies that own huge data centers and renting computing services and rent computing services. Okay, cloud providers are like, here we have seen cloud, right? In cloud we have services, and we have services. Let me write it here. Let me see if I can make it large. Yeah, it's good now. Now we have services here. Services. In cloud we have services too. Text is black. Is there a way to change color? This is okay. Now we have services in cloud, and these services are provided by whom? We have services in cloud, and these services are provided by the cloud providers. These are provided by the cloud providers. These services are, we have cloud, and inside cloud we have some services, and these services are provided by the cloud providers. Now, who are cloud providers? We have different type of cloud providers. Okay, the most used cloud providers are AWS, which is Amazon Web Services. We have Amazon Web Services, and then we have Azure, which is Microsoft service provided by Microsoft. We have Azure, and then we have GCP, Google Cloud Provider. We have Google Cloud Provider. Then we have Alibaba, and we also have IBM Cloud and other private clouds. But AWS, Azure, and GCP are most seen and most used, I can say. Others also are used, but these are most used. I'm aware of. Like I'm aware of Azure, AWS, and GCP. These are the things I most use. Now you come to know what is cloud. Let's define again. If you see in our words, what is cloud? Cloud is like storing our data, and we have seen a drive example. When the user phone is out of space, we can move our photos to drive, and now where this drive is stored? In cloud. What is the drive? It is a service. It is in cloud. Okay, now the practice of using services which are hosted in the cloud is called cloud computing. You also got that. Now we have cloud and we have services, and who are service providers? We have Azure, GCP, Alibaba. These are the service providers. Okay, hope you understanding. Now we have deployment models. Okay, now if you see, we have this services, and they also provide deployment models. Okay, these are the clouds providers, and each provider has deployment models. And what are they? They are public cloud. First one is public cloud. Public cloud. And the second one is private cloud. Private cloud. And then we have hybrid cloud. We have hybrid cloud. Okay. Cloud is having services, and our cloud will provide us the services, and the practice of using that services is called as cloud computing. And what are the services we have? These services are provided by the cloud providers. And who are cloud providers? AWS, Amazon Web Services, Azure, which is Microsoft, GCP is Google Cloud. And these services has deployment models. Let me make this also. Deployment models. These cloud providers has deployment models. And what are the deployment models? Public cloud, private cloud, hybrid cloud. Now, public cloud is like it is for everyone. I can say like it is a server shared by many users. Now, if you see, we have seen. Let me make it simple. We have seen AWS, Azure, GCP, right? And we have seen Alibaba and I also. Now, the cloud provider will have deployment models, and the deployment model which is public cloud, which means Azure, AWS, GCP have their services shared by many users. If you create a account in this AWS or Azure or any, you will be able to access the services which are provided by them, and these services can be accessible or used by anyone who has internet access and an account. They can access them and they can use their services, which means these services are shared by many users. That is public cloud. For an example, uh, we have a public bus and anyone can buy a ticket and use. Similar way, we have an AWS or any cloud provider. We can create an account. We can use their services. That is what public cloud. And now, if you see private cloud is like used by only one organization. Used by one organization. For an example, I'm saying, or used by uh, secure. Used for more secure, I can say. Used for no, this is enough. Used by one organization. Let's make it simple. Private cloud providers are these are used by uh, one organization. Like we have we in public cloud we can see whoever has the account, they can access any services which are provided by the services provided by the cloud provider. In private cloud, only the specific person can use their services. Now, private cloud is having their resources, and only that organization or the people in that organization can only access. No other people can access. Okay. Uh, we have seen an example like Busner. Now, if you see, you have a car and only your family uses that car. That is private. Similar way, we have an organization and that organization has a private cloud, and that private cloud is used by only the people in that organization. That's it. Now, when we comes to hybrid cloud is combination of both public and private. Okay. Now, combination of both public and private. Now, in some sectors, they want some data to be publicly accessible, and in those places, they will uh, use the public cloud, and in some places, they want to restrict the access. In that scenario, they will use only private cloud. We can take bank as an example. They have some some specific resources or services allowed to use by the public, which are in the public cloud. I mean public cloud, and they do have some private resources, like they have some security reasons and security uh, servers or any other private servers or something like, and they don't want to expose it to public, so they will be having only private network or private cloud. Hope you got it. Do let me know if you have any questions in comment box after uploading this video. Cool. Hope you got it. Just a recap before we moving. We have seen what is cloud and then what is cloud computing. Just cloud is like storing the data or using the things like software and servers over the cloud. We have seen an example like drive. When our phone is out of space, we will move our photos to drive, and this drive is it is a service. Just for an example, say it as in a service which is provided by the cloud, and the process of using the service is called as cloud computing. These services are provided by the cloud providers. Cloud has services. These services are provided by cloud providers. Cloud providers are AWS, Azure, GCP. These cloud providers has deployment models: public cloud, private cloud, hybrid cloud, and we have seen what are they. These are the things we have seen. Cloud providers. Cloud providers are public cloud, private cloud, hybrid cloud. Cool. We have seen cloud providers as well. Now we will see cloud service models. Now we have cloud providers and deployment models. Now we will see cloud service models. Okay. Now if you see cloud service models, we have uh, three types. Before moving to that, let me give a small about cloud service model. Uh, just let me open this tag. Before that, let me write cloud service model we are seeing now. Cloud service models. Okay. We are seeing cloud service models now. And the cloud service model defines what level of service the cloud provider is offering. Okay. We have seen what is cloud, and we have seen services, and these services are provided by the cloud providers. Cloud providers has three types of deployment: public cloud, hybrid cloud, private cloud. And now they have service models. Okay. And these service models are the level of services the cloud provider is offering. These cloud providers offering the services, and what level of services they are offering. They have what level of services, I mean what level of services the provider is offering. They are cloud service model. Okay. Let's make it here. Cloud service model. What it is defines what level of service the cloud provider is offering. Cloud service models defines the level of services that the cloud provider is offering. Okay. Now this is what we have. In earlier days, we have on premises, which means everything everything like servers, I mean OS, middleware, servers, running, storage, networking, application, everything is on the on-premises. Which means, let's say, which is in my local computer. On-premises in the sense, not in cloud. It is only in our local machines or in our particular place in our on-premises. Okay, everything can be managed by on-premises in our organization or in our on-premises. Okay, now the cloud provider is providing us three main models, service models. Okay, the cloud provider is providing three main service models. They are IaaS, PaaS, SaaS. They are IaaS, which is infrastructure as a service. Infrastructure as a service. Then we have PaaS, which is platform as a service. Then we have SaaS, which is software as a service. Okay, we have cloud providers and then cloud service models, which is which defines what level of services cloud provider is offering. They are of three types, which is IaaS, PaaS, SaaS. IaaS means infrastructure as a service, PaaS means platform as a service, SaaS means software as a service. Now, if you see here, this is a diagram. You can verify this in the internet as well. I mean, you can search a cloud service model, then you will get more information. In IaaS, these are managed, the application data runtime middleware OS is managed by you, and virtualization servers, these are managed by the service, and these are delivered as a service. Okay, in infrastructure as a service, the this the provider provides the virtualized hardware, which is computing resources, storage, and networks. If you see here, virtualizations, storage, network, and computing servers. These are managed by them, and we will only manage operating system and our application. We will manage. Okay, and then the provider will take care of the physical hardware and virtualization infrastructure. In IaaS, we will manage application data and OS, and the rest of the things like networking, storage, virtualization, all can be managed by the provider. And if you for an example for IaaS, we have discussed about AWS, right? In AWS, we have EC2, which is a virtual machine, and in Azure, we call it as a VM that can be taken as a IaaS, where you will be choosing OS and data application, all can be managed by you, and the storage, service, networking are provided by the server, provided by the provider. We can consider that as an example. And when it comes to PaaS, which is platform as a service, uh, it will platform where you can build and deploy applications without worrying about underlying systems. Okay, now if you see here, application and data is managed by you, and rest of the things like OS, runtime, servers, storage, everything can be managed by the provider, and these are delivered as a service. In IaaS, virtualization service, these are delivered as a service. You will manage the above things. In PaaS, application and data are managed by you, and rest of the things like OS, server, storage, networking, runtime, everything can be delivered as a service and managed by the provider. I can say, like, instead of manage, I can say like it is delivered as a service by the provider. And then we have software as a service. In software as a service, it will provide a fully managed software application over the internet. You interact with the software, and it's like you interact directly with the software. no need to manage infrastructure at platform. If you see, for an example, we have Gmail. We just install Gmail application. We will log in and then we will use everything like sending email, receiving email, deleting emails, everything. Now we are getting Gmail as a SaaS product, software as a service, and we are using it. And what application data, everything can be managed by the provider, and it is delivered as a service. That's how it is. Hope you understood. This is what they are. And then what else we have for today? That's it from my end. We have seen what is cloud, cloud computing, cloud providers, cloud service. Cool. By this, we'll conclude for today. And in our tomorrow's session or our next session, we will see most important topic, which is software development lifecycle. Then we have waterfall model and agile methodology. These are most important topics we'll be covering in our next session. Hope you understood the lecture. If you have any doubts or something like, you can always feel free to drop a comment. And again, I'll be creating a folders with readme.md and the contents which we are discussing in the each folder. Like today we have covered session 1. I have created a session 1 folder and I updated the topics which we discussed today in readme.md. And today, as a part of our AWS Masterclass series, we will be covering our session 2. Let's have a look into it. In our previous session, we have completed introduction to cloud and what are cloud providers and difference between cloud and cloud computing and cloud deployment models, and also cloud service models we have completed. And today in session 2, we will be covering most important topics for a IT guy, which is not only for DevOps engineer, but also they are useful for all the streams. The session 2 involves software development cycle and waterfall model and agile methodology. We will cover these 3 topics today. Let's begin. First, we will see SDLC, which is software development lifecycle. We'll see first thing SDLC, which is also known as software development life cycle. Cool. Let's keep it here. And in software development life cycle, we will be having multiple phases. Before that, let's see what is SDLC. In general, software development life cycle is a structured process and that defines the steps involved to develop, test, maintain the high quality of software. Okay, and in simple words, we can use SDLC to develop a software. Okay, and the stages which are used in software development lifecycle we'll be seeing further. Let's begin. In software development lifecycle, we'll be having multiple phases, and most of the organization will have 7 phases. Okay, and let's me make a diagram for you. Just a moment. Okay, let's take this. Oh, yeah, this is fine. What we have discussed in SDLC, we have 7 stages, and they are like, if we consider this as one, why it came there?
Just bear with me. Let me prepare a diagram for you. I'm just making things easier. And this is okay. Let me move this here and this here and this. Now it will be nice. Cool. This is fine. Okay. What we have discussed, SDLC is a structured process to uh, develop, test, and maintain high quality software. Okay, in SDLC, we will be having multiple phases, and in organization, if you want to build a product, or if you want to create an application, and these phases are, this is the structured process, and this defines the steps to develop, test, maintain that particular application or software, whatever it may be. Okay, and this is called SDLC, and in SDLC we have the first thing, which is like requirement gathering. Okay, where it is, let's keep it here. Requirement, why it's coming in that way? Requirement gathering or analysis, you can call. Let me take it as analysis. Cool, this is fun. The first phase involves requirement analysis. In For an example, we are in a IT company. Let's assume we are in, our organization name is A, and we have a client which is B, and our client came to us, and he wanted to have a application for his e-commerce or any other. uh, then what we have to do, first thing in our SDLC, software development lifecycle, the first thing we have to do is requirement analysis. Okay, we will be having meeting with the client B. We will understand their user needs. We will understand the user needs, and we will see what requirement they are expecting, and what are their expectations, and how they wanted to have the UI, and what is the main agenda for their application, and all those things we will gather. Okay, and then what we will do, we will prepare a document, and it depends. In every organization, they will take an approval via email. They will have some documentations, etc. And after gathering in analysis or requirement analysis or details, we will be having complete information, like what are the client expectations, all those things. Okay, and once we get these things, after we are getting these details, after we are getting the required analysis, we will move to planning. Okay, planning. The next phase is planning. In first phase, we received what their expectations, all those things, and in the second phase, we have to plan. We will be having development team, testing team, design team, uh, maintenance team, all those team, and the organization, our organization will be having a meeting internally with our team, and based on the requirements we gathered in the first phase, we will plan the timeline of the product, and what are the resource we need, and what are the cost optimization, all those things we will be taking care in the planning step. And again, we will be having documentation, and we will be getting approvals, all those things. And after getting plan after completing the planning, we will be moving to design. Okay, we in first phase we gathered information. We had a meeting with our stakeholders along with the gathered information, We have done planning. We prepared cost optimization, I mean cost estimation, and what are the resources we need, by which timeline we can complete. In resources, in the sense where we are going to deploy, or multiple things will come. And after completing the planning, we'll be moving to design. Now the design team will start creating the architecture and database schemes and the UI, what the UI the customer has agreed in the requirement analysis, and after planning we will be providing and we'll be taking confirmations from them. Then we will be designing the tool. The developers or whoever the respective team, they will be designing the architecture and preparing the code and the all the information they will be having. They will create the architecture and they will see what UI mockups, so and everything can be done. Now, after planning and design, the development team will start actually working on the code. They will start writing the code. Okay. After the design, what we have? Development, coding, or whatever it may be. This is where it comes. Now we have an idea how the design looks and what is the architecture we are going to perform. Everything we designed, and after design, the development team will start working on the actual program code, and they will write code and they will perform the everything based on the requirements we gathered and the planning we have done, and the architecture which we are going to perform, which we have committed. All those things, uh, based on those complete information, they will be developing a code. The development starts and they will be writing the code. And after the completion of code preparing, they will test it. Testing starts. Now the testing will uh, in the testing, the appropriate team, testing team, or whoever the assigned person, will ensure the software work as expected without any bug fixes. Okay, I mean without any bugs. The developers or the respective person will be performing the code, and then after completion of the code, the tester or the testing team or the assigned team will be testing the code, and they will ensure there are no bugs. And after the completion of testing, they will be deploying the code. They will be deploying it. Deploying. They will be deploying the code to users. Okay, and users, the application or the code which we committed is available to the user, and they will be testing it. The users will be using the application after the completion of deployment. And after deployment, what we have to do? We have not done yet. We have on the last phase. Let me keep it here. What we have after that? Maintenance. Maintenance. This is really crazy. Maintenance, and then again, this is the cycle. Cool. These are the phases involved in software development lifecycle. Okay, hope you got it. And just as a recap, uh, software development cycle is also called as SDLC, and it is the structured process that defines the step-by-step process to build an application or to develop or test and maintain high quality of software. And what are the phases involved in this? First phase, requirement analysis or requirement gathering. We'll be having a meeting with our client, and they will be explaining what the requirements, like what are their expectations on the tool and why they wanted to use their tool. All those information we'll be gathering, and once it is done, we'll be having planning with our team, and we will prepare timelines and where we are going to deploy, what are the resources, and what is the cost estimation of we'll be calculating. After that, the design comes into the picture, and they create an architecture and everything. Design related information can be done over there, and after the completion of design, the developers will start writing the code, and everything can be done. And after the coding, it will be moved to testing. Testing will be the respective person will ensure there are no bugs and everything is working fine as expected. And once they confirm, we'll be moving it to deployment state. And once the application is deployed, it is publicly accessible to the users. And after the successful deployment, uh, it again keeps on maintaining. I mean, we have to maintain the application. We have to see any users reporting bugs or something like. That's how the SDLC. Hope you understood the SDLC cycle. Cool. Now we have another thing to discuss. Now we'll see model. Waterfall model. Let me keep this here. Waterfall model. Okay. And in waterfall model, I can tell you, like, it is a very traditional model, and it is the first SDLC. The waterfall approach was the first software development lifecycle model and used widely in software engineering to ensure success of the project. Okay. Initially, we were used to use the waterfall model, and in waterfall model, the whole process of the software development is divided into separate phases. Okay, again there are multiple phases, we'll discuss into it. And in this waterfall model, the outcome of one phase acts as the input of the next phase. That is a major thing. Cool, you got it, what I mean to say. Let's see waterfall model first. We'll be we discussed we have multiple phases in the waterfall model, right? And before that, let me give a short overview. The waterfall model was introduced by Dr. Winston Royce in 1970s. Okay, introduced in 1970s, and it was the one of the first SDLC model. Waterfall model is the one of the first software development lifecycle model. That is also another point. And then it is adapted widely because of its simplicity and structured process. And now it is but however it was less flexible compared to the modern approaches like agile model. Before moving to agile, we'll see waterfall model. And as I mentioned earlier, waterfall model was the one of the first SDLC model. And in this waterfall model, the outcome of the one phase acts as the input for the next phase. And let's see this. Same again, we'll be having multiple phases. First phase is requirement analysis or gathering. Will be, as discussed in the SDLC software development lifecycle, we will be gathering the information here. Yeah, let's keep this thing. It's very big here. SDLC. And the second thing is in requirement analysis, we'll be gathering all the requirements before we developing the products, and after that we will be designing design we'll create architecture, and in design what we'll do, we'll create architecture and database scheme, again the UI, everything. And once the design is done, what we'll do, the developers will start writing the code, implementation we can say, implementation or coding. Here implementation or coding comes, and after implementation and coding, the testing comes into the picture. Testing, after testing, deployment will come. First let me write the phases, then I'll give you the one important line. Testing, after the deployment, and we'll be having testing, deployment, and then maintenance. What we have? Maintenance. Wonderful, we are done. See, in waterfall model, as we discussed in software development life cycle, and the waterfall model is one of the first software development lifecycle model. Okay, and in the requirement analysis, we'll gather all requirements before we proceeding to the development. And in design, we will create architecture and we will create database schema. Everything can be done here, UI design and all those things. And in implementation, will the developers or the concerned team will be actually working on that by writing a code. They start writing the code. After completion of writing the code, the testing comes into the picture, and after testing, deployment comes into the picture, and after that, maintenance. But here the crazy thing is, we, as I mentioned earlier in my beginning lines, what I have mentioned, the outcome of one phase is the input of next phase. So here we'll be gathering the information to develop uh, a product, correct? And all the detailed information or requirement analysis are documented, and they will be taking an approvement, and after this phase only the design starts. And in the design, the specification from first phase we'll be getting, and the system design help in hardware system requirements, all those things will be gathering, architecture and everything. After that, the implementation starts. Right now, once we committed to the design, we cannot go back to the design after coming into implementation and code. Okay, let me put it to you again. The requirements is the outcome here, and the outcome of this requirement is the input of this design. Okay, and the outcome of the design is the input of the implementation code. So we'll be taking the outcome of design, we'll be writing the code. Now if you want to make changes anything in the design, then it is not possible, because we cannot go up and create the design again. This is very tough and hectic and cost consuming as well. If the and after implementation and coding, the outcome of this implementation coding will be the input of the testing. And after completing the testing, and if we see any bugs or something, like, we cannot directly go back to the code and do all those things. Again, it is time consuming and it will take more time. And we have to be 100% sure before deploying the product, because once the deployment is done, we cannot make changes. And if you see, the reason why we call it as a waterfall model, it is like a water, if you consider this as a water drop, it is falling, it is dropping from step by step, right? That is why I have drawn this point, diagrams. And after everything, we cannot go back to the previous steps. That's how waterfall model works. Hope you understood. If not, put a comment in the section after uploading the video. I'll try to answer your queries or try to explain more on this. And one more major thing is, it is not suitable for complex projects. Cool. Remember, waterfall model is like waterfall, and after the first phase completion, the result will be the input for the next second phase. And once we get into second phase, we cannot move back to the first phase. Okay. And the last thing I wanted to discuss here is agile methodology. Agile methodology. Let's keep it here itself. Let me make it a 24. This is fine. Now we'll look into agile methodology. And in agile methodology, the process is like uh, it is taken to sprints, like small task, I can say in simple words. And in agile, it believes that every project every project needs to be handled differently, and the existing method needs to be tailored to the best suit of the project requirements. And in agile, the task will be divided into sprints, or divided into time boxes, or like small time frames, I can say. And if you see here, I'll make a diagram for you again. In the definition of the agile is an iterative and flexible software development lifecycle model, and where development is done in small increments, in sprints, I can say, like, and feedback is continuously incorporated. And again, how it works, same process will be, but it is in sprints here. Okay. The in we have seen what is software development lifecycle and what are the process involved. Then what we have seen waterfall model. In waterfall model, what we have observed, it is not suitable for complex projects, and it is the first uh, uh, outcome of the first process will be the input for the second phase. And once the second phase start, we cannot go back to the first phase. And it is really, if it required to go back, then it is again time consuming and cost consuming, we have discussed. And the steps also we have discussed in agile methodology. To avoid that scenarios, they have made the they have made a methodology, and where the projects are divided into small parts or small sprints, and the software is delivered incrementally with continuous feedback. Okay. And just to brief, in 90s, I believe 1990s, software development needed faster, more adaptable way when compared to waterfall model. Software development needed a faster and more adaptable approach than waterfall model. Okay, let me keep it this side. Okay, let's move this a bit, and now let's keep it here. Waterfall model, and in 2001, 1919, we required a more faster and adaptable approach than the waterfall model, and in 2001, 17 experts created the Agile Manifesto, introducing Agile principles, introducing Agile principles. Okay, and now if you see, Agile is the most widely used methodology in most of the IT companies. Agile is now the most widely used methodology in IT companies or IT sector, I can say. Okay, methodology in IT companies. Now let's see what are the key principles of the Agile methodology. And here, customer collaboration is more important. Customer collaboration is more important, and then we have to respond to the change over following strict plan. If there any change, we have to respond to that, and then delivering the work software very frequently, and we'll see individual or teamwork also required. And let's get into the planning. Again, let me take the same shape here, where it was. This is this is nice. And we have planning here. In Agile methodology also, planning is required. Yeah, planning is important. And in planning, what we'll do, we'll select the features for the first sprint. If we have 10 features, we can consider in first sprint we can release 5 features or something like. We'll be selecting the features for this first sprint, and after that sprint we will prepare the design, prepare simple designs. We'll prepare simple design for chosen features. Here we'll select uh, features for the sprint, and we'll prepare simple design for that sprint, and then we will develop the code for those sprints, and after the we will be testing, and after testing delivery of the or delivery release, I can say delivery or release of the software is done, and then feedback or review, I can say. feedback and review happens, and then again the line goes on. Okay, let it be. In as I said, we'll be having multiple sprints. In we will choose the planning and the design everything as per our sprints. And in first sprints we'll be delivering few options, and second sprint we'll be delivering few options, and it goes on. And if you see, in sprint one we can design login and registration of that particular application we can do. And in sprint 2, product search and cart, if you taking a example as an online shopping app, we can just see. Sprint 1 we can use login registration. For login registration everything again starts. For login registration, planning is done, simple design is done, development is done, testing is done, delivery is release, everything goes on. Again in sprint 2, product research goes on. And in sprint 3, payment gateway, sprint 4, order tracking, everything goes on. And with agile, customer get working features early and frequently instead of waiting for the entire project to finish. That's why agile is very famous. Hope you understood. And if you have any queries, anything, feel free to drop a comment in the channel. I'll explain the scenarios again in brief. I see most of you guys are watching the videos but not subscribing. I request you all to subscribe and share it with the people who are learning, who are interested in DevOps learning, and who are interested in the course like AWS, are learning, looking to learn cloud. And in our next session, session 3, we will be starting AWS course. These two sessions are like fundamentals, I can say. Before learning any cloud, you have to understand what is cloud, who are cloud providers, what is cloud computing, what are deployments, what are service models. And after that, you have to know what are the SDLC, software development lifecycle, and what were the waterfall model has done, and what was agile methodology is doing or agile model is doing. These things you have to know. And by this video I can conclude we have done enough information in the two sessions, session 1 and session 2. And in the coming video, session 3, we'll be seeing how to create an AWS account, and we will be seeing introduction to AWS Console, and then we will setting up IAM user and permissions. Then we'll see what are the AWS regions. And as a part of our AWS Masterclass series, today we will cover session 3. I'm preparing the GitHub repos and the uh, content details. I mean the topics which are covering day to day. I am preparing the notes for them as well. You can refer to the readme.md files for more info. And in our last session 2 video, we have seen what is software development lifecycle and what is waterfall model and agile methodology. In this video, in session 3, today we will see how to create an AWS account, and we will have an overview of AWS console, and at last we will see IAM, how to create an IAM user and set permissions, and we will see what are AWS regions. So let's begin. To create an AWS account, you can just log into aws.amazon.com. You can just click on create account, and upon clicking on create account, it will ask for your email addresses and full name. Is it for personal or professional, and it will also ask you to verify your mobile number. Just follow the steps, and go through the process. You will be having a free trial account. Since I already have an AWS account, I am not going to
Cool.
create this for now. I am just logged into my AWS console, and now once you create your AWS account, and you will be able to log into the console, and you will see this type of interface. And this is the main dashboard to manage all your AWS services. And in the top here, it is a search bar, and you can search for any resources. For suppose to create an virtual machine, we can use EC2. EC2 is the name of a AWS services to create a virtual machine, and it is Elastic Compute Cloud. And we can click on launch instance, and we can proceed further creating an instance. And then again, uh, to get into any other service, you can just click on S3. It's a S3 bucket. We'll come into it later in our next coming videos. And you can also view all the services here, like recently visited one. Everything can be seen here. And your billing details, cost management, all the information can be seen in the AWS console. And currently we are with the root user, and you can customize your dashboard as well. And now if you want to create, I mean basically, uh, when we log in with our email account, we will be in a root user. And for best practices, we I recommend, I mean, we will be creating an IAM user, and we will be assigning them the particular resource uh, permissions, and we'll be working on it. For suppose, as an administrator, I'll be having permissions for each and every resources. Now, if you want to have user to be restricted to particular services, then you can create an user, and you can assign particular roles and policies for that specific user, so that they won't be able to access other services, just to avoid any user mistakes, like deleting other user data or something like. And now we will be logging into our console, AWS management console, via IAM users. And to create an IAM user, just search for IAM. If you click on here, this is our IAM dashboard, and this is a IAM services, identity access management. And okay, let's create a user. And to create a user, you have to click on create user and give name as group. Let's say it as group, and click next. For now, just create a user without any policy, something like next. Tags also we don't need for now. Good. Now you have created a user with name group. Let's click on the user and see, he do not have console access. Okay, and no policies has been assigned to this user. Let's have a password for this user. I am enabling access. Let me download the CVV as well. Now the user has console access without MFA, and we also set a password for this user. And to log into this user, just copy this URL, and let me open another browser. Sorry. AWS console login. See, we have to log in as a IAM user, and for that, just give a moment, we need some credentials. Account ID it is asking. IAM user, and copy the account ID. We will be having account ID here, 3317. Okay. This is our account ID, and IAM username. What was our root, and password we have to enter. Now just sign in. Not now. See, now we have logged in with a IAM user, which username is root. You can see the username here, root. And he will be having restrictions. See, access denied. And if you search for EC2 instance, if I click on launch instance, upon entering all the details, it will tell me you do not have access. And now if I create a VPC, if I go on this, Sydney, I mean, if I want to create a VPC, just click VPC, just give name as VPC, and CIDR block is 10.0.0./24 default. And if I click on create VPC, it will tell me an error. There was an error creating. Why? Because I haven't provided any access or any permission for this user to create a user. That is why I'm experiencing these errors. Now, if you see here, permissions, I don't have any. Okay. Now, let me add permissions for this user. Add permissions. Attach a policy directly. I want to give him a S3. Let's go with VPC only. VPC we have to give multiple. Let's VPC full access. VPC full access, and I'll also provide him S3 access. Amazon S3 full access. And next, and add permissions. Now this user has full access to S3 bucket, and this is the permission. You can write it as well directly, and to the AWS VPC as well. Now let's go back to a previous one. See, now if I click create, it has to create. See, VPC successfully created. This is how it works. And now if I go to S3, I will be able to create a bucket. See, I am having option to create a bucket, and I can give name as bucket1. Let's keep everything as it is and click create bucket. Bucket name already exists. It should be globally unique. -PR. Okay, this also exists. This should not be. It is telling a invalid character. If you see now, I have successfully created a bucket. Now, let me delete this bucket. I have deleted bucket, and now I have previous permissions were and I'll remove this policy, Amazon S3 full access policy, and I'll remove now he has access to only VPC. Now he won't be able to create any bucket here. Let's give a random name, and if I click create, it won't. See, after creating bucket, you can upload fail to create bucket, permission is required. That's how it happens. This is the reason, I mean, this is one of the reason why we create IAM users, and I will also recommend you to create an IAM user after you are creating your first AWS account, and it will be free for 6 months, I believe. Earlier it was 12 months, but now it changed to 6 months. And now let's see regions. These are the regions, okay? And AWS data centers are spread across the world. These are the data centers, are they are spread across the world, and each location is called as a regions. Now if you see Mumbai, which is AP South 1, this is a region. And similar way we have Europe and US East 1, East 2, many. And inside this each region there are multiple availability zones, and they are uh, separate data centers connected with high speed network as well. And when you launch an instance or a database, it is always best to select the region closest to your nearest location, I mean your specific region or the specific to any user, so it will reduce the latency and it will improve performance. If you see, now I'm in India, so which is nearer to me, Mumbai or Singapore, so I can select Mumbai just to avoid any latency, something like this is how we will be using AWS account. And let's delete our VPC as well, VPC, and whatever resources you may create, just delete them as soon as you are done with your work. If not, it will charge you and the building will be done for the hours. Okay, VPC has been deleted. Now let's log out a root user to our users and delete this user as well, because I don't want to use this root. Confirm, delete user. Let me delete this as well. I'm not going to use this anymore. Cool. This is how we will create users and give permissions. Just to recap, what all we have done, we have come to know how to create an AWS account, and after AWS account creation, we have seen what are the resources and how to access the resources. And after that, we have seen how to create an IAM user and give specific permission to that user. And this is just for you to log in as a IAM user instead of root user. We have seen that as well, and later we have seen what are regions and what are the availability zones, and how we select regions when we are creating resources. And then we have seen how to add permissions to a user or attach a policy to the user, and we have also seen how to remove a policy and how to delete a user and how to delete the user from the root user as well. We have seen all those things, and in our coming session we will be starting the actual series. I mean, these are like basics, and earlier we have done session 1, session 2. These are the basics. And today we just seen what is AWS console and etc. And in our next session we'll be seeing introduction to VPC and what is VPC, what are subnets, what are route tables, internet gateway, NAT gateways, and elastic IP security groups. Everything we'll be covering in our upcoming sessions. Today we will learn VPC concepts. And in our previous session, we have come to know how to create AWS account, and we have seen AWS console overview, and we have seen IAM permissions and AWS regions. Today, in session 4, we will cover introduction to VPC and how to create subnets, what are route tables, how to create them, and why internet gateway is used and NAT gateway is used, what is elastic IP, and at last we will see what are security groups. To begin, let's start. And before starting that, I just want to give an overview. What topics we are going to learn today? VPC. Why this game? VPC we are going to learn, okay? And what is VPC? VPC is, its full form is Virtual Private Cloud. It is also called as VPC, okay? And it is a logically isolated section of the AWS account where you can launch easy to instance, and you can manage the network within the AWS account. So you will be managing all your network information in the VPC. And then we have subnets. Subnets. Then the subnet is a range of an IP addresses within your VPC, okay? And in subnet we have public subnet and private subnet. We will look into them. Just as an overview, I'm going through all these things. And we have route tables. Route tables. It contains route table contains the rules that determines how the traffic will flow. And then we have internet gateway, which is internet gateway. Internet gateway is it will allow communication between the resources. It gives the internet access. It gives the internet access to your resources. Okay. Then we have NAT gateway. NAT gateway is like it allows the instances which are in private network to connect the internet, which means NAT gateway will allow the missions which are in private network to access the internet. And then we will discuss elastic IP. Elastic IP is nothing but public IP, public IP address. Cool. And security group will look into it at last. Okay, let's begin. And to begin with, we'll go to our AWS console. Let's assume this is our VPC. Before that, let me draw a diagram for you. This is our VPC, and in this VPC, before that we need this is our VPC, and inside this is our VPC, and inside this, let's assume we have this is our VPC, and inside this we have a public subnet and a private subnet. Let's name it as private subnet. This is our private subnet, and this is our public subnet. Okay, let's remove this. This is our VPC. We have public subnet and private subnet, and in this private subnet we need to have internet routes, internet gateways, NAT gateways, and route tables as well. Let's change this color to this one. We'll change to this one, subnet. Public subnet. Or let's keep it as subnet. And same here as well. Let's name it as subnet. Okay, now we will be having, we have private subnet, public subnet, and this I'll explain you that later. And let's assume let's give internet gateway as well. Let's take this one. This is a internet gateway. Let's keep this color. IG is internet gateway. Okay, internet gateway, and then we need to have a NAT gateway as well. Let's take this one as a NAT. NAT gateway. Okay, and we need to have route tables. So let's keep this here, and we need to have route tables. Let's give that as well. Let's take this one. RT is route table. Okay, cool. Now this is what we are going to do. We will be creating a VPC, and then inside VPC we'll be having public subnet and private subnet, and then the internet gateway, NAT gateway, and route tables. Cool. Let's begin. So this is our AWS console, and in our console, we to create a VPC, either you can go to services and search, select VPC, I mean from here, or you can also search for VPC and click on this VPC. And after clicking this VPC, we will be seeing a dashboard which explains VPC, NAT gateways, everything. Click on this VPC, and this is by default AWS will give you a VPC account. Okay, and to create your own, click on this create VPC and give a name for your VPC. I'll give pr-test-vpc, and this is the CIDR block or the IP range. Let's give 10.0.0.0/16, and then I don't want to give a tenancy for now. Cool. These are the tags. Now just click on create VPC. See, you successfully created a VPC. Wonderful. So this means we have created this part. We have created our VPC. What is VPC? VPC is a virtual private cloud, and you can manage all your network settings. You can manage everything in that VPC network and everything. Now we have a VPC. Let's go back to this previous section like VPC. See, now we have VPCs. If you click on here, see, PR test VPC is the one which we recently created. Okay. Now, after VPC, what we need to create? We need to create a subnets. To do that, click on subnets. And these are the default ones. I don't want to go with this because we have recently created our own VPC. And click on create and then select our own VPC. Then in the name, give PR-subnet. Let's take this as a public subnet. Public subnet hyphen, I'll take 1A. Availability zone, it means it will give you the maximum, I mean, you won't be having any what I can say, the availability zone is like it will give you high availability, like you don't face any issues or network droppage or something. Like it will keep you your availability zone or your subnet always available and in a high availability. So we'll be creating we'll be selecting availability zone as 1A, and CIDR block, I gonna change this. This is our CIDR block which the subnet VPC we have, and this is the subnet CIDR block. I'm going to give it as, this is our VPC subnet which is public, and then I go with private subnet as well. PR-private subnet -1A, same. For availability zone, I have selected 1A. You can select multiple 1B as well, or you can give multiple subnets while creating this. Now I'll give the second subnet range. Cool. We have done public subnet and private subnet. Let's click on this. Wonderful. We have public subnet and private subnet. Now if you go back here, you can see you can feel like we have multiple VPCs, and if you are getting confused, we have a good option, wonderful option here. Click on this filter VPC, and we can see the VPCs which are available, and the VPC which we created is PR test VPC. So select on that, and then click on the subnets. You will see only that subnets. Now what we have created, we have VPC, we have created public subnet, private subnet. Next we have internet gateways, NAT gateways, and route tables. Okay, now after creating that, what we need to have, we need an internet gateway. Why? Internet gateway is used to give your resources internet connection. I mean the public resource, the missions which are in public subnet, they need an internet gateway, right? Internet access. That is why we are creating internet gateway. create internet gateway, and this will be unassigned to any VPC. If you see here, detach it. Click on actions, attach to VPC. In this, select our VPC, attach internet gateway. Cool, wonderful. So now we have VPC, we have subnet, we have created internet gateway, and we have assigned this internet gateway to our VPC. See, this is our internet gateway, and this is allocated to our VPC. Got it? Now we have route tables. You can select from here as well and select route tables here. This will specify how the routes, I mean how the traffic will go, and how the routes needs to be, which which route provides the internet and which route provides the access to certain ports or something. You can mention over there in routes. And in this we will create two route table. One is for public, one is for private. Public route table, and select our VPC, PR test VPC, and create route table. Now we have our public route table created. Okay, and we just created, but we haven't assigned or allocated anything, right? So to have our public route table to access the internet, click on the routes, click on add route. This will allow internet access, and then here select internet gateway, and in this select the one which we recently created and save changes. This will allow the machines which are in public subnet to have internet, and here we need to give the subnet. Which subnet? Public subnet. We have to select our public subnet and see. If you see here, we have public route table which is assigned to public subnet, and we have an internet gateway which is assigned to our VPC. Cool. Now see, we have public route table. Similarly, we have to create private route table. Private route table. Again, select our VPC, create route table. Okay, wonderful. Now in private route table, what we have to have? Private subnet. Click on this, select private subnet, save change association. Now in private route table, we have private route table. Wonderful. Now we have added our private route table, and we need to create an NAT gateway. Why? To have access to, it will give access to our private subnets to access internet. Click on NAT gateways. I don't think we created just any. Yeah, create NAT gateway, PR-NAT, and select subnet. What subnet we have to select? Public subnet we need to select. Why public subnet? We are getting access from the internet access from the public subnet. So select the public subnet, NAT gateway and public subnet. Here we need to create an elastic API. Why? Public API we need to have, right? And this needs to be assigned to NAT gateway. So to do that, I'll just allocate a random one, or you can create one and assign here, and then create NAT gateway. If you see here, NAT gateway is created and a public API is assigned to it. Now this NAT gateway, now we have to go to route tables. Okay, we have public route, private route, and in private route we have added private subnet, and let me open this private route table. If you see here, only subnet association we have done, and we do not have any routes. But to have internet access to private subnet, we need to have a route, and that route needs to be click routes and then add it, then 00, and then from where it has to get, from NAT gateway, and where this NAT gateway is assigned, public subnet. Okay, and then save changes. Cool, we have now NAT route as well. So this is how we can create public subnet and private subnet. So if you see here, we have created a VPC, and inside this we have public subnet and we have private subnet, we will be having missions which needs to be exposed to internet. They will be in public subnet, and their missions which do not want to have internet access directly, they will be created in private subnet. And public subnet, I mean, we'll be having root tables. In root tables, we'll be assigning public subnet, and we'll be assigning internet gateway to our VPC. Why we need internet from our VPC? So we'll be assigning that, and we'll be creating root tables. See, in root tables, public root table. If you click on public root table, it will give you root details. In public root table, we have internet gateway. Why we need internet access? Then we have public subnet. Okay. Similarly, we have private subnet. We have assigned private subnet here. For private root table, we have assigned private subnet, and in our roots, we have NAT, and this NAT is assigned to public subnet. From there, we will be having internet access to our private subnets. Cool. Hope you understood. Now we have security groups, and this is a part of VPC. We're done with VPC now. So what all we have done? We came to know what is VPC and how to create a VPC. And after creating VPC, we understood what is public subnet, what is private subnet. We came to know how to create a public subnet, how to create a private subnet. Then we understood how the internet access will be available within our VPC, how via internet gateways, and internet gateways assigned to our VPC because we need internet. And then we need to have root tables. Why? The root table will tell the VPC how the flow is, and in root tables we need to write routes, and that we have public root table for public subnets, private root table for private root tables, private subnets. And in public root table, what we have done, we have edited a rules, and for public subnets, what we need internet. So we have assigned internet gateway, and we have assigned public subnet. And for private subnet, from where we need to get internet, from the missions which are in public subnets. So we created a NAT gateway, and we have assigned that NAT gateway to public subnet, and then we have allocated a public IP. And in routes, we'll be going to private root tables, we'll be editing the rules, and we'll be having NAT gateway to the private subnets. Now I want to show you security groups. Security groups is the one of the important feature in EC2, I can say, because it will tell us what needs to be allowed into our mission and what needs to be blocked. Let me create security group. By default, we have some security groups. To create security group, you can just search for security group, and here click on create security group. We have to give our security group name. I'll give PR security group. Description we can leave, and we have to select our VPC. And here let me create this, then I'll show you the rules. Okay, for demo. Okay, we have created a security group successfully. Now in security group, what we'll be having inbound rules and outbound rules. What is, I mean, why inbound and outbound rules are required? Can anyone, like, because inbound rules will allow the traffic to enter into our instances, and outbound rules will tell what traffic is allowed to leave, I mean leave the instance which we have created. For suppose inbound rules, I'll create on edit inbound, and I'll add a rule, and inbound rule I can use TCP. Let's take SSH 22 custom. You can change this anyways. You can give particular IP address, or you can define your own my IP. You can mention custom as well. So I'll save this rule. See, now instance within the security group can access, and what I have mentioned inbound rule SSH. What SSH will do, it will give session access to you. I mean, when we create a EC2 mission in this security group, the SSH inbound rule will allow you to access the VM, which is in AWS. So if you do not have SSH rule in inbound, it will not allow you, which means we are allowing someone to enter into our instances, and that is happening because of inbound rule, which is port 22, and it is a SSH port. We can also have multiple ports for the inbound rules based on our requirement when we are doing any project. And for outbound rules, this will tell us what traffic we define to leave from our missions. Okay, SSH is allowing someone to access our workstation, and outbound will tell what needs to be go out from our instance. I can You can click on edit. We have all, so all, we do not have any restrictions on here. And if we want to have any restrictions for outbound, for like if we need to have any internet access to download any uh, updates or something, we can just have HTTP or HTTPS, HTTP, and then this I can say any, and then HTTPS, and then same I'll give any, because I'm leaving a traffic from a mission to outside. This is how we'll create outbound rules, and these will allow these will allow the traffic from these ports to go out from your instances. I mean, this will leave the request for 8443 will leave from your missions to the outside. That's how it is. And that's all I have for today. So just to recap, first we'll go with security groups only. Security group we need when we are going to create EC2, but since we are talking about VPC, I just thought of informing this as well, since it is also a security. We have to create, I mean, security groups, and then we have to give a name and click. Then after that we will be having inbound and outbound rules. We'll be providing inbound rules and outbound rules. Inbound rules means which we are allowing from outside to our missions. Outbound rules which we are allowing from our missions to outside. And then VPC, if I search here, VPC, this is our VPC, and it is a virtual private cloud, or you can say it will allow you to manage your network which you define in this region or in this VPC. And subnets we have created. Subnet is a range of IP addresses in your VPC. Okay, we have created a VPC, right? Which VPC? This one. And subnets is a range of IP addresses from this VPC. See here, this one. This is the subnets, and this is a range of IP addresses. And then we have seen route tables. This is our route table. We have public route and private route. We can see this one. We have assigned an add gateway to our private root table to have internet from the public subnet. Then we have public root tables for public subnets, and we have routes. That's one thing. You can click here. Same it will show. Okay. And then we have internet gateways, and this is assigned to our VPC to have internet. And then we have elastic IP. We have a private public IP which needs to be allocated to our NAT gateway, and this NAT gateway is assigned to our public subnet. Cool. That's it from my end. And if you want me to provide a complete detailed information on CADR block or subnet ranges and how the CADR block works and everything, if you want me to teach you, just let me know in the comment section. I'll provide a more detailed video on that. And hope you understood, and if you have any queries related to it, please comment in the video session once I upload it to video YouTube. I'll let you know more in detail in the comment section.
Today, as a part of our AWS Masterclass series, we will be continuing our sessions, and the last session we have completed introduction to VPC and how to create VPC, how to create subnets, how to create root tables, and what are root table, what is subnet, and what is VPC. In addition to that, we have also seen internet gateway, NAT gateway, and use of NAT gateway, and what is elastic IP, and why we use security groups. These all are included in session 4, and if you haven't watched it, kindly watch session 4 before moving to session 5, which is introduction to AMI. Today we'll be covering core concept of AMI, and we will also see how to create a EC2 instance and Linux instance on Windows and Linux, and we'll also try to create a custom AMI. To begin with, just let me give an overview. First, we will be discussing about AMI. What is AMI? AMI is Amazon Mission Image. Okay, the full form of AMI is Amazon Mission Image, and it is a template. It is a template which is used to create an EC2 instance. Hope you got it. And it also contains the information required to launch an instance. What is in what is AMI? AMI is a Amazon Mission Image, and why it is used? It is used to create a EC2 instance, and what it contains. The AMI contains the information required to launch an EC2 instance. It includes operating system, and if you want any application server, that also we can do application server, and root volumes, volume, EBS volumes, those also we can see. Let's say block device mapping, this all we can see. And now we came to know what is an AMI and what it contains. And the users of using AMIs, we can deploy, assume we have created a EC2 instance, and we have installed an Nginx server or any particular application on that. Sorry, and we can launch an identical server
images across our environment like dev, prod, staging. How by use of this AMIs we can repeatable deployment, we can say repeatable deployment. And the second thing why we use is for fast provisioning. We can deploy or provision a EVM in very fast way. And backup and distribution is like you all know, I believe. And we can also create a custom MI as discussed. If we have any data or if we have any application installed, with the help of AMI we can create a same image, I mean same instance, without spending too much of time. And we can also have options to create same OS as well. Let's get into our demo. And to create an AMI, or if you want to launch an AMI, or if you want to know anything about AMI, just search for AMI in this search bar, and you can see here AMIs for EC2. Let's see AMI catalog. If you click here, see here we can see all the available AMIs, and we have Amazon provided AMIs as well. This is AWS Marketplace, and these are community AMI. And if you have any our own created by us, then we can see them here. We have Amazon provided AMIs and Marketplace AMIs and community AMIs. Okay, and these are like Amazon AMIs are maintained by the AWS itself, and they have Amazon Linux, OS, and if you see here, these all are Amazon one. And in the marketplace we have servers which are provided by vendors, we can say, like vendor images, and which includes fees or licensing something. These all are available here. And community, we can see them here, shared by our community users or something, like we can share our AMIs, or we can see all of these things. So this is how we will see AMIs, and these are a quick start, like it will be a plain OS, fresh OS. Okay, and the best practice to select an AMI is like you have to know what OS you required and what OS you wanted to run your application. Based on that you can proceed. So if let's get into our demo part, let's create a I mean let's create an EC2 instance and see how it goes. So as of now, I believe you understood what is AMI and what are the types of AMIs. AMI is Amazon Mission Image, and AMI is used to launch an EC2 instance. As of now, you remember these things. It is more than enough. And quick start is like the AMIs available here are plain OS, and it will be like when you create a fresh OS, similar way it will be. And so let's create an EC2 instance and see. To do that, first we need to have a VPC. I hope you all aware of the VPC. If not, please watch our video on VPC. You'll get to know more on that. And to create a VPC, first you have to click on VPC, and you can select region based on your nearest location. Click on create VPC. We just create only VPC for now, and test VPC. Let's give it as a test VPC. And CIDR block, just let's go with 10.0.0./16. Let's leave everything as it is and create a VPC. VPC has been created, and let's create subnets for this. Subnet, we have to select our VPC, the one which we recently created, and we can give name as public subnet test hyphen public hyphen subnet and availability zone. Let's create our, and this is our CIDR block. This is will be our subnet CIDR block 10.0.0.0 slash, let's have 256. Yeah, and now let's create private subnet as well. Test hyphen private hyphen subnet. Let's select the same availability zone, and now 10.0 dot. Let's do one more thing. If not, we'll select this 2.0 and let's this as 1.0. Okay, now we can create both public subnet and private subnet. Both subnets have been created. Now we need an internet gateway. Hope you all know why we need an internet gateway. Internet gateway, create an internet gateway to get internet to our mission. Test hyphen internet gateway and assign it to attach to our VPC. Select the VPC which we created and attach internet gateway. Cool, wonderful, we have done. Now let's go to root tables and let's create only public root table because we are not going to create any VPC in private. Public root table hyphen public subnet, and let's select our VPC and let's click on create. Our root table will be created and subnet association. Add our public subnet and save association. Now then add root tables. Edit routes, click edit routes and add route. We need to allow internet from where we are getting internet gateway. Let's select the internet gateway which we recently created and save route. Is this the one we created? Yeah, wonderful, we are done with this. And we also need a security group to launch an EC2 instance, so better create that as well now itself. EC2, this one we need. Let's click on create security group, give name as same, test hyphen security group, and then description for demo. Select the VPC which we are creating, and now inbound rules we can let's add it now itself. We need SSH to get into that mission, and it is from anywhere. We can select source anywhere and then SSH. Then for Windows we need RDP, remote desktop. This is also from anywhere for a moment. And then we have HTTP to allow. Cool, we are done with inbound, and I hope this is not required. Okay, let it be, no worries. Of outbound we are allowing all, so that's great. Let's create security group. Our security group is also created. Now what we have to do, we need to create a EC2 instance so that you can understand how to launch the AMIs. Click on launch instance. Give name as test-ec2 hyphen. Let's create Linux one first. See, these are the AMIs which we are discussing. Okay, here you can see Amazon Linux, AWS, it was provided by AWS and Mac OS, everything you can see here, and you can search from the marketplace as well here. Now let's go with the Ubuntu. I have selected Ubuntu, and this is free tier. Ubuntu server 24.4 I'm going with, and here if you see tutu.micro, it is a free tier eligible one, so I'm going with that. You can verify how many CPUs, how many RAM, everything can be seen here. Key pair, this is the important thing. Key pair, what is key pair? Key pair is a key which will allow you to access the EC2 instance after creating. So let's name it as test-key pair. We'll be accessing it from putty, so let's set it as putty and create key pair. Once you click on create key pair, it will be downloaded into your machine. Okay, in this VPC settings, click edit. Everything will be default, so change it to one we have created. And we need public IP to access that machine, so we are enabling. We are selecting existing security group. This is our security group, and this you can leave as it is. Now this is the AMI image which we are selecting, and this here we can see AMI image details, what server and what volumes you are selecting, and here we can see the instance type. Okay, we are launching the instance. Let's go here, verify for a moment. Instance state is pending. Let's wait, it will check for two checkings will go on. Let me show you. Instance status check, it will check. See, it is initializing, and once instance status check is done, we'll try to access it. Before that, I'll also show you how to take custom image, AMI, everything once it is up. Here you can see create template from instance, create image. If you click on create image, it will create a image for your EC2 instance, the AMI which you are using. It will create that snapshot. If you click on template for instance, it will create complete OS related information also, it will capture. It's still checking. Let's see if we can connect. Instance is not in public subnet. Huh? What happened? Shit. We created in private subnet. That's what the mistake we did. So we cannot access it outside of our network. So let's delete. Demo -EC2 Linux, and we are selecting Ubuntu. We are selecting the same key pair, and we are selecting our custom VPC. Here it should be public subnet, not private. and then we have to enable the public IP to access our mission and select our security group which we recently created. Once everything is done, click on launch instance, go to instance, we terminated this EC2 because unfortunately I created it in private subnet, so I recreated it in public subnet here again. Meanwhile, let me show you. To create an image, if you click here, create image, it will ask for an image test-AMI and image description optional. This is the volume which was on the our EC2 instance. Create a snapshot of each volume. See, it is telling it will create a snapshot of the above volumes, and if you click on create image, it will create our image here. Currently creating AMI from instance. See, this is our AMI, our custom API, or we can say. Now if you want to create an instance directly from this AMI with the same applications and everything, you just select on that and launch instance from AMI. Click on this, it will directly select that AMI here and just provide these details again, and the AMI will be created along with the details which the AMI has, from which instance we have taken the details it will be having, and we will create from that. Now let's connect to the TC2. To connect to this EC2, we need a public IP of this EC2 instance. Let's click on this instance and copy the public IP. Let me open putty from my, and let me give the IP, and we need to provide the key here. Connection refused. Okay. See, we have connected to this mission. If you see here who, it will give you the response and host name, everything. So let's verify why we are unable to connect from the putty. What is our public IP? 3.46. See, we just verified our port is available, so just clicking on it, connect. We need our username details. For that, we can verify here. Username is Ubuntu. Cool. See, this is how we will access. What we did, we created EC2 instance with our custom VPC, and we have accessed it from my local machine, and I have also shown you how we access from the AWS console itself. Okay, now I will show you one thing. If I do ls, I won't be having anything here. So what I'll do, I'll create a directory. If I do ls, I have mkdir pr and touch groove.txt, thor.txt, thonos.txt, and I'll if I do ls, now I have multiple. So let me exit this. And now if you see here, what I'll do, I'll take a snapshot of this image, create image. Let me change this as custom image. That's okay. See, now I'm creating an EC2. I have created AMI, right? From this, now I'll launch an EC2 instance. I'll give EC2 second. AMI is already selected. Key pair, I'll select our key pair, and let's verify this VPC. VPC is selecting default, so I'm changing back to our one, and we need public IP. Select existing security group. We created, selected everything. Now I'll launch instance here. Now see what happens. It cannot be run. Okay, it's just because AMI is still trying to take. AMI is not yet generated. Diagnose with Amazon. AMI 0 is pending and cannot be run. Let's go to AMI. Let's see which state it is. See, it is in pending state. That is why we are unable to. Let's wait till it get available and then we'll create. We'll try generating again. See, now both shows available. Let's retry. It will get succeeded now. See, instance launch succeed. Now we are in EC2 second mission. This is our public IP. Let's connect from here itself. We just need to verify. I'll show you what it contains. Let's wait till it get into running state. We created this with AMI, which our EC2 instance has. This instance, we used this instance AMI to create the third EC2 instance. Okay, this instance, we use this AMI to create this EC2-2 instance, and now we are connecting this EC2 instance to see whether the files which you created are also created or not. Connect. Let's click connect. We'll get our window. Wonderful. Now if I do ls, I have snap. Let me go to snap. If I do ls, which path we created, that matters now. Let me connect to this mission, then we can see. We're in root, that is why we are unable to cd home ls. See, this is what happens when we use our AMI. EC2 mission is also having root pr thought.txt, and demo EC2 Linux is also having the same files. PR is a directory, it is also directory. So this is how we use AMI to create instance. We custom AMIs we can call, or see now how much time it taken. Initially we created we selected AMI and then we launched instance, then we created files. Now when we created a image AMI image from our existing mission, and when we use that AMI image to launch an instance, everything captured and all the files are available in the new mission as well. So this will reduce our time, and this is how we use custom AMIs. Hope you understood how we connect to EC2 instance by using PuTTY from our local mission and with the AWS console, and how we create everything you have understood, I believe. So this is how AMI is about. Now let's create Windows mission and let me show you how it works. Meanwhile, I'll terminate all these missions just to avoid cost. Okay, it will shut down and terminate. Now what we'll do, we'll create, let's see how to create a Windows mission. Let's give same test-wind for Windows, and you can select Microsoft one. See, free tier is eligible, and this is also free tier. No, I'll go with free tier here. This is fine. I have selected Windows 2019 base, and it is free tier eligible, and this is also free tier eligible. And keep here we have to create a new one. Why? Because the one which we created is for Linux. So let's create this keep here, win keep here, pem OpenSH. Let's create keep here. It will download in our mission. Wonderful. Now same again, we have created VPC, right? Changes, let's make it as public subnet and get public IP. Let's select our existing security group. This all are fine. Let's launch instance. It will select instance state and everything. Once it is done, we can connect to our mission. It's in running state. This was unable to connect RDP client. Okay, download this one and open this thing. Let's connect. We can directly connect, and we need to provide password. This is a fleet manager, instead of using RDP, we can directly configure fleet manager, and we can install SSM agent in this mission, and we can connect directly from this fleet manager itself. And for that we need SSM agent uh, powered on state. I mean, it should be running state, then only we can connect. We'll also cover this in our later videos. For now, we'll see what is AMI, how to create Linux mission, and how to connect it, and how to launch a Linux mission from the existing AMI, and then we'll see how to create a Windows mission, and how to launch, how to connect. Wonderful. This is how we connect to Windows missions via RDP. See, we can also select our custom passwords, but we need to get into it, right? So that's the reason. We can also write our policies while creating EC2 instance, and for this password, user details, everything. But for testing purpose, I just decrypted the password and just trying to show you how it works. Wonderful. Our mission is set up. This is how we create Windows mission, and how we can connect to it. Cool. If you see 189.22.224 Windows mission, 189.224, 189.224. That's it. This is how we create instance and we launch. Hope you enjoyed the video, and you understood how we create EC2 missions and what is AMI, everything. Just a recap. AMIs are used to create a instance, EC2 instance, and in AMI we have marketplace AMIs, Amazon managed and shared AMIs, and you can select AMIs from the websites. Okay, and later what we did, we created VPC. Why we created VPC? Because to launch any instance we need an VPC. So we created our custom VPC, and we created public subnet and private subnet, and then we created internet gateway and attached it to our VPC. Then we created route tables. We just created public route tables, and for public route table we allowed internet gateway, and we assigned public subnet here. Okay, this is what we did in the VPC side. And after that we are into security groups. Why we need security group? For inbound and outbound rules. For inbound we allowed 80 RDP. This 3389 is required to RDP sessions. Now if you see, we connected to a Windows EC2 instance which is in AWS via RDP from our local machine. That is happened because this port is allowed. And earlier for Linux machine also we have connected via PuTTY from our local machines. How it worked? Because SSH22 port is allowed. That's why it worked. And outbound we allowed any. And later we created EC2 instance. We selected the our own subnets and everything. Hope you understood. Let me remove this as well. It's delete instance, and then AMI also let me delete. We do not require them now. Cool, both have been gone. So by this I conclude in this video. We have seen what is AMI, why we use types of AMIs, and how to select AMI. Later we have seen EC2 instance and how to create EC2 instance on Windows and EC2 instance on Linux, and how to create custom AMI image. This we seen from Linux mission, and we also seen how to connect to this EC2 instance. And as a part of our AWS Masterclass series, today we will be covering session 6, and we will be seeing how to attach EBS Volume and how to attach it to EC2 instance on Linux missions and Windows missions. Let's start. First, we will go with the Windows missions, and first let me create an Windows mission, Windows EC2 mission. Then we'll attach ABC volume, and then we'll see how to. As we discussed in our previous sessions, to launch an EC2 instance, you have to click on EC2 and create instance, and then provide a name for the EC2. EC2 iPhone Windows iPhone PR. This is my mission name, and select the Windows AMI. If you are not aware of what is AMI and everything, you can watch our previous session. We have a brief overview and demo on AMI. And then let me select free tier if I have any. Full T2 micro, and I'll be creating a new key pair, and key pair is used to connect our EC2 instance. Windows hyper key. Let's keep it as open SSH only. Yeah, it is downloaded, and let me select our existing VPC. It is public subnet, and then we need public IP to be assigned to this, and let's select our existing security group. This is a root volume, and whenever we create an EC2 instance, it is mandatory that it is created with an EBS volume, and 30 GB is our current volume. And yeah, cool. Let's launch. Let's go to our mission instances. Once it's in powered on state, I'll pause here and I'll get back to you once it is in powered on state. Yeah, our mission is in powered on state, and let's connect to it. Click on instance ID and click on connect. You can see RDP client, and you can download this one. Download remote desktop. I already downloaded just in a while. Let's launch that mission and click on connect. It will ask for the password, and just once I'm logging with the password, I'll get back to you. Cool. I have connected to the mission. Let's wait till it launch. Great. Our mission is up and running. Let's
open run disk management. Cool. Now disk management is opened. If you see here, this is our C drive and this is the root MB, I mean root EBS volume, which we assigned while creating the mission. Okay. Now what we will do, we will assign a EBS volume to this mission and we will see how to make this as a file system and usable one. To do that, let's go to EC2 mission again and at the left side click on volumes and then click on create volume, and in place of create volume, okay, let me, and ensure the EBS volume which you are creating and the EC2 instance which you have already created are in the same zone, and which region, which one it is, let's verify. AP-South 1A, and the EBS volume should also be in same region. And now click create. A volume will be created. This is our volume, and click on volumes again, and if you see 100 GB, this is the volume which we recently created. Let's rename it WinVol-PR, and let me this is the volume which we now created, and click check mark this and click on actions, then attach volume, and then here select the instance which you recently created, and then this we can select any. If you see here, for Windows Dev SDA1 or for root volume SDFA2PR, we can, let's select SVDF and click on attach volume. Now go back to your EC2 instance, refresh, see 100 GB is also attached. Now we need to go back to our VM, I mean the EC2 instance which we created, and if you see here, let me maximize this. Here if you see unallocated, okay, and this is the one which recently added. Now initialize the disk and click OK. It was in offline state, so we made it online and we initialize the disk, and now click on new sample volume, and then we can follow this one, click next, and we can select multiple partitions. For suppose it is showing 102.397, right? We can make a partition of this into two drives. For suppose if you see in files, it will show you only C drive. C drive it is showing, and it is also root volume. And now in the partition of this place, if you select multiple times, and if for suppose if you say 50 GB here and 50 GB for E drive and 50 GB for F drive, then here two drives will be shown. One is for 50 GB and the other is for 50 GB. Okay, I want to go with the complete GB, and I'll just click on the next, and it is file system is NTFS and volume label is new volume, and let me click finish it, and it will start. Okay, let's verify now. See here you can see 100 GB volume. This is how we will create a EC2 instance with the root volume, and then again we can create a volume, new volume, and we can attach it to the EC2 instance, and we can allocate it. And the one thing I want to mention here is, now we have 100 GB allocated. Now if I here I can upgrade my 100 GB to 200 GB or 150 GB or 1000 GB, but I cannot downgrade it. Once I'm reached it to 100 GB, and if you want to go back to 50 GB, it is not possible. Why? Because we intentionally selected 100 GB for our use case. In that scenario, if you want to downgrade, it is not possible. We can only upgrade the storage. Hope you understood. This is how we'll do for Windows, and let's do it for Linux missions now. Let me terminate this mission to avoid cost. Okay, cool. The mission will be terminated now, and the respective volumes also will be deleted, I believe. Now what we will do, we will create a Linux mission, and then we'll see how. Now we will create a Linux mission with a root volume, and then we will attach a volume, and then what we will do, we will allocate that volume to Linux missions, and later with that allocated volume we will take a snapshot and we will attach it to a new EC2 instance, and we'll see what happens. Okay, hope you understood. Let's create a Linux mission. Linux PR. Let's go with Rocky. Do we have Rocky Linux here? Let me search. Rocky Linux. Yeah, let's go with 8. Yeah, I have selected the Linux mission, and I'll be selecting a new key pair. I want to go with POTI, so I'll select Linux PR key, and I'll create a key pair for this. Yeah, it is downloaded in our mission, and I'll change the default VPC to our VPC, and I'll select it to public subnet. We need a public IP assigned to this mission, and I'll select the existing security group. If you are not aware of these things, you can watch our previous videos. I have explained them earlier. And okay, default 10 GB. Let's take it 20 GB, no? Why, or else take 30 GB. Cool. Now let's launch our instance. Let's verify if Windows is terminated or not. Yeah, Windows is terminated, and the volumes does they deleted. Okay, let me delete this volume actions, and then delete volume, delete in use. Okay, now let's connect to our mission. Let's copy this public IP, and then let me take POTI session, POTI, and I need to upload the key here, Linux PR key, and click open. Go back to login screen. Let's open this one. Okay,
It seems to be connection refused. Let's click. Let me try again. SSH auth and the private key. I'll accept this one, and our username is root. Cool. I'm authenticated to it. Now I'm into our mission, which is crazy. It's got terminated. Why? Let me try to connect again. Some issue, I believe. Root. Okay, asking me to log in as a Rocky instead of root. Let's try. Cool. Now we are into our mission, and we have created our root volume, and let's verify whether it is available or not. And to do that, we can run a command lsblk. It will list all the available block or devices which are attached to this system. See, 30 GB is attached. Okay, now what we will do, as we did earlier, let's create a new volume for our EC2 instance. Let's take it as 100 and ensure it is also in same zone where the EC2 instance is deployed. Just click create volume, and on the 100 GB volume, just for reference, change it to Linux EBS and click on actions. It might still getting created. You see, it is creating. Let's wait till it create. Yeah, it is available now. Check mark this one. Click on actions, attach volume, and select the instance which we have, and let's go STF. Now click attach volume, and it seems our EC2 instance is attached. The yeah, if I click on this one and volumes, we can see two volumes attached. Okay, two volumes, and instance and storage. Here are two volumes attached. Now I'll go to our terminal again. Let me maximize this for you, and I'll clear the screen. Now if I do lsblk, if you see 100 GB NVNMI here, okay, and here this one NV last one N1 is a newly attached EBS volume, and it is in unformat volume. Let me see if I can increase the size of the text. Change settings, appearance, font. Is there anywhere font? Yeah, it's wonderful. Yeah, now we are able to see the newly attached volume, and it is in unformatted way. So now what we'll do, we will verify all the partitions once. Okay, let me clear the screen, and I'll run
sudo fd isk-l. It will show us all the available partitions. This is 30 GB partitions, and see here, this is our 100 GB partition. Okay, and now we confirm that our 100 GB partition is available. Now we need to check the current file system type for this volume. Okay, to do that, just copy this one, copy, okay. Once you copy that one and run command, which is sudo file -s, and then the name as it is shown here. It might differ for you, and verify what disk name is for 100 GB and run that only. Now I am checking the file system is already existed or not. If you see if you see here data, it means it is unformatted, and if you see any other thing, then I'll show you that later. Now we came to know that it is in data and it is unformatted value. Now we need to create a file system for that, and to create a file system we need to use command sudo make file system -t xfs, and then same what it was, dev nvn. What it will do, it formats the volume with xfs file system. Okay, I click enter. Now let's verify whether it is whether the data is changed to store data or not. EBS volume is to store data or not, and to do that we need to verify the file system creation again. What we need to do, we need to run the previous command, which is sudo file -s. Now you can see sga xfs file system data. Earlier what we see in data we have seen. Okay, now what we are seeing, file system data, which means now we have created a file system for this. And after creating a file system, what we need to do, we need to create a directory. And to create a directory, you can use sudo mkdir make directory, and then let's say my volume, and click enter. Okay, you have created a directory. Now we need to mount the data, which we mount the EBS volume which we assign to this EC2 instance to the directory which we created. And to do that, sudo mount, and then the dev, oh sorry, it got copied. Okay, sudo mount, and then what it was, dev, and then nvme1 and 1, and space, and the name of our directory. What our directory name? My volume, and click enter. Okay, now if you verify all the available file system and their usage in the human readable language, and the command is, let me clear the complete screen, command is df-h. You see 100 GB is available now. Okay, that's how we will assign and we'll create directories. And hope you understood this. What all we did, we created a Linux EC2 instance. You can see here we created a Linux mission, and then we attached a volume 30 GB to it, and then we created a new volume 100 GB and we attached it to the same EC2 mission, and we ran few commands. What command? We ran lsblk. What it will do, it will list all the available volumes. Okay, lsblk, it will list all the available volumes.
And after that, what we have done, we have verified the partitions. To verify the partition, what command we have used? fdisk-l, and we are able to see the partitions here. Our partition was available. And here what we did, we verified the file systems if it is available for our new EBS volume or not. To verify, what we need to do, sudo file -s, and then the name of our disk, this one. This was Paisa, and click enter. Now what it is showing, X, XFS file system data. So we are done with the volume creation and everything, and our file system also contains a data, so it is showing this way. If not, what it is used to show, it is used to show data, which means we need to create a file system and then we need to mount that to a directory. Hope you understood. Now what we will do, we will verify which path we are. Let's create a snapshot now again. We are in uh, my volume, which is our volume, and let's create a file here. I'll create touch test1.txt, test2.txt, test3.txt, and I'll click enter. Okay, I need permissions itself. If I do ls, yeah, I have all the volumes created. Now what I'll do, I'll take a snapshot of this, create snapshot, as snap -2 full. Let me go to snapshots. This is our snap. It's in pending state. Let's wait a moment. Yeah, everyone, if you see here, we have mounted the volume, and under our volume we have created 3 files, and we taken a snapshot of that. We taken a snapshot and we created a volume with that snapshot. This is our volume, and now what we are going to do, we will create a new EC2 instance and we will assign this volume to it, and we will verify if the files are available in that or not. And to do that, let's launch our mission, create a new instance. Let's say EC2 mission 2, and let's select Rocky Linux here. Rocky Linux, enter, and 8. Let's subscribe to it and subscribe launch on instance. Now we have selected the EC2 instance, and let's select our key pair and change these volumes to the our existing VPC, and this is our public subnet, and we need public IP for this. And let's select our existing security group, and this is okay. Now launch instance. Once the instance is launched, we will log into that instance, and later we will attach our snapshot volume to this existing mission, and we will verify if the files are created in it or not. Let's wait for 1-2 minutes. Let's copy this public IP, open putty, and let's paste our private key credentials and our key pair, Linux key, open, and let's open our session. It might still under creation. Let's wait. Yeah, let's wait for another 2 minutes. It might be still creating, or checks might going. We'll try again. Public IP, then putting our IP, SSH, authentication, credentials, browse, Linux key pair, open. Let's click open. Yeah, give our username, which is Rocky. Let me maximize the screen, change font, appearance, change, and let me make it to 18. Apply. Okay, if I do lsblk, we'll see only the root volume which we got while creating the EC2 instance. Now go back to volumes, and this is our snap volume. Click actions, attach volume, select our EC2 mission, and device type, let's select dev SDF, and attach volume. The volume is now attached to our EC2 instance. We can verify under storage, and let's refresh. See, 100 GB is also in use. Now go back to our new mission. Okay, now if I let me clear the screen, it will be easy. Now if I run again lsblk, you will be seeing one volume. Okay, at bottom we can see our volume which we recently assigned. Okay, cool. Now what we'll do, we'll verify the partitions. Sudo fdisk -l, it will show us the partitions. See, this is our new partitions. Okay, great, wonderful. Now what we need to do, we need to verify if file system is created or not. To do that, what we need to do, sudo file -s and then dev and this thing, this name. It might be different in your case. Please verify and use accordingly. nvme1n1. It tells XFS file system. Okay, cool. Now what we need to do, we need to create a directory, sudo mkdir, and then let's create restore. A file is created. Now what we need to do, we need to mount this to mount our new file system to this folder which we created, restore. Sudo mount dev nvme1n1 and then restore. Click enter. Wonderful. Now if I do lsblk, it will be added to restore. Okay, now if I go to restore path and if I do ls, all the files will be here. See, if we see 224, it is our new mission's private IP instance, EC2 mission 224. Okay, and 70 is our old mission. 70 is our old mission. We have 3 files, test1, test2, test3. 224 is our new mission. We have 3 files which are test1, test2, test3. This is how we use EBS volumes. Hope you understood. Just to give a overview again, initially we created a EC2 instance and we attached a volume to it, and we verified how to verify the partitions, check the file system, and how to mount that volume to our mission. And later what we did, we created a snap of this image. Which image? For the Linux PR 100 GB image, we have created a snapshot of it, and that snapshot is this one, 100 GB snapshot. Later what we did, we created a volume for the snapshot. Under volumes we can see this one, volumes. Then what we did, we assigned this volume to our new EC2 instance, which is EC2 mission. And when we have taken the snapshot after creating the three files, first, if you miss this logic, first we mounted the volume and then we created the files under our volume. If you do not create files under your volume, or if you take snapshot before creating or attaching the volume, then the files may not be captured or backed up into the EBS volume. So after attaching the volume, you can go to that particular folder or create volumes, or after mounting the value, you can create a files and take snapshot of that volume and then create a volume for that snapshot and then assign it to a new EC2 instance. So similar way, we created files under this first mission, Linux PR mission. Then we created a snapshot of this 100 GB storage mission. Then we created a volume from that 100 GB snapshot. Then we assigned this 100 GB snapshot to our new EC2 instance, which is Rocky, which is EC2 mission. And then what we did, we verified the file system. I'll show you it here. We verified the file system. Yes, our 100 GB is showing. Wonderful. Then we verified the file disk partitions. Yes, it is also showing here. Then what we did, we verified the file system storage. Yes, it was showing XFS. Why it is not showing data as in our previous first mission? In first mission, when we verified dev nvme1, it was showing data. Then we created file system, then we assigned, we verified file system and we mounted. But in this case, it is directly showing file system data. Why? Because we added this volume from a snapshot. That is why it is showing in this way. So it is not required for us to create a file system. Just we need to verify if file system is created or not. So we confirmed file system is created. Then we created a folder which is restore, and then we mounted our new EBS volume to our restore folder, and then we changed our directory to restore, and then when we verified the file list, all the files are showing. This is how we work. Hope you understood the session. If you have any comments, please paste it in the chat. I'll try to explain you again in the comments feed. I kindly request you all to subscribe to our channel for more DevOps courses, and share the channel information to your friends or someone who is looking to learn DevOps. As a part of our AWS Masterclass series, today we will see session 7, which explains IAM concepts. And let's begin. First, we need to know what is IAM. IAM, it is an AWS services, and IAM stands for Identity and Access Management. Okay, and why IAM is needed and what is the use? If we think about that, then IAM, we came to know it is a AWS services, and it full form is Identity and Access Management. Now IAM will act like security. IAM is like security guard of AWS, and it decides like who can access what they can, who can access and what they can access and how they can access. These all are managed by IAM. Okay, hope you got. And IAM contains three things. First, let me start with users. As of now, remember, it has three things: users, groups, and then policies. Okay, apart from this, it also has a Role concept, roles, we'll discuss that in the later, last. Okay, now let's get into our console. Hope you all have created an AWS account, and this is my account. And to access IAM services, in the search bar we need to enter IAM. If you see here IAM, click on that, and here you can manage all the IAM users, policies and everything. Now in the security recommendations, I have configured MFA, and that is the reason I'm not getting any errors. If you haven't configured, you may see an error message here. You can ignore, or you can proceed with configuring MFA for your account. And these are the regions. Okay, now we are in IAM, right? Now what we need to do, let's create a user. To create a user, you have to click on the users button, and I'm in global region, and click create. What will give username? Let's give Howard R. Okay, and this is console access. Now if you see here, we have console access. Similar way, does that user also need console access? Okay, and here if you see identity center, identity center is nothing but if you have in your organization, you will be having a IT admin team, and they will be creating user accounts and everything for the new joining members, and for the different roles and different type of user permissions they will be creating. No, there it is useful. Okay, in same place we can manage everything, but now I just want to create an IAM user. That is why I'm creating this. If you click auto generated password, it will give you a, it will generate a password and it will give you, and I want to go with custom password. Okay, so let me select my password. Done. And now if you check mark this one, user must need to create a new password after they log into the console. I don't want to, I want to use the same password. Okay, now click next. I don't want to save this. Here if you see here, add user to a group, copy permissions, attach policy. Here uh, let's discuss all these things later. First we'll create a user. See here, user review and create. It will we can review here. This is the username and this is the password. Password request, require password reset is set to no, and no permissions, nothing. I haven't assigned any policy. I haven't added him to any group or nothing like that. Okay, now oh, we need to download this one. Now this is the important thing. We have created a user, and if you want to, you need to have a URL to log into that user. This is the URL, and this is the username, and this is the password. You need to download the CSV file so that you can remember the data. And now I have downloaded. Let's click on view user. See, this is the user which we recently created, Howard R. And if you see here, and console access was enabled without MFA, and created on so and so date, and permissions, no permission to this user. Groups, I haven't added him to any group. Last access security credentials also I haven't given any for him. Security access is like if you want to create infrastructure using VS Code with the help of Terraform or any command line, you need to have access keys and everything. There we will create security credential, like we'll come to security credentials and then we'll click on access keys, then we'll create this. And see here, use access key to send programmatic calls to AWS from AWS CLI, AWS tools for PowerShell, and goes on. Okay, now let me show you how to log into that user. See, we don't have any groups. Now to log into that user, copy. Let me show you the downloaded one as well. This is the one we recently downloaded. Okay, Let me open that. I'll go with notepad just once. See, if you see here, username, password, console, sign URL. This is the username, this is the password I set, and this is the URL which we need to use to log into console. Don't worry, I'll delete the user once I'm done with the explanation, so I'm just revealing. Now, one thing, now we logged in as a root user. If you see here, it's my name, it's my account, and it's a root user, okay? And if you try to log in the URL which you copied from the IAM user in the same browser, it will not allow you to log in. Why? It will take you to the same page where Prashant is logged in. So to avoid that, I'll go with incognito for a while. I am in incognito browser. I click enter. Now if you see here, this is the ID. We can change this. We can make it as a alias as well. This account ID it will show. Okay, in this account we have IAM user. What was the IAM username? Howard or. Okay, and then password. Now let me click sign in. I'll be getting the console access. If you see, everything will be restricted. You won't have any access, any permissions, nothing. See here, if you see, Howard or will be the user, access denied, and if I search for EC2, he won't be having access, so it will say access denied for everything. See, I have API error, API error. And if I go with S3 bucket, which is the object storage one, it will also show the same. See, it is showing create bucket, right? Let me try creating. What I'll do, I'll give some random name. Shant Kumar 2025. Let's block everything for a moment and click create bucket. See, fail to create bucket. View your permissions. Permission is required to create bucket, it is telling. Why? Because I do not have any permissions assigned to this user. That is why I'm getting this error. Hope you understood. Now what we will do, we'll go back to our root user. This is our root user, and here policy can be assigned in two ways. One, we can directly assign it here, or we can directly assign when we are creating a user, and the second one, we can assign it to a group as well. Okay, now let me go to policies, or where is users? Let me go from here itself. User, add permissions. I'll give him a permission. Add user to group. No, I don't want. Attach policy directly here. This I will go with. Now I'll choose S3. We are directly assigning policy. That is why I came here instead of going to policy and coming. We see here S3 full access. Let me give S3 read only access for a while. S3 read only access. Okay. Now I'll assign this policy to the user. Add permission. Wonderful. S3 read only access. Now in the root user, I'll go to S3 bucket. I'll create a bucket here. Create bucket. General purpose bucket name. Prashant Kumar 2025. I don't want to change anything. We'll discuss this when we start in our upcoming sessions. Yeah, the bucket is created. This is our bucket. Buckets Prashant Kumar 2025. This is our bucket. Okay. Now I will go to our user Howard. If you see here, I'll refresh this page. Just we'll wait for a while, so that I'll go to buckets. If you see here, Prashant 2025 is now you are able to see. And if I duplicate this and if I search for EC2, I still won't be having permissions. Why? I given read-only permission to this particular user. See, everything is blocked. If you see for VPC also you won't be having access. Howard will not have access for VPC. See, retry. He has access for S3, that too only read-only. He can read, but he cannot upload. If you see here, I'll go here. I cannot upload any file here. If you see upload, add files, I'll choose a file, random one. Let's select this one and open. And if I click to upload, I won't have permissions. I'll get an error message. Upload failed, error. For more diagnosis error. See, why it is failing, because if you see here, access denied. That is the reason why it is getting failed. And similar way, now what I'll do, I'll show you if I have permissions to create a bucket or not. General PR-PR 2025. This is a new bucket and I'm just clicking on create. Still I won't be able to create. Permission is required. Why? We given only read only permission. Now go back to our root user, which is Prashant. Go back to our IAM users. I click on IAM. I'll go to policies. Now I'll search for S3. S3 full access I will give him. S3 full access. Yeah. This policy I will be giving to this user. Howard. Add permissions. Attach policy directly. S3 bucket. Give S3 full access. Next. Add permission. Now if you see here, he has full access, he has read only access. Okay, who Howard has? This user. Now I'll go back to our incognito where we logged in as Howard. Now I don't do anything. If you see here PR25, I'm creating a bucket and I'll just click create here. It will create automatically. Without any error, I will be able to create now. See, PR 2025. And if you see, if I want to upload any file, add files. Let me upload this one. Upload. I will be able to upload succeeded. See, this is how the policy works. Now what I'll do, I will go back to our root user. I will search for S3 and I'll show you if the group and the policy, if the group which we created with the Howard user and we uploaded a file, right, we'll verify if it is visible or not. Wonderful. We are able to see the group. We are able to see the image as well. Let's see if I can. Yeah, this is the image. Cool, great. This is how we can assign a policy directly to the user. Hope you got it. Let me go back to IAM. Let me show you groups now. Let's create a group first. Group name S3 access for developers. Okay, I'm not adding Howard into this, and I'll give S3 full access this time. S3 full access. I'll create a user group. Now I have a group, no user into this group. Now what I'll do, I'll go to users. This is our user, right? These are the policies which we attach to him. Let me remove these two. Remove policy. I removed these two policies. Now If you go back here and if you refresh, you won't be able to. Let me go to buckets. It will take some time. Access denied. Okay. Now what I'll do, I'll add this user to a group. Groups. Add user to groups. Howard R is now being added to this group. User groups. S3 access for developers. See, he is in this group. And what permission does this group has? S3 full access. Now if I go back here and if I refresh, see, I'm able to see these two files. This is how group works. And now I'll create a new user, second user. Create a user. User2, let me rename it as user2. Same, provide console access. I want to create a IAM user. I'll select my custom password. And I'll click next. Okay. It's not meeting the. Yes. Now it is showing me add user to group. Earlier what we did, attach policy we did. Copy permissions is nothing but if I click copy, then all the permissions which Howard has in group S3 access for developers will be directly copied to the user2 which we are just creating. And add user to group means now I will add directly this user to the group. Okay, next, create user. User is now created. I'll copy this. Let me log in from here this time. What was our username? User2. See, now what happened? It is asking me to change the password. Why? You should be able to understand now, because let me cancel this one. Download this for safer side. If I go to users, if I click on user2, he has two policies. You can ask me, Prashant, earlier we have assigned only one policy to this group. Then from where this IAM user change password has came? Now if you see, go to groups. This is our group. If I select permissions, I have only S3 full access permission. And if I select Howard, no permissions for him. I mean only S3 access permission for him, no other permissions. Okay. And similarly, if I select user2, he should have two permissions. One is for IAM password change and the other is for S3. If you forgot to remove the user, if you forgot to uncheck the user change password next time, then also it will occur. Now if I try to log in with the user2, I already logged in, right? Let's rechange this. See, now if I see S3, I will be having access to S3. I can create a bucket over here with this user2. See, he is seeing this Howard created a bucket and Prashant created bucket, and this is the user2. And if I click create user2 hyphen became bucket, and if I click create bucket, it will create and ensure the name is to be globally unique. uh, I have user bk2. Now if I verify this with the Harvard user, I should be able to see this. And if I verify with Prashant, I mean the main account, my main account, then also I should be able to see. See user bk. Hope you understood this. Now what we'll do, we'll go to IAM again. I'll show you how to create a custom policy. Go to policies, create a policy, and to create a policy we need to choose a service. Which service? Let's select S3 only. And actions, it will show manual actions all S3, or you can select only access level. If you see list, read, write, permission management, if I select only read, all read actions. And now what I'll do, you can, if you need, you can add multiple. Again, you can select any EC2 and EC2, and then what here needs to, he needs to, what he can have, I will give everything for him. And if I click next, the policy will be created. All resource. Now it will ask me for policy name. S3 read only and EC2 full access. This is our policy. You can give description, giving policy for S3 read only and EC2 full access for users. And then if you see here, services, why only EC2 came, why not S3? S3 read all read permissions. Next. Yeah, now 2 has selected. S3 read only, EC2 full access. Again S3 read only access and EC2 full access. These are the two policies, and create policy. Policy will be created. Okay. Now what we'll do, we'll log out one of the user, or we'll close this. Yeah. Now I'll go to users. I'll create a new user, create user. This time I will not attach him to any group. I'll directly attach him a policy. User 3. Provide console access. Create, I want to create user, custom password. Yeah, this one we should uncheck. Custom password has been set. Click next. It is not meeting criteria.
Now this is our existing group where we have S3 full access, and this is I explained again earlier. If we click copy permissions, whoever we select, that user permissions will be directly copied to the user which you are creating. Attach policy directly. This is what we want. Now search for the policy which we recently created. What is our policy? S3 read only. S3 read only, EC2 full access. And if you want to see, you can see this. It will be in JSON language. If you see here, fx allow and what all are allowing, and what is not allowing, everything can be seen here. S3 only, EC2 full access, and I'll assign this. I'll create a user with this policy. I'll download this JSON. I'll copy this one. Now in Edge, I'll open a incognito private. This is our user 3, and let me go with the password. This time it will not ask me to change password. Okay. Now we are into S3 user. User 3. If I search for S3, I will be having read access for that. I can see 3 buckets which we created. And if we go to EC2, see instance running, these I can see. I mean, we cannot see, we are not seeing any error for this, right? I'll go back. If the user does not have any permissions policies set, then in the dashboard it will show all API error, but for him it is not showing, so he has access. Security group also is able to see. Okay, now in S3, go to S3, read access I given to him, create buckets. Let's see what policy we have. Let's re-verify. Download users, user 3 policy, read only. We given him read only access, direct job. Okay, bucket location, bucket policy, bucket tax, data access, bucket versioning. He should have bucket access, then only he will be able to. If bucket access is not mentioned, then he won't be able to. Okay, if you see create bucket, then he won't be able to create. Let me show you. I'll give some random name. See, failed to create bucket because he does not have permission. That is working fine. Then it should also show. Okay, create bucket we are giving. If we select create bucket, then again we need to select another permissions as well. Let's give all. Now both has full access, right? Or we might missing some permissions, that is why. Let's go to incognito, refresh, it should highlight. See, everything is showing here. Now if you see, you will be able to
upload anything in any file, because I given all right. Let me show you if I'll be able to add or not. Let's go to downloads. Let's add this one. If I click upload, it will get uploaded succeeded. Okay, and I'll close this. S3 list all, read all, specific error now. Okay, this will work now. We have both S2 S3. Now if I go to here, if I refresh, I won't be able to upload anything. Okay, I can view buckets, but I won't be able to upload inside that. See, if I click upload, I won't be able to. I'll get error, fail to upload. Why? Because we modified our policy to list and read, no write permissions. That is why we are getting that one. Now if you see, I'll go to EC2, I'll edit EC2 policy visuals. I'll remove this EC2 completely here. I removed EC2. I have only S3 now. I save changes. Policy is updated. If you see permissions for user 3, only S3. Now if you see, earlier when we went to EC2, we are able to see API error only on one item, but now we will see on all. Error, incident running. You are not authorized. Perfect. See, you are not authorized to perform this operation, everything. So that's how we use policies. Let's go back to our root user. Now you come to know what is user. I mean, how to create a user, how to add a user to the groups, how to attach a policy directly to a user. Now let's see how create a role. Okay, let's create a role. Role is like a assume policy. It will assume a role, like how can I say, it will be temporary, like it won't have any credentials or something like, but it will assume, the user will assume it has a temporary role. See about roles, and to assign a role, what we discussed, role is like a assume policy, assume role. And first we launch an instance. We'll give name as ec2 hyphen pr, and I'll go with Rocky Linux. Marketplace, select, and then subscribe on instance launch. Let me see if I have any free tier eligible here. Okay, no free tier eligible. I'll select keeper as Linux. I select keeper as Linux PR key, the one which I already had in my mission downloaded. I'll change the network to my VPC, the one which I created. If you are not aware of VPC concept, please watch our previous sessions which I uploaded in YouTube. I need public IP, and I'll select the existing security group, and then I'll just click launch instance. Our instance will launch successfully. Okay, instance is launched. And once the instance is launched successfully, what we need to have, we need a role, right? Go to roles, IAM, and then roles, create role, AWS services. For what services we need role? For EC2. Select EC2 and then click next. What permission does this need? S3 full access. Now give a name.
role created for EC2 to access S3. Allow EC2 instance to call AWS services on your behalf. And this is our policy, and let's create a role. Creating a role is created. Go back to our instance, click actions, security, modify IAM role. Here you will be seeing the role which we created. Role created for EC2 to access S3. Update IAM role. Once the role is updated, you can verify it in the IAM role section. Okay, copy the public IP. I'll connect via putty. I'll paste the IP, and then I need to upload the key. Private key. And then session, then click open. Our username mostly will be Rocky only. Cool. Now to view the service, we need to do run this command. What it is telling, AWS command not found. Just go to here, search for AWS CLI for Rocky Linux, installing. Go click on first your first page, and then Linux, and then this is for remove, and I need for installation. Let's select this command. Sorry. Use the curl command, and then I'll go with the first thing. I'll copy this curl command. I'll paste it in my mission. Okay. Unzip is not found. It is telling unzip is not found. Let me do ls. Yeah, I had a zip file here. Sudo m install unzip. If you are not aware of the unzip command or m command, I request you to watch our most used Linux command series which we done earlier, and it is available on our YouTube channel. Kindly watch for more understanding of the Linux commands. Unzip and then the file name. Oh, sorry. First we need to install the unzip, right? It was telling unzip not there. Sudo m install unzip. Let's wait a moment. Let's it finish installing. Yes, I approve. Yes, unzip is installed. Now what I'll do, I'll just do ls. Now we can do sudo unzip and then the AWS CLI. The file will get unzipped. Now if I do ls, I'll be having unzipped file which is AWS. I'll get into that folder. I'll do ls. This all I'm having here. Sudo. If you are not aware what to run next, we have a readme file here. You can just use cat readme.md. Let me maximize this. Here you'll be having detailed steps. This bundle contains to install AWS CLI, sudo install. This we need to run. Sudo // and then sudo // and then install. AWS CLI will get installed now.
Now if I do AWS S3 LS, the buckets which we have in S3 should get here. See, we are able to see this. This is how it works. Hope you understood what are roles, what is user, what is groups, what is policies, and this is more than enough for AWS IAM concept for better understanding. And if you keep on practicing and testing multiple scenarios, it will be easy for you. Cool. That's it from my end for today. Hope you enjoyed the session. As a part of our AWS Masterclass series, today we will see session 8, which is S3 bucket. We will see concepts of S3 bucket and a demo on that. I see most of the viewers are watching the videos but not subscribing. I would like to request you all to subscribe to our channel. I see most of the users are viewing the videos and not subscribing yet. It's taking me so much effort to create videos, so I request you all to subscribe to our channel for more DevOps videos. And let's begin. As I mentioned, today we will see S3 bucket, which is session 8 in our AWS Masterclass series. If you haven't watched our session 7 and the previous videos, I request you all to go through them for better understanding of AWS resources. Today in session 3, we will see introduction to S3 and what is object, what is bucket, and storage classes, and how to give access to the bucket and everything. Let's go to our readme file. I created a notes for the readme file which will help you to understand more. Now if you see S3, S3 is a simple storage service, which means it is an object storage. It's not like a volume or something. Like, we can say it as a object storage service which is provided by AWS services. And in this object service, it is not like you can store only files or images or something. Like, you can store anything in the S3 bucket, file storage or whatever it may be. You can store in the S3 and you can retrieve whenever you want. And it is a object storage, as I mentioned earlier, and it has unlimited storage and maximum of 5 TB, I believe. 5 TB you can store, and then you can segregate into two individual parts and upload it to the S3. And the S3 bucket has 11 nines of durability, which is 99 point, then 11 nines, 999 goes on. And it is a pay as you go service. You pay for the storage and the request and the data transferred. And the key concept on this and the terminology which you need to remember are buckets. Remember, a bucket is a container for objects in S3. Okay, bucket is a container for object. We will see what is bucket in our demo. Just remember the terminology. And the bucket needs to have a globally unique name. If I say Prashant as my bucket name, there might be another Prashant which are using AWS services and they could have named their bucket as Prashant. So I won't be able to use Prashant name for my bucket. So it's going to be globally unique. And then objects. Object is the actual data which you will be storing in the S3 bucket. Okay. And remember, object is the data which you will be actually storing in your S3 bucket. And each object contains of object data, which is your file content, and the metadata, which will be the key values pair about that object, and the key is like the path or full name inside the bucket. You can see here example as well. Regions are like as we mentioned earlier in our previous videos, regions is the provided in the AWS services, and we can choose the nearest region for our deployments or any other to avoid any latency. And this is important. Storage classes is very important. You should be aware of these concepts more. And S3 offers multiple storage classes, okay, and they are like S3 standard, which is for frequently accessed data. There will be data like which you wanted to access frequently, and there might be some data which you won't be which is not required to access for months or years, and there might be some data which you want to delete after 30 days of usage, and some data might be like you may access it once or twice in a month or twice in a year. For those scenarios you need to be aware of the storage classes. In the standard storage S3 standard, we have frequently accessed data and it has low latency and high throughput. S3 intelligent tiering, it will automatically move data between frequent and infrequent access states. And S3 standard IA, infrequent access, it lower cost than the standard and the data is accessed less often, but needs you can have fast access when required, okay. And S3 one zone IA, it's like single AZ, okay, cheaper but less resilient than the multi-AZ. And S3 Glacier, Glacier Instant Retrieval and Glacier Deep Archive for archive data. Very low storage cost and high retrieval time or cost. You can go to AWS URL and search for the S3 storage classes and you will be getting more in-depth detail over there, just for your understanding and a short notes like I'm just describing all these things. And IAM control access, these all we'll be seeing in our video. Now let's move on to EventBridge session. As I'm requested earlier, please subscribe to our channel. Most of the users are watching but not subscribing yet. In your AWS services, in the search bar, search for S3. This will give you the S3 services. Take you to the S3 services and click create bucket. And for now I just go with the bucket general purpose. Let me go to Mumbai. Now I'm in Mumbai, okay. My bucket name, what I mentioned, bucket name should be unique, so I'll select AWS hyphen Prashant. Today's date 01/12 01/12/2025. And now I'll be leaving everything as it is, and this is for public access. I'm blocking it for now, and I'll click on create bucket. See, successfully created bucket. View details. Let's go to our bucket. Buckets, this is our now if I click on buckets, this is our bucket which we recently created, okay. Let's open the bucket. Bucket does not have any data. Now if you see in our AWS nodes, what I mentioned, a bucket is a container for objects. Now we have a container for our objects and we do not have any object, so let's upload an object. I click upload, add files. Let's upload. I recently created a file for Linux most used commands. I'll upload that and I'll keep everything as it is, and I click upload. Uploading, you can see file, MB, everything. Cool. Let's close this and go back to our buckets. Now this is my bucket which is a container for our object, and this is my object. Hope you understood now. We have a bucket which is a container for our objects, and the file which we upload is our object, actual object, and the file which we upload is our actual data. Now if you see here, if we want to access let me show you this as well. We created in the Asia Pacific Mumbai region, and you can see the size and the last date modified and the type and the key is name, and you open your object URL and everything. Let me copy this object URL and see if I paste in the browser what I'll get. Access denied. Okay, and here we can see storage classes which we discussed. If we click on storage classes, we'll be having multiple type storage classes. We can change whenever we need, and we can change it as per our requirement.
Now if I go to buckets, let's see our bucket permissions. This is metadata and this is the properties of our bucket. Versioning and all we'll see in a moment. And tags, we can add tags as well. Now this is the permissions. We created a bucket, we added our object, we tried to access our object, we are getting access denied error. Now we will see how to make an object access publicly. It's not like you can add only files or something. In your real scenarios you will be adding applications or as per your client requirements and your needs. Now if you see block public access, which is set to be on, so let's disable this so that the changes, this will change to access publicly. I'm confirming. I'll click confirm and save changes. Cool. Successfully edited block public access settings for this bucket. Wonderful. Okay, now I'll refresh this page. Still I'm having access bucket, denied access, and you may think I'm using wrong URL or something. Like, to avoid this, let me recopy this URL and try again. Same error. Okay, now I click on this bucket and I click on permissions. You can view this by clicking in this directly. It will open in a tab. Open this one. You can view. This is possible, but this can be seen only by me or the persons who will be able to log in with the credentials of mine. Though only can access, others won't be able to. So this is for everyone. Denied. Okay, let's close this tab. Go back to our bucket. I'll re-click on the permissions. Here you need to understand we disabled access, block access for public access. Bucket policy do not have any. We need to add a bucket policy for this as well. It will be in JSON format. You can just click on add statement, search for S3 and all actions. Let's go for all actions for now, and then simply come down, add resource S3 I want, and S3 all resource. Let's select and click add resources. Okay, now here principal seems to be empty, which means no one will be able to access. So I'll make it everyone. For this I'll put star. This is for everyone. Okay, and resource, let me change the resource as well. S3 all access, add resource, S3 resource type, bucket name. What is our bucket name? AWS hyphen Prashant, today's date 2025 slash star we need to give. Okay, and then add resource. This we can remove. Now let's see save changes, what happens. Yeah, successfully edited bucket policy. We have principal for allow everyone and S3 resource. This is our ARN. I forgot to show, let me show you that as well. Objects, let's click on object. There will be an ARN. This we can add it over here. permissions. In this place we can this add bucket ARN, this one ARN AWS S3 AWS Prashant 25 and let last store. That's it. And you can, if you are not aware, you can go to policy examples and read some stuff and for better understanding. Now what we did, we to access our object publicly, we turned off block public access. I mean, which mean we enable the public access, and then we wrote a bucket policy which is set to allow everyone for this bucket or this resource ARN. Now if I refresh this page, I should be able to see. This is how we will set public access. Now you may think that I am using wrong URL. Let me copy the correct, I mean recopy the URL. Copied, new tab, paste it, enter, see. This is how we will give public access. Okay, now hope you understood how to give permissions for a bucket to access globally. Got it? Cool, wonderful. The second thing, which is versioning, let me take you to that. Bucket versioning. Versioning is like I can say it will keep multiple variants of an object in the same bucket. Now we have Linux, this bucket name Linux most used commands object, right? If I modify some changes and if I re-upload the same file with the same file name, then it will take it as a version of the previous file and it will use the current one. Okay, let me show you. First we need to enable the versioning. Enable, save changes, successfully enabled bucket versioning. Wonderful. Go to objects, upload a file, add files, select the same one, click open and upload. See, time, everything can be seen, uploaded. Now let's close this one. Go to properties. Versioning is enabled, right? Now go to object, click on this object, click on versions. You will see two versions. This was the previous version which we used, and this is the current version. Similarly, if I upload the same file again, it will take the new file, not this file. Let me show you that as well. I'll go to bucket, I'll upload a file, I'll add files with the same name and I'll click upload. Now it will move to the recent upload one. Object version C. This is the current version which we recently uploaded. Okay, and this is the previous version. You can see time 5111, 5156, which means this is the latest one. Current version, this is the previous version. You can download, delete, you can do multiple things. And now if I want to delete this thing, see, I can delete this as well. I need to enter permanently delete. Click delete objects. Successfully deleted object. Cool. Let's close. If you see now what happened, can you guess? It will directly goes back to the previous version which was uploaded at 5111. Hope you understood. You getting the point. What we did, we uploaded same file. I mean, let's say we added some lines in the Linux most used commands, or assume it is an application code. Our application was running perfectly when it was initially uploaded. We made some changes and we made some changes to reflect in UI and we uploaded this as well. It is working fine, wonderful. Later what we did, we changed some login prompts or login design web for web UI or something like, and we uploaded that thing, and for some reason it was not working fine, or your client may ask to change or make some corrections on the latest release or something like. In that scenario, or you deleted that, I mean you want to go back, in that scenario you can directly delete, or you can move that file, download, copy, and if someone unexpectedly delete that as well, no worries, the previous code will be available and you can start working, or you can re-upload the current code. That's how versioning is used. Hope you understood the version concept as well. Now I would like to tell you the last thing which I would like to, which is cross region. Before that, you may think, what if I upload a different file name? Let me upload that as well for you. Let me see if I have any. Yeah, session 4, which is for Linux. Upload. Now, can anyone tell if this is will be publicly accessible or not? No, wrong. It is accessible globally. Why? Because we given the permissions for entire bucket, not for object. See, this is one. This is how we get it. Hope you understood. Hope you understood how to upload a file, how to access it in the web, how to give public access, and what if we don't give policy for the object, and what happens when the user tries to access it with the URL. And we have seen what is versioning, and we have seen what if I upload the same file multiple times, and we have seen what happens if I upload a different file as well. Now we will see the most important concept, interesting concept I can say, or useful concept for most of our scenarios for backups or something like, which is cross region. Let me show you that properties. Somewhere it will be RBAC tags, default encryption, intelligent server access, login management. Yeah, this one, replication rules, lifecycle rules. This one, cross replication rule. What we will do, we are in Asia Pacific, Mumbai. We have a bucket and we have two files. Now I'll create a replica set. What happens, whenever I upload a bucket in this bucket, I mean whenever I upload a object in this bucket, it will also be uploaded in the destination file, destination bucket. Let's assume, let's consider AWS Prashant is our source, and let me create a new bucket in US region. Let me reselect US region and refresh the page just to avoid. Yeah, I'm in US region. Bucket name I give US-PR- Prashant 01 and the date. I'll create bucket. Must contain uppercase. Bucket name must not contain. It should not contain uppercase, it seems. US. Create bucket. Wonderful. Our bucket is created. You can see which is in Virginia and Mumbai. Let's go to our source bucket. Click on the source bucket. Click on management. Replication rules. Create replication rule. Give name for replication. Mumbai to US region replica for Prashant. We enable or disable when we created priority. Source bucket, this is correct. Asia, correct. I'll give it for all the objects in the bucket. Choose bucket. If you have multiple accounts, you can select bucket in a different account by providing the 12-digit account ID, which is this one. For the different account, you can copy account ID of that account and can provide this. In our scenario, I'll go with the same account. I'll select my bucket. bucket name. Let me refresh. I should get US. Yeah, this one. Choose path. Wonderful. Crazy. Now you need to understand this thing. The limitations, or I can say the rule to use replica is we need to enable versioning in our S3 bucket, which is AWS Prashant. We have enabled the versioning, and we have seen no how if we what happens if we upload a object with the same name, and how can we see the versions of that file name and everything. Similar way, this bucket also, which we created in the UST East, this also need to have versioning enabled. Let me go back to our permissions and enable the versioning. Where it is, properties, versioning is disabled. Enable versioning, save changes, go back to our bucket. Let's refresh and retry. US Prashant, choose path. It's enable here. You go away from here. Let's refresh and try again. Why it's taking cache or something. US versioning is enabled. Let's retry now. US Prashant, choose path. Wonderful. The error has gone. Destination region is US East region and Virginia. I'll create a new role. Let it create a new role. And these all encryption and everything we can select, and additional replication options also we can select. Now let's save this. Yeah, it's enabled. Application time control disabled. Now let's go to our US East region and click on buckets and refresh. You can see two buckets are already here. And now if I click here, nothing is there. If I click here, there are two files. Wonderful. Now what we'll do, we'll go back to our destination source. We click on buckets. We'll upload we'll add files in these two buckets. Add file. Which one to add? Let's add GitHub image. Upload success. See, in Mumbai region, AWS Prashant bucket we uploaded. I'll close this. I'll go to buckets. I'll try to upload in US East. We don't need to actually, because it should automatically get into this bucket, so we can ignore, and you can just see US Prashant GitHub is already came. Because why? Because we haven't uploaded, I mean we set a replica source as this bucket and destination as this bucket. So if we upload in this bucket, it should automatically replicate in this region and in this bucket. So that's what is happening here. If we go to here, Virginia, I'll go here. If I select, I have 3 files here, and in Mumbai also I have 3 files here. And if I go here, I have one recent file which I uploaded recently. And if I go go back to Virginia, 2 buckets. If I open this Mumbai bucket, I have 3 files, and the GitHub, see here it is in region and this file. What if I upload here? Let's see what happens. Add files. Virginia, I had 2 files. If I go to Mumbai and if I verify this, it should have only one. Okay, cool. It's showing 2 as well. I can upload there here both ways. But it will show only in the N Virginia, not in Mumbai. If I click here, this is bucket which is replicating in this bucket, right? If I click here, it will take me to Mumbai region and it will show me these things. 3 are available here. And if I click, it will take me to US and it will show me 2 files available. But the thing is, we have to upload in this bucket and it should show in US bucket, which is Shant 1. Let's upload some random one here. I'll upload GitLab. I'm uploading in Mumbai. And as per replica rules, it should show in Virginia. See, I can see in Virginia. GitHub PNG and session 4. It has 4. It should also show 4. 3. Correct. We enable versioning now. Let's see 1, 2, 3. Here 1, 2, 3. This we uploaded previously, right? Cool. And you can access all these things. Object URL, search, browse. Wonderful. Mumbai one is accessible. Let's see Virginia one. Access denied. Why? Because the permissions for the US Prashant regions are not enabled for public access. It was blocked. That's why we are getting that error. Cool. These are the things I thought of explaining you guys today. First thing, we have seen what is bucket, then what is object, and then we have seen storage classes. Then we have seen how to upload a file. I mean how to upload an object, and what happens if we directly access the object URL in the web browser. It shows access denied. And then what we did, we tried to enable the public access, and then we tried, it's still throwing an error. Why? Because policy has not set. So we have set a policy, we tried, it worked fine, and then we have seen and we come to know what is versioning and everything, how to enable versioning. And later we have seen replication steps, how to replicate Mumbai S3 bucket to US bucket, which means what happens after enabling replica the source bucket, which is AWS Prashant, and destination is US Prashant. And in AWS file, which whatever the object or the file I upload in the AWS Prashant, it should automatically reflect in the US Prashant. That's what happening after replication steps. Cool. That's it from my end today. Hope you understood the session and you enjoyed it. If you have any queries or questions, please feel free to mention in the comment box. I'll try to answer them. And I request you all to subscribe to our channel for more DevOps related videos. It will boost me because I'm putting my effort and making the videos, but most of the viewers are watching but not subscribing to our channel. If you subscribe to our channel, you will be notifying whenever I upload a video or whenever I post something, so that you will come to know whatever I upload in the YouTube channel, and you will be aware of the technologies which are related to DevOps. That's it from my end. And as a part of our AWS Masterclass series, today we will see session 9, which explains about OSI models. Session 9 today we'll be covering, and we will see OSI model overview and concepts. And I have prepared notes or the content for our OSI model in our GitHub repo. You can go through it. And here OSI model is a open system interconnection model. Okay, OSI stands for open system interconnection model, and it is a conceptual framework that explains how data travels across network. Okay, and it has 7 layers. What it has? It has 7 layers. It has 7 layers, and layer 1 is physical. Let me put it to you, just a moment. It has 7 layers, and layer 1 is physical layer, and 2 is data link layer, 3 is network layer, 4th one is transport layer, and then session layer, then presentation layer, and layer 7 is application layer. These are the 7 layers. Okay, these are 7 layers which we have, which is layer 1 to layer 7. And what are they? They are uh, physical layer, data link layer, network layer, transport layer, session layer, and application layer. Well, now if you see in this image, it explains the complete OSI model. Okay, and here on the sender side, data goes from top to bottom. Okay, this is the sender side, and here data goes from top to bottom, which means it starts at application layer and goes till physical layer. Okay, and at the receiver side, it goes from bottom to top, which means it goes from physical layer, which is layer 1, to application layer, which is layer 7. And this process is called, let me write, this process is called en- encapsulation and decapsulation. This process is called encapsulation and decapsulation. And on the sender side, data transmits from the top to bottom, and on the receiver side, data goes from bottom to top. Okay, and this process is called encapsulation and decapsulation. Now if you see here, application layer, which is layer 7, what happens here is the application layer creates a data. Suppose you types a message or opens a browser, and here the application layer goes on, like it adds a protocol HTTP, and the data is plain data here in the application layer. Layer 7, which is application layer,
Here the user creates a data. Okay, the user creates a data and it is in plain data. Okay, and application protocol is added, which are HTTP, FTP and SMTP. These are added at layer 7 and the data is plain here. Okay, and at the application layer is for simple word, let's say as at the application layer the user creates a data or data is created. Okay, now next what happens, the presentation layer. In the layer 7 the application layer creates a data, and in the layer 6 what it is a presentation layer. If you see, application layer is 7 and presentation layer is 6. In presentation layer what happens, here the data which is plain data, which was in HTTP or FTP, is being formatted and it also encrypted if needed, and it also compresses the data. Okay, and in addition to that it adds a presentation header. Okay, in the presentation layer the data is formatted, encrypted, and compressed if needed. Okay, and in addition to this presentation header is added. Presentation header is added, which is, we can say, PH, presentation header, which means for the data it adds some value. Presentation layer, now this makes data more secure and readable. Okay, and the presentation layer also makes let's say it makes data more secure and readable. Cool. Now in next step, what is session layer, which is layer 5. In session layer what happens is, in layer 5, which is session layer, here session is created between the sender and the receiver. A session is created between the sender and the receiver. Okay, and keeps the communication stable between them, and a session header is added to the data. Earlier presentation header, which is PH, added to our data, and now in the session layer it creates a session between the sender and the receiver. That is fine, clear. And in addition to this it adds session header sh to the data, or we can say it adds session header sh, or it is added. Cool. And here session layer controls the conversation. Remember that in application layer what it is happening, the plain text is being created in the application layer. Sender types a plain text. Let's say you sent a message to your friend or someone saying hi, and the presentation layer makes it secure and it compresses the data or formats the data and adds a presentation header,
and then on the session layer it creates a session between you and your colleague or someone whom you sending the message. What happens there? A session is created and a communication is started, and a session layer which is session header which is added to the your data. Okay, hope you understood. And now in the session 5 we understood session is controlled controls here, and sh header is added. And in the transport layer which is layer 4, here it is very important layer. Okay, it is very important layer. Why? Because data is broken into segments here. The data which you are sending to your colleague of someone is broken into segments, into pieces I mean to say, and port numbers are added here. Port numbers are added, which you can choose TCP or UDP. It is chosen, TCP or UDP is chosen, and it is a it breaks your data into segments. Let's say you started saying hi, and it breaks it into segments, and the transport header is added. The presentation layer adds a presentation header, the session layer adds session header, and the transport layer adds transport header, and the data is chosen with the TCP and UDP ports. Okay, transport layer ensures correct delivery is happening. Okay, transport layer ensures correct delivery, which means it makes the data with the secure way, and it breaks into its segments, and then it moves it to the next layer. What it was next layer? Layer 3. What are layer 3? Layer 3 is network layer. In the network layer, what happens? IP addresses is added, IP addresses is added, and then root best route is chosen. Routes, routes, right? We explained in the Linux session. Routes has been chosen, and it adds network header to the data. Network header to our data. Network header. Okay, and here what happens? Router is came into picture, and network header is added, and network layer decides where data should go. The network layer decides where the data should go. Okay, and next we have what it is going, data link layer, which is layer 2. In layer 2, what happens? In layer 2, MAC address for the in the layer 3, which is network layer, IP addresses is added, and in the layer 2, MAC addresses is added, and frame is created, and error detection happens here. Here MAC addresses is added, MAC addresses are added, and frame is created. And in addition to that, what happens? If any error detection is also happens here, and data link header and data link trailer is added. Data link header is added, data link header is added, and you can say devices like switch and those comes into picture. Data link layer handles local delivery. Okay, and at last what we have? Physical layer. Layer 1, what it was? Physical layer. Here what happens? Data is converted into bits. Data is converted into bits, which is zeros and ones, and sent through the cable or Wi-Fi or any fiber. Actual transaction through physical medium happens here. Actual transmission through physical layer happens here, okay, which is physical medium. And here physical layer sends the actual signal. Now what happens in the these all from the sender side. What all we have seen is from sender side. In the sender side, what happens? Application sender creates a data, and the application layer makes it plain data, and then it moves to the presentation layer. In the presentation layer, what happens? Data is formatted, encrypted, and compression is happens if needed, and it adds a presentation header to the data, and then it goes to layer 5. In layer 5, what happens? Create the session between the sender and the receiver and adds the session header. Then layer 4 is very important. Why? Data is broken into segments and port numbers are added, which may be TCP or UDP. Then in layer 3, IP addresses come into the picture, and it decides how the data should go. Then MAC addresses are added, and the frame is created, and error, if any error detection is also happens here. And at the layer 1, data is converted into bits, raw bits, which is zeros and ones, and sent through the cable or Wi-Fi, and the actual transmission happens here. Okay, here actual transmission happens. This all from the sender side. Now on the receiver side, decapsulation happens. If you see now, if you see here, it started from application layer, which is layer 7, and goes till layer 1. Now in the receiver side, it is reverse. It starts at physical layer and goes to application layer. Okay, now if you see here, physical layer, what it happens? It receives the bits, and data link removes the, here in the sender side, what it did? It added the data header, correct? And in the receiver side, it removes the data layer, and then it removes the network header. And in the transport layer, what we had added? Transport header we have added. It removes the transport header. And in the session layer, what we had added? Session header we have added. It removes the session header. And in the presentation layer, here data is encrypted, and here decrypts the data. And then application layer shows the data to the user. That's how the process. Okay, this process is called decapsulation. Layer 7 to layer 1 is called as encryption. Let me put it here. Sender from layer 7 to layer 1, and encryption happens. And at the receiver side, it goes from layer 1 to layer 7, and here decryption happens. Hope you got it. I mean decapsulation, we can say decapsulation. Encapsulation and decapsulation, as we discussed here. Decapsulation, and here encapsulation. Let it make clear for you. Remember this sentence, okay? Decapsulation and encapsulation. When the data is sending from the sender side, it is encapsulation, and when the data receiving from the receiver side, it is decapsulation. And here in encapsulation, I mean here in the encapsulation, it adds headers while sending the data to the sender, I mean receiver. And in the decapsulation, it removes the header while receiving. Okay, and what you mean by header? It control information data, I mean control information added by each layer. Here if you see, application layer, plain data we have seen. Presentation layer, presentation header is added, session header is added, transport header is added. And in the receiver side, when it goes from physical layer, from the raw bits, Then it started removing the data header and network header, transport header, session header, presentation header, and at the application layer it shows the correct data. That's how it is goes. Okay, hope you understood this. This is all I have for OSI model, and let's go to our readme file and see if I miss any. OSI model we already discussed, which is open system interconnection model, and it explains how data travels across the network. Here we have seen how data travels from sender to receiver layer, physical layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. These are the 7. And here what happens, data goes from layer 7 to layer 1 when it is sending, and at the receiver side it is from layer 1 to layer 7. Hope you understood this. And then we have seen what happens in the physical layer. It handles the medium like cables, signals, and in the data link layer it handles MAC addresses, frames, and network layer IP addresses, routing, and session headers. Everything we have seen. And this is important, it was created by ISO, which is International Organization for Standardization. In the year 1980s it was been created. And here if you see, I just prepared some usage of OSI model today. I mean, if you get any error message or troubleshooting, this how it makes engineers to easily resolve the data. Possibly layer 1 happens cables, no internet, and no IP means layer 3 issue, and website not loading means it is HTTP or DNS site layer 7. This way we can segregate the or we can uh, get an idea of the issue where it might be happening or it might be occurring on which layer, and it makes the engineerings or the uh, administrator to troubleshoot easily. These we have seen, these we have explained. This is the diagram for OSI model, and we also have TCP and IP, which is application layer, presentation layer, session layer are considered as application layer in TCP. And then we have transport layer, network layer as it is, and then it changes, data link layer and physical layer are considered as network access layer. Okay, same again, I made it a more easy for you. When the client side, the application presentation goes from layer 7 to layer 1, and in the receiver side, layer 1 to layer 7. Hope you understood the session. If you have any doubts or something, please let me know. I request you all to subscribe to our channel for more videos, and that's it from my end. And please share the information to your colleagues or friends or someone who is looking to learn the DevOps courses. By this I conclude our session 9, which is OSI models. As a part of our AWS Masterclass series, today we'll proceed with our session 10, which is load balancers. And in our last session we have covered OSI models and how the session flows in OSI model. In session 10 we'll see what is load balancer. Okay, and load balancer is a component that sits between the user and the server, and it distributes the traffic across multiple backend servers. Okay, and it improves the availability, scalability, and the service provides the load balancer in AWS is called as elastic load balancer. And there are 3 types of load balancer. One is application load balancer, network load balancer, and gateway load balancer. Application load balancer runs on layer 7, which is used for HTTP and HTTPS. Network load balancer is on layer 4. Gateway load balancer is used to deploy third party security appliance. And here, if you're not aware of what is layer 7, layer 4, I recommend and I request you to go through our session 9, where we discuss the complete OSI model in detail. And I'll show you an example. Now let's say this is an user, and we have configured load balancer in our environment, and there are two EC2 instances which are assigned to this load balancer. Now whenever a user hits the load balancer, it will route the traffic to backend instances, which is EC2 1, EC2 2, and multiple, so that when one instance goes down, the other will be available. And when the traffic is high, let's say we have some e-commerce application or any other, and there are multiple users who are triggering to this load balancer, and the load balancer receiving multiple requests from the multiple users. In that scenario, the workload will be high, and two instances may not be sufficient or enough to distribute the load and send response back to the user or the customer. In such scenarios, we can use uh, scalability, and it will add the more servers behind the load balancer. Okay, whenever the load is high, we can scale it, and the instance will increase, and it will give response faster to the users. Hope you understood. Let's start our demo. I'm in my console. Let's create two EC2 instance first. Launch instance. I'll change it to south. I'll give this as server1 hyphen Prashant. Not require server1. I'll keep it as server1. Let's go with Rocky Linux only. Search for Rocky Linux in the AMI. Rocky Linux 8. Yeah, Rocky Linux 8 has been selected, and we need a smaller one. This is fine. T2 small. Let's create a key pair. Key pair is used to log in into that particular instance. Okay, load balancer key pair. I'll go with putty. I'll be accessing it with putty. So let's create. Once you create, it will be downloaded into your machine. I already had created a VPC, so I'll change the VPC to our custom one, and the subnet to our public subnet. I'll enable the public IP to be assigned, and then we have to select the security group. Let's go with advanced details. Here, user data. In user data, we'll write a script. This will allow us to run the bin bash and add an index.html file. Let's launch instance. Yeah, instance is launched successfully. Let's create another instance. Again, launch instance. Name it as server2. Same go with Rocky Linux. Cool. Let's change instance type to T2 small, and I'll select the same key pair which we recently created. Load balancer key pair. Yeah, Again, I'll change the network settings. If you're not aware of how to create a VPC and subnets, I request you to go through our previous videos where I clearly described how to create subnets and VPC and everything, and security gateway as well. Cool. I'm adding again the script. Let's launch instance. Cool. Our both instances have been created now. It's in running state. It's in pending state. Yeah, both are in running state. Now what we need to do, we need to create a target group. For that, again, click on EC2. Click on target groups. Create target group. Yes, it's instances. Give the target group name. EC2 target group. Yeah, protocol HTTP, and this fine. Change the VPC to our one which we recently create. Which we already had. Click on next. After clicking next, our two instances will be shown here. Select them and mention include as pending below, and then click next. See, this is our target group which is associated with our VPC, and this health threshold, unhealthy threshold, and port is 8080. These are the instance. Let's create target group. Target group has been created. Okay, now let's create a load balancer. Click on load balancers. Create load balancer. We'll be going the application load balancer. Name it as application load balancer -pr. We are using for internet facing, and we need to change the VPC to our custom one. And then availability zone. Let's select both. Yeah, we have selected the availability zone as well. Let's select our custom security group. Yeah, listening port is 80, and target group, we have to select the target group which we recently created. This is our target group. Listeners is optional, and load balancer. Okay, let's click on create load balancer. Successfully created load balancer. Okay, just refresh this one. The status is pending. Let's wait till it finish. Our load balancer is still in provisioning. Yeah, load balancer is active. Let's browse the DNS of ALB. Okay, our instance is in public subnet, and this is also in public subnet. Cool.
Let's add another role here, HTTPS as well. Let's access these missions and see what's wrong with him. Yeah, we are into our mission. Let's curl this HTTP colon and then the local host. Yeah, we are getting the mesh server response, so it should. Let's try now. Yes, we are getting the code. Let's just do the same for the first instance. This is our second instance. Yeah, let's copy our IP. Cool. Now if you see here, this is the response from server 2 and this is response from server 1. Let's copy the DNS of the load balancer. This is the DNS name. I have copied this. Now if I search this, it should route the traffic as we discussed in this image. When the one user hits, it should reach to EC21 and the other request should go to second instance. Now I am searching the DNS of the ELB, I mean application load balancer. See, it's going to Harvard Rock. Harvard Rock is on what it was telling, hello from server Harvard Rock. Let's copy this server to. If you see what it's telling, hello from Harvard Rock. Hello from Harvard Rock. This is from server 2. So our first request has been reached to server 2. If I refresh multiple times, let's verify our target group and see if they both are working, I mean running straight or not. Security group, okay. Go to target groups, click on EC2, unhealthy 0, total 2 targets, healthy is also 0, which means yeah, now both showing healthy. Now we should get response as well. Great. Now see, we are getting from server 2 and if I search again, we should get from server 1 as well. See here, hello from server Prashant, which means it's coming from server 1. How can I confirm? Means if I copy the public IP address of server 1 and if I paste it in chart, it should show server hello from server Prashant. So the second request is went to server 1 and the other request to server 2 and again it changes. Hello from server Prashant, server Howard Rock. So this is how the application load balancer works. See how many requests I type, those my requests will go on. See, the first request goes to one server and the second goes to another server. This is the load balancer and this is server map, security group. We can see the security group which we assigned and we can explore all these things later. But for your understanding, I have explained how the procedure, how it works. Okay. You can also create auto scaling groups. We have another topic for auto scaling groups. We'll discuss then. Just a recap. A load balancer acts as a server between EC2 instance. Okay. When the user interacts with the load balancer, it will forward the traffic or the request to the backend EC2 instance, and we can it will give us high availability and scalability as well. Okay. How when one instance goes down, the other provides the response to us, and when we'll be deploying them in the availability zone as well, it will be available to us. And we have scaling, auto scaling. It means when the traffic is increased, the instance will automatically scale up based on the configuration which we mention or which we describe. That's how the load balancer will function. And how we created one EC2 instance, and we added our custom script just to identify uh, which server is giving response to us. And what we did, while creating EC2 instance, we need to have a public IP assigned to it. I mean, enable public IP is to be allowed, and VPC needs to be created, and in VPC we need to have two public subnets. Okay. And those two public subnets we will be using to create EC2 instance. If you see here, this is public subnet 1 which we use to create EC server 2, and here if we go to this, if you see here, test public subnet, this is the other public subnet where we deployed the other mission, first mission. Okay. And we also created the, I mean, we added the our custom script while creating the instance itself. We can add it, so that we don't need to again log into the EC2 instance and deploy those things. Just for testing purpose, sample code I wrote, and tags you can give as well. After creating the two EC2 instance, we will be creating target group. Why? Target group will have the targets instance. Okay. In target group, we will describe the port and the protocol and the EC2 instance where the traffic flows from load balancer. Okay. In target group, we have targets. Under targets, we added our two EC2 instance, and those two instances will provide response to us or the users whenever they click on the load balancer DNS. Okay. And health checks, we can see here, you can see total targets and how many healthy, how many unhealthy, how many unused, all those things we can verify here. And one more thing, basically we need to have two security groups. If you see here in security, I have used the same group test SG for both EC2 instance as well as the load balancer, but here test group for a server, and for load balancer also I have used the same test SG. But in real world, I mean real scenario, we will be using one separate security group for EC2 instance and the other for load balancer, just to avoid any discrepancies, so that will be it will be easy to understand security rules from load balancer and for EC2 instance. And for that, what we have allowed HTTP, HTTPS, and this is for we access the mission from PuTTY, right? How we access the port 22 is allowed. That is the reason we have access via PuTTY. And RDP is for Windows missions where we can use remote desktop access. Okay.
This is how the load balancer works. After that, we copied the load balancer DNS and we searched in the browser. See, it is from one server saying hello from server Prashant. And if I search for multiple times, it should show hello from server Howard. So the load balancer DNS is routing the traffic to both the EC2 instance which we allocated in the target groups. Hope you understood. That's it from me for today. As a part of our AWS Masterclass series, today we will see our session 11, which is VPC Peering. And I prepared notes for the same. And in general, if you see what is VPC Peering, which means it is a network connection between two VPCs that allows them to communicate privately using private IP addresses. Okay, you may have one VPC in one region. Let's say you have one VPC in AP South and the other is in US or somewhere else, and if you want those both to be communicated, then VPC peering needs to be enabled. Okay, that's what it is. So let's begin our session. To proceed further, we need to create two VPCs first things, and route tables, internet gateway, everything. Let's do everything. We are creating VPC and we are giving name as test -VPC -1. This is our VPC, and let's go with 10.0.0/24. 16 will take, and tenancy everything I'll leave as it is, and I'll create VPC here. Test VPC has been created. Let's go to our VPCs. This is our VPC, test VPC, and if you see here 10.00, that's one. Let's create a subnet for this. These all are the default one. While creating subnet, I'm selecting our VPC which we recently created. Now I'll name it as VPC1 subnet. I'll keep availability zone as well, and CADR block 10.0.0./24 to 56 IPs, and tags I leave as it is, and let's click on create. Yeah, it has been created. Let's create internet gateway so that our VPC will have internet gateway, so it will communicate with the internet. The instance which are created under VPC, they will be having internet access. This is our VPC attached internet gateway. Cool. We have attached our internet gateway to VPC1, so the instance which are created under, they will be having internet. Let's create route table as well. Test VPC1 route table. This is our VPC. Let's click create. Let's associate our subnet, VPC1 subnet, save association, and now click on edit routes, add route, which is internet gateway from anywhere. Click on internet gateway and select the internet gateway which we recently created and save changes. Cool. Done. Now let's create a security VPC and create our VPC2. VPC only test -VPC2, and let's select the range 100.168.0.0/16 and default tenancy. Let's click create VPC. VPC will be created, and select subnets, create new subnet. Let's select VPC2 name as test-vpc2 subnet. In general, everything subnet will be private subnet. uh, for demo purpose, I am doing this without naming convention. And let's give our subnet range 1.168.0.0/24 IPs. Cool. Let's create a subnet. Subnet has been created. Let's click internet gateway. VPC2 internet gateway. This is for internet gate. I mean our second VPC. Let's click attach VPC and select our second VPC. Attach internet gateway. Cool. Subnet association heavy. Test VPC subnet. Let's click on the subnet and see. Test subnet. Click on route table VPC1. Okay. Let's create route table. Test VPC-2 and select our second VPC and click create route table. In subnet association, add our subnet. Cool, that's fine. You can add internet gateway here if required. Done. Now we have VPCs and subnets and route table, and to proceed further on this, we need to have two EC2 instance. Let's create our first EC2 instance. Name as PR-EC2-1. Let's go with Amazon Linux, which is free tier. Yeah, free tier. Let's select key pair as the one which we recently created and change the VPC to our recently created one. First we go with VPC1 and we'll assign public IP. I do already have security groups created, so I'll go with existing one and I'll click on advanced details and I'll add a small script over here. Cool. This is our script and let's launch instance. Cool. While the instance is being launched, let's create another instance as well. PR-EC2-2 and let's go with the same thing, free tier, and select the existing key pair. And this time change VPC to the second VPC which we created, and it will assign public IP. I do have security group already created, so I'll go with EC2 security group and let's add our script here as well and change these to EC2-2 and click launch instance. Let's go back to our instance and see if the instance are running or not. Cool, we do have one instance. Let's refresh and see if the status check has been finished. Yeah, for this it's finished. Let's connect to our instance once. We are getting the response, so it's fine. It has to. Let's wait for another some time. So definitely we'll be able to access. And let's add HTTPS as well for our security groups. This is our second security group. Edit inbounds, add role, HTTPS. And let's go back to our security groups and change for our EC2 one as well. Edit inbound rules, add role, HTTPS from anywhere, save changes. Cool. Now this is our EC2 one. Okay, this is our EC2. Let's go back to our instance. If you see here, 10.0.227 is the private IP. 10.0.0.227. This is our EC2 one. Okay, let's connect to our EC2 2. First we'll copy this private IP from EC2 1. We'll ping private IP of EC2 1. If you see, it will timeout. Okay, let's connect to this EC2 instance as well. If you call localhost, it should show EC2 2. See, it is showing. Okay, now if you ping the private IP of instance 1, it will fail. Same error it will show. Okay, why? Because they are not in same VPC, they are in different VPC. That is why we are getting such errors. So to avoid that, I mean to make this action successful, what we need to do, we need to have peering connection to be allowed. So for that, go to VPC, click on peering connection, create peering connection, and add VPC 1 to VPC 2 is our peering connection. Okay, let's select our VPC 1, and you can add VPC peering with the same account or with a different account, and within the same region or with any different region as well. Select the second VPC here. Why? This is the requester VPC 1 and acceptor is the VPC 2. Okay, click on create peering connection, and here we need to accept the peering connection. Click on accept request. Now the peering connection has been done successfully. Now what balance we have is we have to edit the route tables. Go to route table 1, click on edit routes, click on add role. Now we are in VPC 1, right? So go to VPC 2. We are in route table of VPC 1. Okay, click on VPCs, click on VPC 2 and copy the CIDR of VPC 2. Now paste the CIDR in here. Okay, and make it as peering connection. Peering connection, and select the peering request which we recently created and save changes. Okay, now go to route tables, select our second route table VPC route, edit routes, add route. Now come back here and select the private IP, I mean CIDR of VPC 1. Now go back to our VPC, paste it here and select peering connection and add the peering request, save changes. Now peering connections has been done. Now if you come back here in our EC2 instance and if you run the previous command, the ping will work. See, 10.0.0.227 is the instance 1 private IP. Earlier we were unable to ping, but now we are able to. Okay, and if you call the same private IP 10.0.0.227, we will get the output of that one. See, hello from server EC22-1. This is from EC2 mission. Now this is our 227, which means first instance. This is our second instance. 192 series. This is our first instance. Now if I run this previous command, and this is the private IP of our VPC2 EC22, see, the communication will happen. Similar way, if I call that IP 1.168.0.237, we will get response as server EC22. This is how the peering connection work. EC21, EC22, both vice versa, we can ping and we can communicate. This is how peering request works. Hope you enjoyed the session. As a part of our AWS Masterclass series, today we will see session 12, which is Route 53. And as earlier we used to have readme file, right? I have created a readme.md file in GitHub. You can go through the complete documentation just for your reference for the Route 53 introductions and what are the things that we use in Route 53 and definition things, everything you can go through here. And to start with, Route 53 is a service provided by AWS. That is the first thing, okay? And it is highly scalable and available and fully managed domain name service system provided by AWS. And it is used to translate human readable domain names such as google.com into mission readable IP addresses, okay? And how it works is, for an example, we are accessing AWS console, right? And we are using, it's a web URL, aws.amazon.com. and similar way, if we use Google, we'll enter google.com. It is easy to remember, but in the backend it will be having an IP addresses, and the user, whenever they type Google or something, it will be resolved to the DNS with the IP, and then it reaches the server and gives the output to us. I mean, gives us the web UI. So that's how it uses, and it is easy to remember names, right, instead of IP addresses. So that is the reason why we use Route 53, and this is the key features. And I also provided we have two zones in Route 53, which is public and private. Public means it is accessible over the internet, and private means it is within the VPCs. And here if you see A record is maps to name to IPv4 addresses, and C name is alias to another domain name. You can go through this for more information. And without wasting your time, let's begin session. Search for Route 53. Okay, this is our Route 53. Before proceeding, I would like to let you know that here in our GitHub repo, if you see here what I mentioned, user types some Google or something DNS, it should resolve to their IP addresses, right? It is a domain, and we need to have our domain first, correct? To get the domain, you can go to no IP and get your free domain here. I use no IP website to get the domain, and you can just search for mine.noip.com and click sign in with your Gmail or GitHub accounts. Under the DNS records, you can create a hostname, and a hostname will be created, and we will be using this DNS for our Route 53. Now click on get started. Under this we have multiple things, okay? We can also register a domain in the Route 53 and we can transfer domain, configure the traffic flow and health checks and everything. We'll create hosted zones first. Click on create hosted zones and get started. Here give name for the hosted domain. It is asking for domain name, right? What is our domain name? This one, Prashant DevOps. And then optional we can ignore, and yes, we want it for public hosted zone. Click create hosted zone. Hosted zone will be created. Yeah, if you see here, now you can create records in the hosted zone to specific how you want route 53 to route traffic for your domain. Wonderful, cool. We have created this domain. Now it should show us NS and SOA type records. Yeah, this one I was speaking about. Now we will be using CNAME. Okay, if you using any other domains, and you can use these names in the your domain registry. If you have GoDaddy account and if you have purchased a domain there, you can mention these values in the GoDaddy and you can use this domain as well. And now we need to create a CNAME. Okay, and we are in the hosted zone, and then we need to click on create record, and after clicking on create record, we need to provide the record name, which is www. I'll keep, and record type I'll keep it as CNAME. Record type I'll keep it as CNAME, and then value is our domain. This is our value. Okay, and TTL30 simple routing. Okay, now click create. Let's enable alias what we are getting. Okay, that's fine. I'll create a record here. I'm just creating a record. Error. Let's see why it is failing. Please try again. Fail to fetch. Let's try again. Wonderful. Our record has been created. If you see here, CNAME record has been created for Prashant DevOps and with the domain. Now we need to create a EC2 instance. Let's duplicate this tab for a while and go to search for EC2 in the services. EC2 launch instance. Test hyphen demo hyphen PR. This is our EC2 name. I'll go with Amazon. Free eligible tier. Free tier. Key pair. I have an existing key pair, I believe. Yeah, let's use this key pair and select our VPCs. I want to use which region we are in. Okay, let's go to our south so that we can have our own VPC. Demo iPhone PR. Amazon Linux. Retire eligible. Key pair. Let's select. Okay, let me create a key pair. Click on create new pair and new iPhone route 53 iPhone. Yeah, key.
Mostly I'll be using 40, so I'll keep it as ppk and I'll click create. Once you click create, it will be downloaded. Yeah, see, now click on edit VPC, select our custom VPC. If you are not aware how to create a VPC and subnets everything, we have discussed this in our previous sessions. You can go through them, and if you have any questions or queries, you can comment and I'll try to respond. Security group also will created. Advanced details. Let's add a small script over here. I'm using hello from EC2 Prashant DevOps. It will be under index.html. Launch instance. Our instance will be launched. Verify the status. It's in pending state. Let's wait for a while till the pending state changes. Yes, our instance is running. I'll just copy our instance ID and browse it. Hello from server EC2 Prashant DevOps. Cool. We are getting the response. Now what you have to do is copy the public IP addresses of EC2 instance, public IPv4. I'm copying this. Now go back to no IP website and click on this edit under the DNS records and change the IPv4 to our IP and make save changes. It will take some time. Wait for a moment. And if you are using GoDaddy or any other applications, as I discussed earlier, you can copy this 4 and paste in the DNS custom names, and we can browse these as well. But since I'm using no IP free domain, I'm just copying the IP addresses. Okay, and now copy our DNS, browse in. You should see the same as we have seen with the IP addresses. Hello from server EC2 Prashant DevOps. And if I browse prashantdevops.ddns.net, you should see hello from server EC2 Prashant DevOps. So that's how we can map our IP addresses to the DNS. Okay, and here CNAME maps the domain and A records maps to domain, which is IP, and no IP provides the dynamic DNS. Okay, in simple words, we have used the no IP website to get a domain. We have created a domain. Okay, after that we have created a hosted zone. Okay, and for hosted zone we have added our CNAME and mentioned our domain Prashant our DNS. Later we created an EC2 instance. We provided an index.html file in that EC2 instance, and we browsed the IP addresses, and it was showing same exactly as we mentioned in the hello from server EC2 Prashant DevOps. Now we went to our no IP and we changed the IP addresses to our public IP. And when we browse this DNS, let me go incognito and show you again. When we browse the domain, we should get the same hello from EC2 instance, hello from server EC2 Prashant DevOps. That's how it works. And same we can get from these IP addresses as well. Hope you understood. And for more notes, you can see here. You may ask me, what is hosted zone? Hosted zone is a container for DNS records for a domain, which means for our domain. And we have public hosted zones which resolve DNS requires from the internet, public IP. This is what we have done just now. And private hosted zone is it will be within the VPC, so it may not accessible outside. It may
It is accessible only within the VPC. Okay, that's the one thing. You can see here, you can use Route 53 with EC2, LB, CloudFront S3 gateway, AKS and VPC and all. And the architecture is simple. User creates a Route 53 and you can also use CloudFront application load balance and then EC2. You can manage for this. And did I miss anything? And these are the supported domains for Route 53. Cool, that's it from my end. And as I mentioned earlier, you can also use this DNS name and route your traffic if you are using GoDaddy or any other application to get your any other websites to get a free domain, or if you are purchasing domain, you can just, here we just change the IP addresses, right? There you will be having DNS details, custom domain details and some information you can see, and you can change accordingly. And that's it from my end. Hope the video is useful to you, and I request you all to subscribe to our channel for more DevOps related content. And as a part of our AWS Masterclass series, today we will see session 13, and in session 13 we will be covering AWS System Manager, EventBridge and CloudWatch monitoring. Okay, now if you see, first we'll go with AWS System Manager, and it is a management service that helps you securely manage, monitor and automate the operational task across your resources such as EC2 instances. I mean, in simple words, you can manage EC2 instance operations which are going to do it on that, and you can manage the instance and monitor the instance. Okay, and without wasting your time, let's start our demo. I'll go to AWS console, and for this you need to have a EC2 instance. I already have an EC2 instance in my account. If you are not aware of how to create an EC2 instance, I request you all to watch our previous sessions where I have shown you how to create launch instance. Click on launch instance, give name to your EC2 instance, select AMI and instance type and a key pair. Key pair is used to log in into your EC2 instance, and here network. Here we can select VPC, subnets, security groups, all those things. Okay, upon providing all the details, if you click on launch instance, an EC2 instance will be created. Now we are going to see AWS System Manager, correct? And in System Manager we have a service which is SSM agent. We have SSM agent. Okay, and let give me a moment here. If you see, SSM agent is a software agent that runs on your EC2 instance, and it enables system manager to communicate with that instance. Okay, in simple words, if you want to connect to your EC2 instance and the EC2 instance needs to have SSM agent installed, if the EC2 instance is having SSM agent installed, you don't need to open port 22, and we can automate patch instance and all those things. You can find the pre-installed SSM agent supported OS list over the link provided here. See, these are all the links, and let's we already have an EC2 instance. Okay, after creating EC2 instance, click on instance ID, click on actions, security, IAM role. Why we need to have SSM agent installed, correct? Yes, I have selected an AMI image that has SSM agent pre-installed. Cool. So our second part is also completed. We already have an SSM agent, but how you will be connecting to it? You need to have a role which assigned to your EC2 instance.
To do that, click on create role for AWS service, and for EC2 click next. Here we need to select the policy. The policy is Amazon SSM manage instance co. Click on next. Give role name SSM policy for EC2. Give name in such a way that the people who are reading the name itself, they can understand the policy. Okay, let's create a role. Wonderful, role has been created. View role. Here we are able to see the policy, right? We can select here. Just to give you again, click on create IAM role. Click on create role for EC2 AWS service, and for EC2 click on next. We need to attach a policy. The policy we have selected, right? SSM managed SSM managed instance core. You have to select this. Click next. Provide a name and create role. A role will be created. You can find that in the roles. Upon creating a role, just come back to our EC2, refresh the page. You can see the role here, SSM policy for EC2. Click update IAM role. If you see, the policy has been assigned. Now click on connect. If you see here, SSM manager, it's showing offline. Let's wait for a while. You can connect now from fleet manager. Search for fleet manager. Fleet manager. After clicking on fleet manager, you can see your instance here. It will take some time. Just wait for a while. In the managed roles also, we can see our instance. Click on instance, click on node actions, click on connect, start terminal. You will get the terminal. You can search who you have, two users, ls. So this how we will connect to our EC2 instance in managed nodes using SM agent. Just to give you in brief, in using system manager, we can monitor the services and manage securely. We can automate the process, and we can connect to EC2 instance seamlessly without port 22. To do that, we need to create a EC2 instance, and after creating EC2 instance, we have to assign a role. After clicking create role, we have to assign SSM in Amazon SSM managed instance core policy to the role, and upon creating successfully, come back to EC2 instance, add the role here. You can add by clicking instance security modify IAM role, and after updating, wait for some time. Meanwhile, you can verify here. If you see here, SSM agent, it was unable to start earlier, but here if you see, SM agent worker started, and after SM agent worker is started, we have verified in fleet manager our EC2 instance appeared successfully, and we clicked on instance, then node actions, then connect, Start session terminal. You will easily verify this session here. If you click terminate, it will end the session. This is how you can connect to EC2 instance. I mean Linux EC2 instance. You can try with the Windows as well. To do with Windows, you just need to launch a new EC2 instance again. Click on launch instance. Give name as Windows EC2 AMI. We need to select AMI. Let's see which Windows Server Nano versions it seems. Windows Server 22 will go. Windows Server 22. Select this. I'll subscribe on instance launch. Cool. I'll go with free tier AM. Yeah, this is free tier T2 micro. Key pair. Let's create new key pair for Windows. I'll go with OpenSSH. Here I'll change the details to my custom VPC. If you are not aware, I request you to verify our previous sessions where we clearly explained how to create EC2 instance using VPC, and we have also had a separate session with the complete VPC. Click on launch instance. We'll wait till the instance launch. Cool. Click on ID. Let's wait till it start. Cool, it's running. Click on actions. We already had a IAM role created, right? Click on security, modify IAM role. Select the role which we previously created, update IAM role. Now the instance is having IAM role. Go back to fleet manager, wait for some time. The instance will appear here in 2 to 5 minutes or some. Let's wait. You can check meanwhile if SSM agent installed or not. Click on connect. Let's verify if security check is done or not. Yeah, it's still security check is going on. Let's wait till it finishes. So basically we have seen how to connect for Linux missions which has pre-installed SSM agent, right? Similar way we are verifying it with Windows. That's it, nothing else. Let's wait till the status check finish. And meanwhile, do you guys know what is this status check 2x2 check passed? If not, the status check 2x2 means the check 1, it checks if the actual physical hardware and power cables are working or not. And this check 2, I mean status check 2, it will check if the operating system, whatever it may be, Linux or Windows, started up and is responding to the network or not. These two it will check, and once everything is done, it will show green and it will be ready to use. We can use it. Cool, it's done. If does not, then let's verify this thing. Click on connect. SM agent still offline. Maybe it is trying to restart. Let's refresh the page. Here if you see, it is showing SM agent status is offline. We have to wait some more time. We'll wait for 1 or 2 minutes. If that doesn't help, then we'll try to troubleshoot by using RDP client. Cool, wonderful. If you see, the SSM agent is showing as online and it's ready to connect. You can connect directly. It came into PowerShell. Okay, that's okay, cool. Now go to Windows. You will be seeing both instance here. Click on Windows, click on Node Actions, click on Connect, click Connect with Remote Desktop. By this you will get the complete these things. Windows 1. Let's browse our key pair. I downloaded it, correct? Yes, WinKeyPem. I'll upload my key and I'll click connect. Now the window will come. Just a minute. Cool. Great. And again, it does not require the RDP port as well. Okay. I'll copy paste everything. We haven't passed our credentials. We just use the key pair. We browsed it and just selected connect, and it's loading now. I'll just wait till it comes properly and we can disconnect. Cool. SM agent is running. This is how how to connect using SM agent with the help of Fleet Manager to an instance which has pre-installed SM agent. Okay, and if you are selecting any other AMIs which does not have SM agent pre-installed, then you have to follow the steps which will be showing here. How to install, all those steps you have to follow. That's nothing. You can just go through the steps you can find. I pasted the official link in our GitHub readme file, and I also mentioned the role which we need to go. Cool. Hope you like the session. In our previous session, in session 13, we have covered system manager as a part 1. In this session, we'll cover EventBridge, which is part 2. And EventBridge is nothing but it is a serverless event bus, which means, in simple words, it connects AWS services and SaaS apps, which means software as service applications. If you are not aware of it, I request you all to watch our previous session in our AWS Masterclass series. You will understand more on that. And in simple words, when an EC2 instance status change or an object or any other files are uploaded to S3 bucket, if you want to get notified or if you want to receive a notification, you can use this service. To create that, first you need to have an EC2 instance running. Okay, let's duplicate this tab. I'll show you my EC2 instance. I haven't created any new EC2 instance as I already have an instance here. I haven't created the one. This is my EC2 instance. And if you're not aware of how to create an EC2 instance, VPCs or security groups, I request you all to watch our previous session. You can understand more on those topics, and I kindly request you all to subscribe to our channel, because most of you guys are watching our videos but not subscribing yet. I request you all to subscribe so that you don't miss any further notifications from my end. So to do that, first we need to create an SNS topic. Okay, go to SNS topic, SNS simple notification service. I already created a SNS topic here. If you see, you will be getting a topic. You have to click on create topic, provide a name for the topic, and create topic. After creating a topic, it will ask you to create a subscription. In this subscription, it will show, if you click on create subscription, it will show you what protocol you want, how you want to receive a notification. So I selected email, I have provided my email address here, and I created subscription. After this, the status will show you pending confirmation. If you verify your email addresses, you will be getting notification, and I have confirmed the subscription as well. So it is showing as confirmed. Now we need to create a EventBridge. Click on create role. First we have to create a role here. Okay, click on create role and then give a name for the role. I'll go with instance status and event bus. Click next. What you want here? Okay, for EC2 service, I'll select with EC2. Cool. Our event is EC2 and event type is instant state change notification. Okay, any state. If you want specific state, you can go, I mean, stopping or stopped, terminated, running, pending. I click on stopping, stopped, terminated, pending. These are my topics. And any instance, this is for any instance. If you want for specific instance, you can click on specific instance and provide the instance ID. Let's provide our instance ID. This is our instance ID. Paste our instance ID here. Click next. The target, how we want to receive. The target is SNS topic. Under this topic, you can select in this account or any other account as well. You can change this and you can provide your other user, you can provide your other account details as well. For now, I'll go with the same account. If you see here, this is the topic which we have created in subscriptions. If you see here in a SNS topic, they notify me. This is my topic. It will highlight here. I have selected the same. Execution rule. It says EventBridge needs a permission to send EventBridge. We can create a new role for this specific resource. Okay, that's fine. I'm okay with a new role. I click on create next. Tags I don't need as of now. Just verify once what all you have provided. Enable status. Stat is stopping, stop, terminated or pending. Cool. Notify me via SNS. I'll click on create role. Now our role has been created. Wonderful. Now what we'll do, if you want to receive a notification, first the instance should be in stopped state or stopping state, right? Go back to your instance, change the state to stop. Click on stop. Now you should receive an email. I'll go back to my inbox. See, as soon as I just click my inbox, it is showing as, I'll click on dashboard. I have one event bus, one role and one scheduled group. What it is? Default. That's okay. Default one. Fine. This is my role. Whenever an instance is stopped or something, I should receive an email. See, I received an email here. Notify me. Version ID, type, instance state change notification. If you see here, notify when EC2 is stopped. Why we are receiving that? Because in subscription we have provided that here, notify when EC2 is stopped. That's why we received that. Notify when EC2 is stopped. See, continuously I'm receiving. EC2 change notification time, state is stopping. The state is stopping and it is stopped. Stopping to stopped we have received. So this is how you will be receiving emails and you can click on unsubscribe here. See, it will give you complete information, status change and region, all those things. So in this way you can get notification when an instance is stopped, start, or any actions on any other services in AWS. You can use EventBridge and SNS topic to receive notification.
As a part of our AWS Masterclass series, today we will learn Elastic Beanstalk and RDS. Before we moving on to demo, I request you all to subscribe to our channel for more information on DevOps related courses. And if I have prepared the notes in our GitHub repo for the same, you will see what is Elastic Beanstalk, RDS and everything here. If you see, Elastic Beanstalk is a platform as a service. Okay, in our initial videos on AWS Masterclass series, we have learned as PaaS, SaaS, right, which means software as a service applications and all those things. Similarly, Elastic Beanstalk is a platform as a service, which means it will give you platform, okay, that allows developers to deploy and manage applications without managing infrastructure manually. Hope you understood. Which means the Elastic Beanstalk will automatically create EC2 instance, load balancer, and monitoring and everything as per your requirement. Okay, let's begin our demo. Search for Elastic Beanstalk and after that click on create application, give name, click on create. Now create an environment for your application, correct, web server environment. Domain, you can provide your domain if you want to have your custom one, like if you give your name or something and check availability. If it is available, this domain is used. Platform, I'll be going with Python. Here you can go with the sample application or existing versions. For now I'll be going with custom code. I'll label version as 1.0. It is in local file. You need to have these three applications and in zip file. I mean, you can Google or you can get your custom application which is in Python and requirements and everything. Click open. I'm going with single instance. You can also go with any, but as a free tier I'm going with single instance. Here we need to provide service roles. Okay, I already had, so I'm not providing any roles here, but I'll show you what roles I have given. Search for IAM roles, click on roles. If you see service role -pr, service role -pr, this service role I have created to manage Elastic Beanstalk, and these are the policies I have given. Elastic Beanstalk enhanced health and managed update customer role policy. And the other one is for EC2 instance, which is Elastic Beanstalk EC2 role PR. Here I have given three policies: Elastic Beanstalk multi-container Docker, Beanstalk web tier, and worker tier. You can get these, you can directly click on create role and the policies will automatically select. As of now, I don't want to go with any key pair, so I'll be clicking next. VPC. I have a custom VPC, so I am going with that. If you are not aware of how to create VPCs, subnets, and security groups, I request you all to go to our AWS Masterclass series in our YouTube channel, and you can watch the videos which we had uploaded earlier for creating custom VPC, subnets, and security groups, and also for a public IP. I'll be selecting two public subnets for this and then click next. This is monitoring tool optional, so I'm skipping it. This is also an optional one, so I do not go with anything here right now. Yeah, verify here. This is our environment type, application name, and the file which we uploaded. And this is our platform. This Elastic Beanstalk and all those things. If you want, you can change the platform as well. Let me show you. Here, if you see, we provided Python and this, right? And here you can see the other as well, other supported. So for now, I'm going with 3.14 and 4.10 single free tier instance. Just I'm reselecting the file. -pr. I'm selecting with custom VPC and my public subnets, public IP. Click next. These are optional one. You can change as per you can, but for now I'm leaving it. Verify again here, it will show you details. Okay, click on create and see. Now if you see here, the application demo application environment is being created, and you can verify the details which it is creating in the events. If you see, environment is started and it is using S3 bucket. Similar way, you can verify all the details. It has been created security group. It has created a public IP. Let's wait for another few minutes. Waiting for instance to launch. Wonderful. It is pending its state. Once the instance is being created, it will highlight here. Wonderful. An instance has been added. Go to AWS. Click on EC2. Search for instance and change it to running state. This is the instance that has been created. Now you can verify the name demo application environment, and this is our demo application environment. Refresh the page. Cool. It's in running state. Let's verify if status check is done. Yeah, status check has been completed. Go back to environment. Deployment has failed, but deployment has been successfully run. Let's wait for 2 minutes again. Okay, let me try to upload my zip file again. Let's wait till this finishes. Great. If you see here, environment has been updated successfully and health is okay. See, when I browse my domain, it is showing welcome to Prashant Nandam channel, AWS Masterclass series, Elastic Beanstalk, Python 3.14 successful deployment. Now, if I go back to instances, this is the one running, right? And browse the public IP, I should get the same. Let's wait a moment. See, it is showing the site can't be reached. Why? Because it is in HTTPS, but we deployed in HTTP. See, this is how it works. So whenever you want to test some application, or you want AWS to manage environment like EC2 instance and everything, in that scenario you can go with Elastic Beanstalk with your custom application code. And let me show you my code as well. I had two files, which is application.py and requirements.txt. This is my application content, I mean sample details. This is what we are seeing, masterclass series and successful. And in requirements.txt, This is what I have wrote. I deleted the other file due to which we were encountering errors previously. And let me show you another one as well. Click on create environment, give name as sample. Here you can search for sample and see what is available. See, this is how you can give your custom domain, where this one it will change. And same again, I'll go with Python. I'll leave it as it is. Now I'll go with sample application. Okay, earlier what we did, uploaded our source code, right? Now I'll go with sample application and single instance, and I'll show you how the sample application will look like. Same roles I'm selecting again, nothing new. VPC again, our custom VPC and availability zone as well. Public IP is set to false, but we need public IP. Yeah, I enabled it. Cool. Let's just click on create. Again, same, you will see here what we see in our web page. Right now we'll see sample one. Again, you can see in the events creating environment and what all it is going to do. Just let's wait for some time. It's waiting to launch EC2 instance. Cool, it's still pending state. Let's wait for a few more minutes. Wonderful, it is done. Now if you see, domain will be our one which we provided, sample 1 2. This is how the sample site look like. And go to EC2 instance, and where it is, we had another one as well we recently created, right? This one. Browse this IP, it should give you the same. See, this is how it works, the sample one. As a part of our AWS Masterclass series, today we will continue session 14, part 2, which is RDS, Relational Database Service. Okay, and it is used to manage database services. I mean, it allows users to create and manage databases without installing or maintaining database software, and it supports MySQL, PostgreSQL, and Oracle, all those things. You can go through the details for more information here without wasting your time. Let's get back to into our demo. And here one more thing, in our part 1 we have created a EC2 instance with elastic beanstalk, right? This one we will be creating RDS server now, I mean RDS database, and we will use the same EC2 instance to access the RDS database. Click for RDS, choose this one, Aurora and RDS, create database, and in this select MySQL standard, this one, and then let all things be same. Choose template as free tier. Here in database settings, you can see what all availability zone during here, everything. Since we are going with free tier, we will be getting one instance. And in settings, provide the DB name, pr-rds-demo, and let the master name be admin, and self-managed password. Provide a password for this. Confirm again. Great. Upon confirmation, go to instance configuration and select the this one, T3 micro. This will be sufficient for us. And in connectivity, select EC2 instance, or we can go in this way. Select the same subnet. Yes, for public access. This is subnet group. VPC security group. This one. Availability zone. Let it be random. Give as AWS demo DB. This backup window and everything you can choose as you request. Let's click on create database. Okay, this needs to be underscore. Let's wait till the database create. VPC does not support DNS hostname, it seems. We need to update the VPC and try again. Let's go to our VPC, choose our VPC. This is our VPC. Let's enable DNS hostnames and save this. That's cool. Let's click on create again, it will work. Cool, our database is being created. Let's wait for a while. We'll wait till it finish. And it should show available here. Then we can proceed with further action items. It may take 5 to 10 minutes, so I'll pass and I'll get back again. I'm just adding port 22 inbound to access the EC2 instance. Wonderful, we are able to access the EC2 instance. Great. Let's see if the database is created. Wonderful, the database is also created. Now what we have to do is go to EC2 instance which has been created with elastic beanstalk. This is the EC2 instance. Okay, go to the security group. If you come here and click on security, you can see the security groups for this. Click on that security group and copy the security group name. You can see here security group name. Copy the security group name. Now go back to RDS server. Click on this. Again click on security. This is the security group. Okay, click on this. Click on edit inbound rules. Edit inbound rules and add a role. Here we have to select MySQL Aurora and the port 3306, it's correct. And in the source you have to choose the EC2 instance security group. We just copied and paste it. And then save these changes. Wonderful, changes have been saved. Now here if you see, we already connected to that instance, right? Come here and now update this first by running sudo m update -y. Cool, it's up to date. Now install MySQL on this. Yum install MySQL -y, enter. Okay, did we enter correct spelling? Fine. Okay, let's try the other one as well. MariaDB will try. Sudo m install -y, it has to install. Completed. Now verify MySQL version. MySQL -, version. It is showing wonderful. And now run this command, okay, which is MySQL -h and our RDS endpoint. Go back to RDS. This is fine. Let's run this as it is. Click enter password. Great. We are into, if you see here, we are into MySQL now. Now we have to enter show databases. As our server version is 8.4.7, then we will be seeing our database. And now what you will do, see, database is changed. Cool. This is how we'll connect from our EC2 instance to RDS database. So in this session 14, we have seen how to use Elastic Beanstalk and create an EC2 instance, and then how to create an RDS database and how to access it from an EC2 instance. Hope you enjoyed the session. In our AWS Masterclass series, we will see session 15, which is, if you see here, we have done with session 14, and today we will be covering DynamoDB and AWS Lambda. As usual, I have prepared a notes for you in session 15 readme from readme.md file. And if you see here, DynamoDB. What is DynamoDB? It is a fully managed, no SQL database service which is provided by AWS, okay, and it delivers fast and predictable performance with seamless scalability. Okay, hope you understood, which means DynamoDB is a fully managed NoSQL database service. That is the first thing, and it is provided by AWS. That is the second thing, and third thing is it delivers fast and predictable performance with seamless scalability. Okay, now why DynamoDB is used? Because it gives high performance with low latency and automatic scaling without manual intervention. We don't need to do any scaling. It will scale automatically, and it is fully managed. No server maintenance is required. And again, if you see when to use DynamoDB, when you are running a web application or mobile application in backend or gaming or any microservice architecture, in those cases, okay. And key concept is, in DynamoDB, you can create tables, items, and attributes, which means tables means collection of data, items means individual records, and it is data fields. Okay, and in this video, we will be seeing three things. Okay, I mostly divide this session into two parts as we did previously for session 14. And first thing is,
we will see what is DynamoDB, how it works, and how we create data in it. And in part 2 we will we will be covering Lambda as well today, Lambda service. We will see what is Lambda and how it works. And in the third, in part 2 only, we will be seeing how to integrate Lambda with DynamoDB. These three things we are going to see today. Again, first thing, in part 1 we will see what is DynamoDB and how to create tables and everything. And in part 2 we will be covering Lambda function. In addition to that, we will see how Lambda function works with DynamoDB. Hope you understood. And before proceeding into demo, I request you all to subscribe to our channel for more DevOps related content, and please share channel information to your colleagues or friends or someone who is interested in learning DevOps courses, so that it will help me as well. Cool, let's begin. Go to AWS console, and as usual I'll be selecting a region which is close to me. Now click for DynamoDB service. See here, manage NoSQL database. Click on this. Once you click on this, click on create table. Okay, after creating a table, give name as we'll be going with engineering details. Imagine you are in a college or something like, and there are some engineering students and you are capturing their data. Okay, name it as engineers. And okay, and here if you see table, what we have seen in our readme file, if you see a table, what it is, collection of data. Okay, table means collection of data. And the other thing is partition key, which is very important. Let me give details. Engineer ID, and it is a string. It can be anything. You can change number, binary, and L. And why partition key is being used, DynamoDB finds data using this partition key. Okay, and example, it may be for now we are engineer ID or student ID or roll number or PAN number, any other, whatever the detail you are provide in this partition key, DynamoDB finds this data using the partition key. Hope you understood. Okay, and it is a unique identifier. That's it, and leave this for now. And now create table. You can create table or customize settings as well, standard, and I'll go with the default for now. You can see default table settings here: capacity mode, maximum read capacity, and write capacity. We'll see this later. For now, click create table. It is creating. Let's wait. Great, wonderful. The engineers table was created successfully. Cool. The table has been created now, and here if you see read capacity mode and write capacity mode, which it is like I've selected default, right? That is why it is showing on demand. If not, it will show you some number 5 or 1 something like. After clicking on this, it will not show as on demand when you select customized or something like. It will give you some random one, and if you check on that, it will give you 1 or 5 and maximum is 10 read in that way, because it will give you maximum 10 read capacity or write capacity, and if it is more than 10, it will automatically scale up the infrastructure. Okay, now we have table. If you see here, we have table, but we don't have any data here. So what we need to do, we have to create a data, which means create table. Click on this. Now if you see here, table is engineers. Okay, and click on create item. Provide the ID here. We can also use JSON here. Click on JSON view. I mean, if you want to go with here, you can provide engineering ID, which is 123, and you can add new attribute as well, which is if you select string, it will give you string. If you select number, it will give you number. In that way, you can provide engineer ID. Let's mention as something like 100, and next add new attributes and click string and add attribute name as name and value as Prashant, and then again new attribute will go with string again, and department will add now. Department, which is cloud, we are going with engineer, no? Let's add mechanical, that will be easy. Mechanical engineer, add new attribute and again string, and here what we'll do, years of experience, years, let's just mention years, mention 4 years. Yes, it will be for 4 years engineer, and then we'll add, this is not string here, it should be number. Years, which is 4, and then we'll go with string, we'll add location Harvard. This fine for now. Let's click on create item. It is created successfully. Create new item. That was 100, so this, let's give 101. Add new string name Satya, then department, oh sorry, department, civil engineer. Let's add number, years, 4, and location we can ignore location actually, because it is not like it should be same or something, which means, let me create first, I'll show you. Now if you see here, this Prashant has location, but Satya do not have any location. Okay, so this is the huge advantage that we can have in this DynamoDB, which is schemeless database. Nothing like it is not mandatory to provide all the details. It's up to you. You can give what all you needed. Okay, now we create a data, right? Just come back, click on filters, attribute name, give it as engineer ID and equal to string value 101, and click run. It will give you only for that value. See, completed, item return 1, item scan 2. Why we have 2 items, that is why 2. This is the one we created. Okay, and we are receiving the data. Now if you go to here and do 103, it will not return 0 items. Why? There is no 103 item at least created. Engineer data has been created. Let's create now. I'll give only engineer ID as 103, and I'll go with string. Now I'll give name, just go with the name itself, Ishwar. I have created. If you see, only it automatically runs. Just check Ishwar. Similar way, if I go to 100 and run, see, this is what we can use. Updating records and everything we can do here, and if needed we can also delete the item. And this is how we can store data within DynamoDB. And this is just for sample and for your understanding. You can explore more on this item by going to official documentation thing. Query also you can do. Now you can do query as well. What I did, I have selected the table which is engineer and selected a specific attribute which is name. And now when I run this, it will give me only name and value is 103. See, we have did query here. We have selected our table and specific attribute. We have given our attribute here which is name, and partition key. As we discussed, it is very important to find our details. The value is 103. And now what it will do, for at per attribute engineer id which has 103 value, it will return their name. See, this is what it will do. Now the same thing, if I do 101 and click run, it should return another name. See, that's how it works. Hope you understood. Today we will see session 15 with part 2, which is Lambda function. And Lambda is a serverless compute service that allows you to run code without provisioning or managing services. Okay, and it automatically executes your code in response to events and manage the compute resources. And if you see here, why it is used: automatically scale applications and reduce operational cost and pay only for execution time. Okay, and you can go through complete details here again. And the language it supports is Python, Java, Go, Ruby, Node.js and all. Before proceeding into demo, I request you all to subscribe to our channel for more DevOps related content, and please share the channel information to someone who is interested in learning DevOps. Cool. Let's begin our demo. Search for Lambda. Click on create function. Select author from scratch. Give function name as engineer data. Let's select this as Python 3.14. Click on create function. It will take some time. Let's wait. Okay. Cool. The function has been created. Now understand the screen here. Okay. And this is our Lambda function. I mean, we just created this, right? That is the one. And now delete everything which is here in lambda function.py. And I do already have a code. You can use your own one. I mean, you can just Google it and get some code for testing purpose. Yeah, this is what I want. There will be option to deploy. Yeah, this one. Click deploy. Now it has been successfully deployed, and run test now. Okay, click on test, and here create event it is asking, right? Click test, create new test event, give event name. Let's write a test event. Let everything be same, and in this change this details. Let's add our details here. Name, and let's add Prashant here. Prashant 95, and then let's add department as well. Department mechanical. That's it. Cool. Now this save and run this one. Save it. You can see save option at the top. This one. The test event was saved successfully, and you can run this now. See, when I run the test, it is giving me output as 200, which is success status code, and name is test event, status is succeeded, message hello Prashant 95 from mechanical team. You can see other details like start request id and request id and now, and it is easy to fetch values here. Let me show you the code which I added. If you see here, event is the input, okay, and event get is the department details it is getting, and once we test and run, we are getting the response as like this. Hope you understood. And now what we'll do, we will see Lambda function with DynamoDB. Okay, to do that, we have to create a IAM role. Okay, and to do that, scroll down, duplicate this tab, click on IAM, click on role, use case is Lambda, click on next, and in permissions, attach policy which is DynamoDB full access, this one, and click next and give role name Lambda Dynamo test and create role. Wonderful, a role has been created. Now go back to your event, go to Lambda, or else instead of going there and creating role, we can create from here as well. Click on configuration, and in configuration we can see permissions at the left side. Somewhere we can see permission. Search for that here, permissions, click on permissions, and then here if you see execution role and click on this, it will take you to IAM. Click on add permissions and attach policy, and search for Dynamo Amazon DynamoDB full access, and just add permission over there. Policy will be attached. Great, we have added the policy now. And now check permissions, what all it has. Yes, it has two. And go back to our Lambda role, click on this function and click on code. Let's edit this and add the other code. I already had saved this in the, you can get it from Google as well. Just say sample code for Lambda function test with DynamoDB. We have added our code and click deploy. Wonderful, it has been successfully deployed. Now click on test, create new test event, give name as new test event itself, and in the search bar give details as follow. Let's give engineer ID which is 100 105, and I'll give name as name. let's give name for this, and name is PR, and let's add department as IT, PR and department as IT, and years equal to 10, and location, let's add location as well for this user. Delhi. And now if I save and run this test file, I have saved, right? Now when I click test, see the wonder now. Okay, it seems it's failed for some reason. Let's verify. Remember, these are case sensitive. Okay, the details which are providing are case sensitive. It should be, if they are lowercase, it should be lowercase, and if they are uppercase, it should be uppercase. Okay, now I understand this capital one, not small, because if you see, it's engineers and it's engineer ID. Okay, it's engineers. Let's verify if there is any else. Redeploy our code. Save this and test. It should work. Wonderful. If you see, status succeed, test event name, new user test, response status code 200, message, new engineer created successfully. Now go back to your tables, click this table, and if you refresh here and go to this explore table items, you should see Karthik here. Now what we'll do, I'll give this code in comments as well. You can use. Let's do another thing. Let's add more details here, like engineer ID is 900, name is Rakesh, experience is, let's add 15, location is Delhi. Let's save this, retest now. When you retest, it should give you success event. Okay, see, it is succeed. Now verify here, sorry, here verify. You should see Rakesh as well. Okay, this is how you interact Lambda function with DynamoDB. Just to explain you again in clear, what all we did, we didn't do anything. I mean, we haven't did anything much here. We have created a function, and upon creating a function, we went to configuration and permissions. We added our DynamoDB role here. If you see here, if you go to this, you will be seeing assigned policies. See, DynamoDB full access policy we have assigned to that. And after assigning policy, what our agenda, we want to trigger this Lambda function to DynamoDB, which means when we create a user using this Lambda function, that should trigger in the DynamoDB. To do that, I have prepared a code. You can just get this code from online. We are using Boto 3, and here to connect to DynamoDB, we are giving our DynamoDB details. If you see here, this is table, and what is our table name? Engineers. So we have provided our table name. You can find here, this is our table name, engineers. And after that, what we have mentioned, partition key. What is our partition key? If you see, this is the partition key engineer ID. What we discussed, partition key is used to find your details. So we mentioned partition key. If not engineer ID, return to 400 and say so missing input. And if new engineer, then mention go with this engineer ID and provide all necessary. If it is success, say success. If it failed, say failed. And in test event, we provided user details. We after providing this complete code, we deployed it, and upon deployment, we created a new test event and we have provided user details. We saved the test event, and when we ran test, you see we are getting errors. User has been created. Now same users will be there. So yes, I'll show you how this is how the users will be created. Okay, that's how we can trigger any service using Lambda. Not only DynamoDB, you can use Lambda function to trigger to S3 bucket as well. Hope this makes sense. Thanks. Today, as a part of our AWS Masterclass series, we'll be seeing session 16. In session 16, we'll be covering session manager and CloudFront. In today's video, I will be showing you how to access an EC2 instance without SSH key and without even opening port 22. Okay, and if you see here, session manager, and it is a feature of AWS System Manager. Okay, and it allows you to securely connect to an EC2 instance without SSH key or any port open like port 22 and even bastion host as well. And here, to use this session manager, instead of using inbound ports, we will use IAM based policies. I mean IAM based authentication. Why session manager is used? Because of security, and without even public IP we can connect to this EC2 instance just using an IAM authentication. You can go through this complete article. I mean, you can go through this complete readme.md file for definitions and the benefits of using CloudFront and the session manager. Without wasting our time, let's begin today's demo. And before proceeding with the demo, I request you all to subscribe to our channel for more DevOps related content and share the channel information to someone who is looking to learn DevOps courses. Thanks. Let's begin. First, we'll create an EC2 instance. Click on EC2. Click Launch Instance. Cool. Give a name for EC2. And choose Amazon Linux for now. T2 Micro free tier, that's fine. We are not even using the key pair here. Let's change this to our custom VPC. I'll go with public subnet. Let's enable public IP as well for a moment. And I'll be choosing existing security group. If you are not aware of how to create a VPC and subnets and security groups, I request you all to watch our previous videos in our AWS Masterclass series, where we have discussed briefly about VPC, subnets and security groups and even route table as well. Cool. Click Launch Instance. Proceed without key pair and launch instance. Let's wait until the instance starts and status check finishes. Instance is running and status check is verifying. Let's wait for a while. Meanwhile, let's go to our security group and remove if any port 22 is mentioned for inbound. Yeah, we do have port 22 SSH. Let's delete this. Save rule. Cool. Now we have removed our port 22 as well. Now what we have to do, we have to create an IAM role. Duplicate this tab, search for IAM, click on this, click on role, create role. It's AWS service and easy to click next. Here in policies you have to select SSM managed. There will be something core policy. Yeah, this one, service core, the policy system function. Let's add this one, instance core, and click next. Add as pr-ssm-policy and click create. Policy will be created now. Wonderful. Let's go to policies once. Yeah, in roles we can see the policy which we recently added. Go back to instance, click actions, click security, modify IAM role, choose an IAM role, pr-ssm policy, this is one, and update IAM role. Once you update IAM role, the policy will show under IAM role. Okay, here if you click on connect, it should show you SSM agent running. See, this is being in offline, that is the reason it is not yet, it is not able to connect. Let's wait till it becomes active. You know why? To use system manager and connect via session manager, we need to have SSM agent installed on the particular instance. Okay, and for this EC2 instance, this one, to connect, the SSM agent needs to be in running state. That is why we are waiting. Once the SSM agent is online, we can connect automatically. Uh, let's see if the AMI which we selected has SSM agent by default or not. For some AMIs, the SSM agent will be installed by default, and I'm not sure for the AMI which I selected the SSM agent is available or not. So just we'll check that right now. Okay, let's open port 22 for a moment. Just this is a testing environment, that is why I'm giving anywhere. I have updated the inbound rule. Let's try connecting it to the instance now via EC2 instance connect, as it is a Amazon AMI rule. I do have a, yeah, this command. I do have official document open, so this is the command sudo systemctl status Amazon SSM agent. This will show you whether the agent is installed or running or what. Okay, active and running. Okay, it is telling access denied. System manager instance management role is not configured for account. Okay, let's verify our role once again. SSM managed instance code. Yeah, policy is correct. Let's restart our instance once. Cool. Once we restarted the agent, the session manager SSM agent was showing online. Now, if you see here, agent worker started. Let's refresh this one. Cool. See, it is showing online and connected. Now, what we'll do, the policy which we assigned is correct. We verified that, and we opened SSH port for a while to see if the SSM agent is running or not. It has been running now, so we don't want this as well. We can close this. Come here again, click on instance, click on security groups again, edit our security group, remove SSH port. If you see SSH 22, delete, save rule. Now the inbound 22 port has been removed, which means it is not possible for us to connect to the instance via SSH. Go to EC2 instance, click connect. By connecting now, it will fail. Great, port has been blocked. Now we can do it in two ways. See, in system manager I have went to fleet manager, and here managed nodes, the instance which we have created will highlight. The instance name was test-ec2. You can see here name was test-ec2. Select this EC2 instance. Let me show you more clearly. Let's copy this instance ID and find it here so that you will understand. See, it is the same instance. Now click on connect, start terminal. It will give you terminal even without port 22, which means you are securely connected to your EC2 instance. You can see who am I, SSM user. You can perform your actions in this way. Okay, and the second way to connect to this instance is click on connect, click on SSM session manager. Since the SSM agent is inactive and it is working, and if you see connection status is connected, click on connect. You will experience the same here as well. Okay, you can search for who am I. You can get the host name hyphen I 154. You can verify the private IP 154. And the craziest thing is you can connect to this EC2 instance even without public IP. I can show you that as well. Click on launch instance, give name as EC2-2, Go with the same AMI and the same T2 micro without key pair. Select this test VPC. Previously, we'll terminate this session. Go to OK. Previously, we have created our EC2 instance in public subnet. I am creating it in private subnet, disabling the public IP, which means we will not get the public IP for the EC2 instance. Going with the security group which we already had, just click launch instance. Go with without key pair. Let's wait till the instance comes into running state. We don't want this as well for now. Let's wait for a while until the status come to running and 2x2 check passes. Wonderful, it is in running state. Great. Same again, we can click on actions, security, modify IAM role. See, no IAM role has been assigned to this EC2 instance. Modify IAM role. Select the role which we previously created. The same policy I am using here, and update IAM role. Scroll down. For EC2 we have same policy, and for test EC2, the one which we created with public IP. See, here we have public IP. We have role assigned. See, public subnet, it is in public subnet. And now for EC2 instance, you can see the same VPC, it is in private subnet and no public IP is assigned. You can click on connect, verify SSM agent, it is offline and not connected state. Okay, since it is still showing offline, let's verify our VPC. Duplicate this tab, search for VPC. Let's verify our route table. This is our VPC. Route tables. Now okay, I do not have any route table here, only public subnet. Let's create a route table here. RT route table hyphen private subnet, and select the VPC. Click create route table. Subnet association. Click edit. Add our private subnet. Save association, and then click edit again. Add route. Destination 00 and target should be NAT. Okay, we do not have NAT gateway as well. Search for NAT here. Create NAT gateway. PR-NAT gateway. Select our test VPC. Create NAT. Go back to route tables. Add that NAT here. Cool. Save changes. It might be still creating or something. Something here. Oh, state still pending here. NAT gateway state is still pending. Let's wait. Yes, now NAT gateway is available. Come back here and give it a try. It should work. Done. And verify if our public subnet has internet gateway. Yes, it does. Cool. We have done. Let's try now. If not, we have to create endpoints. It will take some time. Let's wait now. See, now our same EC2 instance, I'll show you. EC2 this is the instance. This instance does not have public IP, and this is in private subnet. If I click connect and SSM manager, I should be able to, and now if you see, it is showing online connected. If I click continue, it will work. Let me connect. Cool. See, if I enter who am I, SM major, and I'll go to root. I'll enter the same. I'll show you the public, I'll show you the IP as well. 2.19 2.119. Now if you understand here, previously we were not able to connect to this mission. Why? Because the VPC will be having root tables, right? Let me go to our VPC. This is the VPC which we selected for both public subnet type instance and private subnet instance. And for public subnet instance, when an EC2 is deployed in public subnet, which is this one, test-EC2, this is in public subnet, right? See, public subnet. When it was in public subnet, it has internet access. See, public subnet root. It has internet gateway, and same this one. See, internet gateway is attached to a test VPC. Okay, and this public subnet has, in subnet association, it has public subnet. In public root table, we have public subnet and we have internet gateway. So this can reach to internet and it will give you access to EC2 instance. Similarly, we do have private root table. Before, I haven't created private root table. That is why we were unable to make session via SSM agent. So I verified that I have created a root table for private subnet. Under this subnet association, I have added our subnet. Adding alone subnet does not help us. For that, we need to have a NAT gateway. So I have added NAT gateway. I have created NAT gateway. Let me show you. This is the NAT gateway which I have created, and it is in our test VPC. And after creating NAT gateway, I added it to the private root table. See, RT means root table, private subnet. 00 is for NAT gateway. Now private subnet root table sends the traffic to NAT gateway. Okay, sends to NAT gateway, and now the NAT gateway uses its public IP to talk to internet and sends response back to private IP. If you see, the NAT has a public IP. This is NAT gateway, IP address 1325. If I scroll down, you can see it is a public IP. It is a public IP, okay. Connectivity type is public, and it is a public IP, and private IP cannot reach internet directly. So we created a NAT gateway, and the NAT is assigned in private root table, and whenever an instance wants to reach internet, private subnet root table sends internet traffic to NAT gateway, And NAT gateway uses its IP address, which is this 13.200.157.125 IP address to talk to internet and sends response back to the NAT gateway. That's how it works. Okay. Now what we'll do, till now what we have done, we have worked and played with AMIs which has SSM agent pre-installed. Now if you want to access an EC2 instance which does not have SSM agent pre-installed, then what you have to do? I'll show you that right now. You can ask me whether it is showing Fleet Manager or not. See, EC2, it will show here and you can connect from here as well. Connect, and if it is a Windows mission, it will give you connect with via remote desktop. Along with the start terminal session, it will show you connect via remote desktop. Cool, we are able to connect, right? So let's ignore for a while. Go to instance. Let me terminate this instance just to avoid if any casting. Terminate. Successful initiated termination. Okay. As they are being terminated, let's create a new instance. Click on launch instance. Give name as demo-ec2 this time. I'll go with Rocky Linux. I believe Rocky Linux mission does not come with predefined SSM agent. I mean, it does not come with SSM agent installed. Let's go with this one. 8 official. Subscribe on instance launch. Okay, subscribe now. Fine, that's okay. I'll keep SSM for this one. I'll keep port 22 open until we connect to instance via SSM agent. You know why? Because we need to have we need to install the agent manually now, so we should be definitely need a temporary access to get into that instance. So that is the reason we are creating a key pair and giving port 22 access for a moment. You can ignore key pair as well, but for a safer side I'm creating key pair as well. I'll connect via putty, so I'm using putty. Once you click create, it will download. Let's select public subnet. Let it have public IP, and I'll select the existing security group. Just re-verify. You can go with private subnet and without public IP as well, as we did previously. Oh, it doesn't have port 22, just rechecking. Let's reassign the IAM role here. IAM role is mandatory, okay? Without that you cannot connect. Great. I just keep running. IAM role has been assigned to this mission. Let's copy this public IP. Take putty. You can connect from here. See, SSM agent is off. Oh, does this has SSM agent? Let's re-add port 22 until we connect and install SSM agent. Let's go with putty without wasting any time. It will be easy. Paste the IP address, and we need to upload our private key. Browse, choose the key which we recently created, click open, accept, and user will be Rocky mostly. Cool, we connected. Let's go to our admin guide, copy this command and see if it is already installed or not. Wonderful. If you see, let me make this font larger. Hope you can see now. Systemctl status, it is showing agent service could not be found. Okay, for this what we have to do, we have to install the SSM agent. What are the steps? These are the steps. The AWS has an official document. You can go to their website and search for this. I'll Yeah, quick install SSM agent on Rocky Linux. This is the one. Copy this command, go to putty, paste and click enter. Wait for a while. It is being RPM, the Amazon SSM agent RPM is being exact. Okay, it is installing. As the font is very large, I believe you can't see the content. Let's make a bit smaller. Change settings, appearance, change. We are in 24, right? Let's make it 18. Cool. Hope this is also fine for you. We have installed the SSM agent, and then verify what are the next steps. After installing agent, run this command again, systemctl status SSM agent. See, it is running. Worker agent started and running. That's wonderful. That is more than enough for us. Let's cancel, exit, come back to EC2 instance. Click on the EC2 instance. Go back to security groups. Select our security group. Edit inbound rules. Remove the SSH. Save rule. Come back to EC2 instance. Click connect. SM agent should work online. See, it is showing online and it is showing connected. You can connect from here. Who am I? Sudo hyphen I. Sorry, it's I. Sudo hyphen I. Root hostname hyphen I 130 1.130 1.130. See, for the same EC2 instance, we are able to connect after installing SM agent with the help of their official document. Not only for Rocky Linux, they have for Ubuntu Red Hat as well. I want to show you the fleet managed as well so that you can see if it is available or not. See, fleet manager and demo EC2. Click node actions, connect, start terminal. This is how it works. And at last, I will show you Windows as well so that we can conclude we did with public subnet, private subnet, and SSM agent pre-installed and SSM agent we installed manually. For that, come back here. We don't need this instance now. Terminate. Great, instance is being terminated. Click launch instance. Windows-PR. I'll go with Windows. Okay, let it be. I'm not sure if it has SSM agent by default or not. Let's verify that. T2 micro small L select. T3. Okay, no filter, then let it be. Click on edit. Let it has public IP. Select existing security group, and by default our security group I will be going with, and click launch instance. Proceed without key pair. Launch instance. Click on instance. Change it to running state. Click modify IAM role. Add our policy. Update IAM role. It is being initializing 2x2 check. Let's wait. Meanwhile, you can try connecting and see if SSMA. Okay, it's offline. Okay, 2025 does contains pre-installed. Ours is 2025 only. My Windows are 2025. Okay, let's wait. That will be fine. See, it is showing online and connected. Now you can ask me, we have RDP port enabled, so let's disable that as well. Edit inbound, RDP, remote desktop 3389. I am deleting that as well. Save rule. So without RDP in general, we cannot make remote session to Windows workstations, right? But with the help of SSM agent, we can connect. Click connect. SSM agent online connected. Click connect. It will give you terminal. I mean the Windows login. It will give you command line. I mean PowerShell or terminal in that way here. I'll show you remote desktop as well. Just give me a moment. See Windows PET showing. What is the command to verify? IP config. Correct. 1.234 IPv4 1.234. Go to instance 1.234 private IP. It's correct. Now from here click connect and connect. We are getting only terminal, right? And what you have to do to get the remote desktop, simple. Go to fleet manager, refresh the page. You can see your server here, Windows PR. Select this node, click on node actions, connect. See, this is what I have explained you when we are connecting to Linux machine. Connect with remote desktop. Click on that. This previous one. It is asking for credentials, right? Do we have credentials with you? We haven't had any credentials, so click connect. Let's see if we can connect via serial console. You know what happened? I forgot actually. If you have credentials, you can connect directly, but we do not have any credentials and we do not have any key pair, right? For that, we have to, we need to have a user at least. That's simple. Just give me a moment. Connect via this. Open new window. Just simple search for, give me commands to create a user in Windows machine via terminal. It will give you some commands. Copy this. Go to session. It is still connecting. Okay. I forgot we could have done a while creating EC2 instance itself, we can added some commands over there, so it could have created, but that's okay, no worries. Just paste the one which we recently copied. Let's add user has Prashant and the password has PR at one. We need something, right? PR at 123 and add. Let's add him. The command completed successfully. You can use these credentials now. Remote. It's Prashant. PR at 123. Let's wait for a while. Cool. Connecting, and it should give you in 2 minutes. Going through remote desktop. Okay. Now we need to change this one. It's a bit slow. Just bear with me. Our user does not have admin privileges, right? Let's give him admin privileges. Command completed successfully. Let's see if it works now. Okay, it's trying to connect. Let's see now. It taking some time. Let's wait. Let's wait for a while. Please bear with me. See, this is how we connect. Please wait for the local session manager. Okay, I'll wait. Windows PR. We are logging into that mission. See Prashant. And this is how you connect to EC2 instance without having public IP and with SSM agent installed on Windows machine. Cool. That's how we connect to Windows machine with SSM agent. In our next session, we will see AWS CloudFront, which is CDN. As a part of our AWS Masterclass series, today in this video, we will be covering session 16, part 2, which is AWS CloudFront. I have created the README file for the same. In our previous session, we have seen what is session manager and how SSM agent is used in Linux and Windows machines. And if you see here, CloudFront, AWS CloudFront is content delivery network, and this is a service that delivers websites, videos, and applications globally with low latency and high transfer speed. Okay, and CloudFront uses global edge locations to catch content closer to user's location. And if you see why CloudFront is used, because of its high latency and slow website performance, increased origin server load, and it also solves caching frequently. And if you see when to use CloudFront, hosting a static website and delivering images or videos to worldwide and streaming media content and all those things you can see here. In simple words, imagine you upload a video in one location. Say, for suppose we always using Mumbai, right? Imagine like you uploaded in a website in this Asia Pacific Mumbai region, and now a user from US opens your site which you deployed in Mumbai region. He opens that site and it becomes slow because data travels a long distance. How your website or application is deployed in Mumbai and a user from US is requesting that URL. So it takes a long distance and the data travels a long distance. So it takes time, right? And you you all may watch videos in Amazon or Netflix or any other OTT content, or you know how this is available for worldwide. I mean, not only from India, in other countries as well, they stream videos in OTT platforms, right? How they are available to the users, how the users are streaming those videos because of this content delivery network. Okay, now let's see a demo. We'll see a demo now. What we'll do, we'll create a simple website and we'll host it on the S3 bucket and we'll deliver it to CloudFront. For that, we need to create a index.html file. I already had an index.html file. This is the one for CloudFront. It just says hello from CloudFront, and this is delivered via AWS Content Delivery Network. And now search for S3, click on create bucket, and now give some name. PR-CDN. For now, we'll block all public access. Click on create bucket. Must not contain uppercase, it seems. Fail to create bucket. Why? Okay, bucket name is already taken, it seems. Let's give some random name. Cool, the bucket has been created. In this bucket, let's upload our index.html. Let's upload our index.html. This one, index.html. Click open. Select upload. We have bucket created
and a object in the bucket, which is our index.html file. Let's open this in a browser. Yes, we are getting, oh, this seems a different language. Let's verify what it was. Okay. Now open CloudFront. We need to search for CloudFront. This one. Click on this CloudFront. Click on Create Distribution. Create Distribution. I'll go with free tier. Click Next. Give name for distribution. Let's give as CloudFront. Click Next. Yes, our origin is S3. We can use customize origin settings as well. You can see protocol is HTTP only. Cage setting also you can. Cool. Select this as redirect HTTP to HTTPS and all. Click Next. Next. Create distribution. We'll wait till the distribution creates. Cool. The distribution has been created. Now if you see last modified, it is still deploying. Here successfully created distribution. It doesn't mean the CloudFront is completely created. It means the distribution is created and it's being deploying. If you see the state is deploying, we need to wait until it shows date and time. So let's wait. Cool. Now if you see here, last modified date is showing as today, and this has been deployed successfully. Just copy the distribution domain name, browse it in. If you see access denied, why we are getting access denied? Because the S3 bucket has blocked all public access. Search for S3. Now if you see the bucket which we recently created is blocked for all public access. It doesn't, we haven't given any public access for it. Block all public access is on. So to enable this for public access, we need to create a OAC, origin access control. Okay, to do that, click on origin. Let's see if you can create a new one. Click on create origin. Choose origin as our bucket is this one, origin access control. Okay, now we do not have any origin access created, so let's create a new one. In signing request, see S3 is already there, so let's create and copy this policy. Create origin. Now go back to S3 bucket, click on edit policy, paste the policy which we recently copied, save changes. Our bucket policy has been updated, and come back to distribution. Let's wait for our distribution to create again. It is showing as deploying again. Why we are deploying again? Because previously we have blocked the public access for S3 bucket and we haven't mentioned any policy, and we created a CloudFront distribution and we tried to access that particular domain, and then we have received access denied error. So we have edited our origins. We have created a new origin, which is this one. We have edited this and enabled signal signing request as S3 and we updated the policy in the S3 bucket. This is the policy. If you see CloudFront service principal, we have allowed it, and S3 bucket, this is the one which we created. So we need to wait till it finishes. We'll wait for a while. Yeah, last modified is showing. So copy the distribution name. If you browse this, it will take some time to load. This is the one we created recently. When we access our domain distribution name, we are getting error as 404. So why it is getting? Because initially we haven't created OAC. So for this we have created origin access control. So we have chosen this one. Okay, now this name is amazon.com for origin access control one. So click on behaviors, edit this behavior. If you see here, it has selected the first one. So choose the second one. Let all the changes be same. Save changes. It will again start deploying. Let's wait till it finish. Meanwhile, I wanted to show you, like, we'll be placing the policy here, and in addition to that, I wanted to show you static website hosting. This should be disabled so that the S3 REST API will be used by CloudFront. Let's wait till it deploy. Once it is deployed, we will be able to access this distribution name. Cool, our website has been deployed. Click on this domain name, or else let's refresh this page. It will be same, right? Okay, XML file does not appear to have any associated with the document. Let's create an invalidation. It will remove cached error. So for that we have to use this one. Let's wait till it finish. If there are any cached error, it will remove all the cached errors. Search it again. Okay, it is still getting XML does not appear and access denied. Okay, cool. Why it is happening? Because we have provided our distribution domain, but we haven't provided where to search. So let's provide our index.html, return this page. Now if you see here, when I search the CloudFront with index.html, we are getting the output as expected, and this is the first one. I mean, whenever a user from any location searches with this distribution name along with the index.html, he will get the content or the response from CloudFront, wherever it may be in the location. Now this is the original one. Okay, this is not cached one. The response has taken some time, right? Now if I refresh, this is the cached one. The response will not take much time. So it will search in the nearest region in my location, and it will give me output. See how fast the result is. This is how the CloudFront is used. And to explain you again why we are getting error without using index.html, the CloudFront does not automatically assumes the index.html. So we must explicitly tell it what file it should serve as a default. So that is why we have provided this name, and you can edit this as well. Go to CloudFront and distribution, click on settings tab. See, this is the default root object. Mention here as index.html, index.html, and save this. Again we have to wait till the deployment is finished. I'll remove this one. Cool, the modification has been done. Copy the distribution name. Now search without index.html. You should get any result. See, without index.html we have browsed this file and we are getting this response.
Now if I search again, the response will be very fast. So the first will be the original request, and the second will be the cached request. Just to explain you in short what all we have done to achieve this via CloudFront. First, we have to create a bucket. This is our bucket. Later, we have uploaded our index.html file, and then while creating a bucket, we have disabled the static website hosting. Later, we have blocked all public access. If you see here, on, which means it is not publicly accessible. Okay, and after saving this, we came to distribution. We searched for CloudFront. We have created a distribution. In distribution creation, we provided our settings, which is let me show you. Click create distribution. I then went for free trial. Click next. Provide the distribution name and provide. After providing distribution name, okay, we need to specify the origin. Let me give simple some random one. Click next. Our origin is S3. Why? Our object is in S3 bucket. So we have selected S3. We have to select that object. Once the object is selected, you can customize origin settings here. I mean, how many connection attempts and timeout, when you want to enable timeout, and cached setting also you can enable. Okay, once this is created, once you click on create, the bucket will be created. See, let me select the same. Once you provide all those things, it will come here and it will give you some website application firewall related things, and you can click next and proceed uh, to save. And after creating this bucket, what we have done, it will take some time to give you the deployment finished status. And once the deployment is finished, we came to origins. Why? The default origin is created with static website because we haven't provided the access level. See this one, origin access control, we haven't provided. So we have created a new origin, and we have provided access control, and we have created a new one. And once the new access is created, we have copied this policy and pasted that policy in these permissions. So the S3 object is blocked public access. So the S3 object is blocked publicly, but with the help of this policy, it can access via CloudFront to the users. Once that has been created, we will be copying this distribution name and providing the our file name index.html. Why? Because we haven't selected the default root object. Whenever a default root object is not specified here, the CloudFront will not aware which file to look. So we have provided our file name. Since our file name is provided, whenever we browse this distribution name, domain name, we will get the response, which is our index.html file. See, this is what we have in our index.html. We are getting the same. So this is how you will use the CloudFront. Not only for sample text files, you can upload videos, streaming videos, gaming videos, whatever you like to. So you can play with this for a while. As a part of our AWS Masterclass series, today we will see CloudFormation, which is session 17. In our last session, we have covered
AWS CloudFront, and today we will be going with CloudFormation. Before proceeding further, I request you all to subscribe to our channel for more DevOps related content updates. And I have already prepared notes for the same. You can refer to our GitHub repo and README file. Here, CloudFormation. CloudFormation is a infrastructure as a code, and that will allow you to define, provision, and manage AWS resources using a template file, which may be ML format or JSON format. Basically, if you want to create an EC2 instance, what you will do, you will go to AWS console, you will be clicking EC2, and then you will click on launch instance, right? You will click on launch instance and you will proceed with the next steps. But with the help of CloudFormation, you will be writing a program or code in YAML format or JSON format, and using that file in CloudFormation, the resource will be created in AWS. It might be EC2 instance or S3 bucket or any. Okay, and you can go through this for more information and the terms which are used in CloudFormation. Basically, you need to know what is stack. A stack is a collection of AWS resources that are created, managed, and deleted together using a CloudFormation template. Okay, and all resources in this stack are treated as a single unit. For now, understand a stack is a collection of AWS resources. Without wasting our time, let's get started with our demo. To do that, go to your AWS console, search for CloudFormation. We need to create a stack here. What we see in the stack definition is, stack is a collection of AWS resources that are created or managed or deleted using CloudFormation. To create a stack, click create stack. We'll go with the standard one. Choose existing template or build from infrastructure composer as well. It will give you some options. I had my code already prepared, so I'll be using my code. Here, if you see, there are three options. When you choose an existing template, you can get it from Amazon S3 bucket with its URL, or you can upload your file, or you can also sync from Git repo. For now, I'll be going with upload file. Before uploading, let me show you my content. This is my S3 template YAML file, this is the template format version, and description is, for our understanding, I have mentioned simple S3 bucket using CloudFormation. Resources, under resources, what you mention that will be created. What we are creating, S3 bucket, and type is AWS S3 bucket, and properties, in properties we have mentioned name, bucket name, tags, what all you required. I am going with that name. This is my bucket name. If you see, s3-template.yaml is my file name. I will be choosing that file. Where did I save? Mostly in desktop itself. Yeah, this is our file. Click open. Full. Once you upload a file, click next. Specify the stack name. I'll mention demo S3 creating and the stack of S3. And I click next. If you need any IAM role to be assigned, you can assign as well here. For now, I don't want any, so I'm going with all default settings. Click next. Review the settings here. If you see, template is ready, and this is the template URL, and description is this one. Click submit. Once you submit, it will take some time, and mostly 30 to 60 seconds. Once this is done, you can verify in S3 that the object is created. Bucket is created. See, earlier it was in progress, and you can verify the time. Start time is at 1440 and end time is 1441. Total duration it was taken is 15 seconds, and at last you can verify it is completed. Now let's duplicate this tab, search for S3. Our bucket should be seen here. See this one, my demo PR CloudFormation. My demo PR. You can verify our demo, our bucket name. This is our bucket name. I'll copy this. I'll see. This is our bucket name which has been created recently. Similar way, you can put objects as well here, and you can see stack info and all the information can be seen here. You can see our template as well. This is our template. In compiler, see, compiler is nothing but you can see all at once. I can change this bucket name, and if I save and if I update bucket, see what happens now. Click next. Next. No policy I need for now. I'll be leaving everything as it is. Update is in progress. Let's wait for a while. In progress. See, again it will show you how much time it taken. 18 seconds it has taken, and update has been completed. Now go to S3 buckets, refresh this page. Now I'll just search for our file. We are unable to see this file, and instead of 210.32026 we change it to 36. But where 26, we just renamed it. We haven't deleted or created a new file. We have renamed this 2103.2026 file to 2036. That is why we are unable to see the previous one. And if you see here, there are two files with the CF templates and the region. If you see here, we are in US East 1, so they are also in US East 1. Why these files has created? Because these are internal storage buckets and created by AWS to keep our templates safely. Okay, we didn't create it manually, right? AWS created it for us. So when we delete our stack, the main S3 buckets will get deleted, but this two remains as it is. Why? Because they are created and managed by AWS, and instead of we uploading the template, our template file, if you provide a template URL from S3 bucket, CloudFormation won't create the extra buckets. And this bucket, this CF bucket is just a storage location. Okay, this is how we use CloudFormation to create resources in AWS. Similar way, we can create EC2 instance, any other as well. As a part of our AWS Masterclass series, in this video, we will be seeing auto scaling groups. In our previous session, we have covered CloudFormation. If you haven't watched, I request you all to watch it for more information related to CloudFormation. Now in this video, we will be covering auto scaling groups. I have prepared a notes for the same in session 18. If you see here, auto scaling groups. What is auto scaling group actually? It is a feature in cloud platforms like AWS, and this automatically manages a group of compute instances, which are nothing but virtual machines, to ensure desired number of instances are running and high availability is available, and application scale based on demand. Okay, basically you will be creating a EC2 instance and you will configure it for an auto scaling group, and now whenever the requests are high to that website which is in our EC2, the instance will increase as per the desired number of our desired numbers which we mentioned while creating scaling group. Now if you see here, why it is used for improve performance and automatically adjust capacity based on the traffic. It will increase the instance and it will decrease the instance based on the traffic. You can go through this for more information, and if you see here, these are the key points you need to remember. Desired capacity, this is the number of instance auto scaling group tries to maintain all the time. Minimum capacity is the number of instance always running in our AWS console. Maximum capacity is upper limit of instance allowed. And scaling policy, it will be rules that trigger scaling actions. Okay, we need to perform some policies, we need to perform some rules. And load balance integration, uh, I request you all to watch our previous session where we discussed about load balancer. You will understand more about this. So let's get into our demo. Create an EC2 instance. Go to instance. See if there are any running. No. I'll go with Mumbai region. Click launch instance. Give name as demo-ec2. Let's go with Amazon instance only. Yeah, it is free tier, that's fine. Keeper, do I have any? Let's leave keeper. I'll select our custom VPC. If you are not aware of how to create VPC subnets, I request you all to watch our previous sessions where we discussed clearly about this VPC creation and subnet creations. Select existing security group. I have already created a security group, so I'm choosing select existing. If you don't have any, I request you all to watch our previous session where we discussed how to create security group so that you'll get more information related to it. Click on advanced settings. Scroll down. Here I have a user data already prepared. I'll show you this one. I'm using bin bash and it will update the instance and it will install HTTPD. It will start the service. It will enable the service. And I am writing hello from ASG demo. I'm placing this under var www.html index.html so that this web page will load. I'm copying this entire thing and I'm pasting it here. Let's launch our template. Launch instance. Proceed without keeper. We'll wait for a while. Our template has been created. Let's wait. Click on auto scaling groups. Create auto scaling group. Give name. We can give as auto scaling group hyphen demo. Let's create a template from this image. Give name for our template, which is asg-template. Create launch template. Now our template is being created. Okay, template has been created. What we did, we have created an EC2 instance and we have created a template of it. This is our template, and now we are using this template for auto scaling group. I am using the template for my auto scaling group. Now click next. In VPC and instance type, select VPC which we are using and availability zones. I'll select this public subnet and this subnet. Two subnets I will select, which is two zones. And after selecting our two subnets, we can select next. For now, I'm not going with load balancer. Click next. This one is important. Desired capacity. As we discussed in our desired capacity, number of instance, auto scaling group tries to maintain. How many instances we need it to maintain? 2 instance. Always 2 instance should be running. Minimum is 1, maximum is 2. Minimum 1 instance will run and maximum 2 instance will run. Let's go with no policy only. Click next. Go to previous one, to scaling groups. CPU utilization, if CPU utilization is 50, then it will create automatically. Instance warm up 10 seconds, let's say. Click next. Click next. You can verify all the details here. Let's create auto scaling group. It's updating. Let's wait for a while. Now if you see, we have only one instance. Go to instance. We have only one instance, right? But after creating our auto scaling group, we have 3 instances running. What we have selected, desired capacity 2. So number of instance tries to maintain. It will always maintain 2 available missions. Okay. Let's wait till it finish. Initialization. If you go to our instance which we created previously, if I open public v4, we need port 80 to be allowed in our security group. Let's verify. Yes, it's allowed. Cool. Our second instance is also up and running. Just rename it as -1 so that we'll remember this is the one we created first, and these are created by auto scaling group. Let's add port 22 as well as an inbound. Let's verify if our system is running or not. I mean, our code is running or not. System CTL status HTTPD. It's active and running. Let's curl localhost. We are getting response, so we should get is okay. It's HTTPS. So if we search for HTTP, then we should get. See, we are getting hello from ASG demo. This is what we had in our echo, hello from ASG demo. Now the similar one, we have updated our index.html in our initial image, which is EC2-1. Now if you see the second one, and if I search, if I browse this public IP, I'll make it to HTTP, you should see the same. See 40.173, which is first instance which we initially created, is giving hello from ASG demo, and the second instance which has been created using auto scaling group, which is 63.93, is also giving the same instance, is also giving the same output. Now we will see the second one. This is also from auto scaling groups. If I browse this IP and if I change this to HTTP, see same response I'll get, and this is how it works. Now what I'll do, I will delete two instances. Before that, let me show you desired is to instance to desired capacity to minimum to maximum to. So I'll change this template. I'll edit these details here for a while. Edit desired capacity to minimum is 3, maximum is, I'll change maximum to 3. I'll update this policy. Now what I'll do, I will remove these two instances. I'll terminate them. Successfully initiated termination. Okay. I'll just wait for a while. See, I have deleted our instance. Now within some time it will start recreating again two EC2 instance. See, once the auto scaling group identifies two missions are unavailable, it will automatically create another one. It will create only one mission because this is our default one, so it will not count this, it will create another one. See, another EC2 instance has been created and it is in pending state. I'll show you another magic as well. Let's wait till it get into running state. Cool, it is in running state. This is our default mission which we created image, so it is eliminated. And as per our auto scaling group policy, the desired capacity is 2, so it will always maintain two instances up and running. So this is 1 and this is 2. We deleted this image, this EC2 instance, so it is created another EC2 instance. Now if we browse this public IP, it should give us same response where the first instance was giving hello from ASG demo. Okay, now what we will do, go back to the auto scaling group policy. Desired is 2, minimum is 1 and maximum is 3, right? Now what happens, I'll do I will connect to one of the instance. I will write a command and that will increase the CPU utilization, so that the auto scaling group will try to create another instance as per our desired maximum quantity mentioned, as per our this one maximum numbers mentioned here. So for that we need to install stress sudo yum install stress -y. Yes, it has been installed. Now what we will do, stress -cpu 3 hyphen timeout 300. Let's increase the CPU here. It is dispatching stress. Meanwhile, let's go to our EC2 instance. Select monitoring, maximize the CPU utilization. Let's enable detailed monitoring. Once the CPU is greater than 50, it will create 3 instances. It will keep maximum 3 instances up and running. It will take some time. Let's wait. See, another instance is being created. The now if we verify the instance, if you see in monitoring, CPU utilization, it might have reached high. See, 99.35 it's reached. But as per our request, whenever the instance CPU reaches to is greater than 50%, it should create 3 instances. Now the CPU is higher, which is greater than 50, so it's created another mission and it is maintaining maximum capacity 3, and it is from 2 availability zones. Okay, now once the stress is, I'll show you one more thing. This is the one which recently created. Let's browse this as well. It should give same hello from ASG. Cool. Total 3 instances are being in running state. We'll wait till it initializing check finishes. Once it is done, I'll show you one more thing. Cool. Now what I'll do, I'll stop the stress. Yeah, it's automatically stopped. Now let's monitor the EC2 instance CPU utilization. As soon as it comes below 50, the instance will terminate. One instance will automatically terminated and it maintains desired capacity 2. Let's wait. It will take some time, so let's wait. Now if you see here, the another instance is being shutting down and it's about to terminate. See, now only 2 instances are in running state. I'll show you only running state 2. Now I'll go back to our auto scaling group. I'll refresh this page. See, instance is changed to 2. Earlier it was 3. Why? Because maximum running instance were 3 and the total desired capacity became 3. Now it is changed to 2. So whenever the CPU, as per the policy which we mentioned in auto scaling group, whenever the CPU is greater than 50, it will automatically create another instance. As per our provided, maximum capacity we mentioned 3, right? So whenever the load is high, it will maintain 3 instance. Okay, now if you see, only 1 instance is being running. All we terminate another one as well. 1 instance is being running. Why? Because minimum is 1. Minimum is 1. So according to that, it will change. The load is low right now, so it is started maintaining 1. Hope you understood this demo. As a part of our AWS Masterclass series, today in our demo, we will see session 19, which is backup and disaster recovery. We will be covering it in 2 parts. Part 1 will be backup and part 2 will be disaster recovery. Before proceeding into demo, I request you all to subscribe to our channel for more DevOps related contents. So first we'll create an EC2 instance. Click on launch instance. give name EC2-backup. I will be going with Amazon Linux. No key pair. I'll go without key pair. I will be selecting our custom VPCs and our custom public subnet, assign public IP, existing security group, and in advanced details, in user data, I'll upload my bin bash script. This will update our EC2 and install HTTPD. It will start HTTPD service and it will enable HTTPD service and will echo hello demo on backup to index.html file and it will store it in var www.html. So I'll mention the same here. Click launch instance. Let's wait until the instance is launched successfully. We'll wait for some time. Okay, our instance is being running. Let's verify if our script, our user data is working properly or not. We'll give some more time. We'll wait for instance check to finish. Cool. Hello demo on backup. It's working. Cool. Great. Now we'll duplicate this tab. First, to configure backup, we need to create a backup service in AWS. So search for backup, AWS Backup. Click on this one. Now we have to create a vault first. Okay. Create a vault. And backup vault is like it is a storage locker where all our backups stored securely, and we create one vault to organize our backups. Okay, let's give our backup name, vault name as demo hyphen backup hyphen vault VALT. Let's select the backup vault and select the default one, default encryption, and create vault. Wonderful, our vault has been created. Now let's create a backup plan. Click on backup plans, create backup plan. We need to build a new plan. Why we do not have, I'm not going with template, so I'm building a new plan. Give our backup plan name demo backup plan. Now scheduled. In simple words, if a backup plan is like it defines when and how the backup should happen, and here we are scheduling the backup for daily and storing it in our vault which we created. And backup rule, give backup rule name as daily backup, daily backup. Select the vault which we created previously, frequency is daily, backup time, let's keep everything as default, and life cycle will change this to 7 days. Create plan. Now it will ask for assign resources. Okay, and in assign resources we'll specify our specific resources and select EC2 resource ID. We'll select we'll go back to our resource and we'll copy instance ID. We'll paste that here.
not all instance, only resource ID which match this. Only these details will be backed up. Exclude specific resource IDs from the selected resource type. We can select EC2, or we can uh, leave it as it is since it is optional. Assign resource. Give resource name. We need to provide our resource name, so let's give backup EC2 resources pool. Assign resource. Our resource has been assigned successfully. Now what we need to do, we need to go to protected resources. Protected resources. Click on create on-demand backup. I mean, what we are doing, instead of waiting for the schedule, I'll be triggering backup immediately so we can see the result quickly. Select resource type as EC2 and resource ID is the one which is created. Create backup now. Total retention period 7 days. Tells AWS Backup how long to store your backups. That's fine. And the vault will be our vault which we created. We can go with the default IAM role. Create on-demand backup. As soon as it is started, it will create the backup jobs, and you see the status created, right? It will show completed. It is running. Let's wait. Once it is completed, our data is securely stored. Cool. Now if you see here, this resource has been completed. Now go back to our backup vaults, select our vault which we created, and you can see the image here. AMI completed EC2. It will stay here for 7 days, and same you can see here. So now we can select recovery point as well. If you click on this and actions, if click on restore, let's keep everything same. You can see here it is giving same as we selected, and showing private I mean our VPC as the test VPC, and subnet has public subnet, security group as so and so, the one which we created. And restore backup. IAM role is null. Let's create a role first. Duplicate this tab. Click on roles, IAM, and then roles. Create a role. Select AWS service, then AWS backup. AWS backup. Click next. Select or attach policies as AWS backup service. Let me see. AWS backup service role policy. Yeah, this one. AWS backup service role for backup. Select this one, and second one is for restore. AWS backup service role policy for restores. Select these two and click next. Give role name as
AWS backup service policy for for mm, restore. Let's keep it as like that. Then click create role. Now AWS backup needs a permission to access and backup resources, right? So this is done using IAM role, and we created an IAM role. Now what we need to do, we go back to backup. Now select the role which we created here. Just see, we are able to see. Click restore backup, it should work. Restore in progress for recovery point image, so and so. See, this may take several hours for status updates, and to view the resources, go to EC2 console. See, one instance is being restored and the state is showing as pending. Let's wait till it finish. You can stay here itself. Let's refresh this page. Status is running. Status is completed. We can see our results here now. Both are in running state. So let's change this to running state. See, easy to backup. The name also came as it is. Now, before it finish status check, I want to give heads up again what all we did. First, we opened AWS backup service in our AWS console, and this service is used to manage and automate backups in AWS. Hope you understood that point. And secondly, we created a backup vault, and the backup vault is a secure storage location for all our backup data. After that, we created a backup plan, and we defined how often backups happen and where they should be stored. I mean, in backup plan, we created how many days the backup should take and how many days it should be available for a user, and where the backup data should store. All those things we have created in backup plan. Next, we assign the resources. In resource place, we assigned EC2. Why? Because we wanted to take backup of EC2 instance, so we created a EC2 instance, and we added these sentences in var.html file, which is hello demo on backup, and later we taken backup of that in assigned resources. In assigned resources, we have selected EC2, and in EC2 also we haven't provided all EC2. We provided only instance ID for that particular mission, and then which means the assigned resources will tell AWS exactly what data needs to be backed up. Okay, then in the place of restoration, we needed a IAM role. Then we used an IAM role which gives AWS backup the necessary permission to access and protect our resources. Okay, we have created, we went to IAM and we selected roles, and we created a role, and we attached two policies for the role, and the policies are this one: AWS backup service role policy for backup, AWS backup service role policy for restore. These two policies we have attached, and after that we restored the uh, backup data which was present in our backup vault. If you see here, backup vault, this is our backup vault. This is our restore one, and for this recovery point we restored, and after that the resource has been created successfully. That's all we have done. After performing restore point, we are able to see the instance here. Just wait for a while.
This is the instance which we want. Now if you see here, the public IP v4 does not have. Do you know why? Because the resources, I mean EC2 instance which we restored is created under uh, our VPC, private VPC, right? So it won't have access, it is not accessible to internet because we haven't allowed auto assign public IP in subnet range. I mean, in subnet settings, we can auto assign public IP. So we haven't done that. So it hasn't created. To do that, we can just simply launch EC2 instance, or you can go to subnets here, go to VPC, select subnets, public subnet. Let's select this one. Actions, edit subnet settings. Here, auto assign public IP. If we enable this, whenever an EC2 instance is being created under the subnets in our VPC, a public IP will be auto assigned. Now, since we cannot assign a VPC, what we'll do, we'll create a public IP. For that, we need to select elastic IP, allocate elastic IP, just create allocate elastic IP and just allocate a IP address will be created. Just name it as for backup EC2, just for reference. Associate, sorry, we need to associate it with the EC2 instance. Associate elastic IP address. We need to choose our EC2 instance, for which one we doesn't have. 114D4B, 11D4B, 11D4B. Yeah, we have select our APC private IP address. Obviously, this will be 11. Select association. Now go back to this EC2, refresh the page, browse this IP address. See, hello demo on backup. This is how we can take backup of an EC2 instance and auto assign. I mean, we can auto assign public IP with by enabling in subnet, or we can create a elastic IP and assign it to our EC2 instance. So this is how we'll take backup and restore our data. And first we'll in backup, we'll create a vault. In backup, we will be creating a vault to store our data, and we'll be creating a backup plan. Backup plan is used to uh, in backup plan we'll mention how many days the data should be kept, and where the data should be stored. All the information can be stored here. And protected resources, instead of waiting for backup plan to run, we just uh, created on-demand backup, so the restore begins immediately, and upon restore the instance got without public IP. Since we haven't enabled the auto assign public IP in subnet level, so we have created an elastic IP and assigned it to our EC2 instance. Once the IP is assigned, when we browsed that IP in our browser, we were able to see the output, which is hello demo on backup. You will be getting same for our previously created EC2 instance as well. See, I'll change this to HTTP. This is how the backup data works. Do not forget to delete the resources which you created in your AWS console to avoid any charges. So just to delete resources, change this to running state, select all, actions, terminate, sorry, instance state and terminate. The instance will get terminated automatically. And in backup, role we can leave, that's okay.
Go to dashboard. Okay, this is the vault which we created, so I'll be deleting our vault. Mention confirm. We are deleting our restored point. Cool, point has a restored point has been deleted. Now delete the vault. Vault has been deleted successfully. Go back to backup plans. Delete our backup plan here. Mention the backup plan name. Demo backup plan. Okay, we have resource one. Now we can delete this. Cool, our backup plan has been deleted. Our old has been deleted. Protected resources. That's how we delete our resources. I hope the video helps you in understanding the backup and restoring the data from backup in AWS. And as a part of our AWS Masterclass series, today we'll be covering a demo on two-tier architecture, and here we'll be using EC2 instance and S3 buckets. Let's begin our demo. This time I won't be creating any GitHub notes for this. Just we'll focus only on demo part. Now if you see, we'll create a EC2 instance and we'll install a web application in it, and we will use some static files such as images in S3 bucket, and we'll let EC2 instance use the content which is stored in S3 bucket in the web application. So let me show you how it is. I'll be going with the Singapore region this time. Click on VPC, select VPCs, click create VPC, and give name as demo hyphen two tier. Select the range as 10.0.0.0/16. Let's keep everything as it is and create VPC. Now go to VPCs, see if the VPC is created or not. Yeah, if you see, this is the VPC which we recently created, demo two-tier VPC. Now what we have to do, we created a VPC, right? We need to create subnet for this. Select our demo two-tier here and click on subnets, create subnet, select the VPC which we created recently, name it as two-tier public subnet. Availability zone we can select as 1A. CIDR block is 10.0.0.0/24, where we will be getting 256 IP address. Create subnet. We will be creating only public subnet for this because we are not going to deploy anything in private subnet, so that is the reason. Now we have VPC created, we have our subnet created. Now we need to create route tables. Click on create route table, give it as two-tier route table and select our VPC. Click create route table. Route table will be created. Now under route table, what we need to do, we have to add routes. Okay, the destination, click on edit routes, In subnet association, add our subnet here, public subnet. Cool, we have added our subnet. Yes, we have our now we need to have an internet gateway. So first we have to create internet gateway. Give it as 2-tier internet gateway. Click on create internet gateway. Attach to VPC. Select the VPC which we recently created. Click on attach. Now again we have to edit routes. Go to route table. Click on edit routes. Add destination as 00 and here select it as internet gateway and select the gateway which we recently created and save changes. Cool, we have done with our route table as well. Now we need to create a security group. Scroll down, click on security groups, create security group, name it as 2-tier security group. Select our VPC, add inbound rules. We will be needing, we will be deploying our application, right? So to connect to our mission, let's select SSH and let's keep it as destination any for a while. Now we also need HTTP. Let's select HTTPS as well. These are the three required. Click on create security group. Okay, description trees for 2-tier demo. In real world, we won't keep it as all. We will be having some specific IP ranges or something like. We have created our security group as well. Now duplicate this tab. Click on EC2. Launch instance. Give it as EC2 2-tier demo. Select Amazon Linux, that is fine. Yeah, let's see if we have any free ML. Yeah, it is free type, that's fine. Let's create key pair as well. I'll be using with putty, so I'm choosing it as putty and 2-tier demo key. Once you click on create, it will be downloaded to your local machine. In VPC settings, click edit, select the VPC which we recently created, and yes, it is in public subnet. Allow public IP and select the security group which was created recently. Cool. Launch instance. Wait for a while. Go back to instance and see if the instance is up and running. The status check is initializing. Let's wait till it finish. Cool. The status check has been finished. Let's connect to the EC2 instance. Click connect. Since it is an Amazon EC2, Amazon AMI image, we are able to connect from the AWS portal itself. We have logged into the mission, right? Now what we have to do, we have to update. Let's update our instance. For that we have to run sudo m update -y, so it won't ask for yes approval or something like. Let's wait till it finish. Yeah, it's up to date. Now what we have to do, we have to install httpd -y
sudo yum install. Cool. Now let's start our service. Sudo system ctl start httpd. Now let's verify the status. It's active. Let's enable this as well. Yeah, created system link. Now go back to here, copy the instance public IP, browse it here. You should see the httpd page. It works. Cool. It's working. Now duplicate this tab, come back here. Now our first part is finished. What our agenda, we'll be creating an EC2 instance, we'll be installing a web application in it. So we have created EC2 instance, we have installed httpd on this. Now we are able to access the public IP in the web browser, and we are seeing it works. Now the next step is we need to create an S3 bucket. Okay, so for that we have duplicated our tab and click on S3. Click on create bucket. It's general purpose only. Let's keep bucket name as demo-ec2-s3-prashant. Let's keep everything as it is for a while. Let's enable this. I mean, for demo, as it is a demo purpose, I am allowing all public access. If not, we need to again create a policy and all those things. Click on create bucket. Just acknowledge the settings. Yes, bucket has been created. Now Apache has been installed, right? Now we need an image. Let's download one beautiful image. It's nice. It's sleeping and enjoying it moment. Let's download this image. Image has been downloaded. Go to S3 bucket. Click upload. Add files. Select the image. Click upload. Upload successful. Now close this one. Select this one and click open and see if yes, we are able to. Permission, see if yeah. Now our second part is also half is completed. We created S3 bucket. We created S3 bucket and we have added our image in the S3 bucket. So now what we have to do, we need to have a role here. Why? Because to let EC2 instance access our S3 bucket, the EC2 instance should need S3 permissions, right? For that we will be creating an IAM role. Come back here, duplicate this tab. This is our EC2 instance. You can see no policy has been assigned to it. IAM role, no policy is assigned. Come here and click on IAM role. Roles. I believe we already have an S3 policy. Let's see it. If okay, click on create role. It's AWS service and service is for
EC2, click next, and S3 full access we need to give this one, S3 full access. Click next, provide name, 2-tier demo S3 access to EC2, create role. The role has been created. Now come back here, see IAM has no roles. Click actions, security, modify IAM role, attach the role which we recently created, 2-tier demo S3 access to EC2, update IAM role. Now the EC2 instance is also have S3 access. Now go to our session here, install Amazon AWS CLI is here, sudo yum install AWS -CLI -y for s. Yeah, it seems they are already available here. Just click AWS S3 LS. You will be able to see the bucket which we created here. Sorry, no space should be there here. See, demo EC2 S3 Prashant. This is the name of a bucket. Demo EC2 S3 Prashant. Demo EC2 S3 Prashant. Cool. Now we have our EC2 instance has access to our Amazon bucket. Now what we have to do? Let's change the file to var www.html do ls -a. Okay. Now what we have to do? We should create a file here. Sudo nano index.html. We have to create index.html. Click enter. Now in this index.html, I already have a script prepared. Let me maximize this one. This should be replaced with our bucket one. So go to our S3 bucket. This one, S3 URL. Copy this one. Come back to our notepad and paste it here. Now copy all these things. Go to our EC2 instance. Paste it here. Save this file and then exit. Let's verify if it is prepared or not. I mean the content is saved or not. Yes, it has been saved successfully. Let's restart our HTTPD services. systemctl restart HTTPD. Click enter. The service is restarted. Now you will see the magic. Where it is? Yeah, this is our EC2 instant public IP, right? And earlier what we have run, Apache was running, it works. Now refresh the page and you should see the panda image. Image is corrupted here. If you see here, it is changed. AWS 2-tier architecture demo. Why it is showing? Because we have mentioned here AWS 2-tier architecture demo EC2 web server, and the image is HTTPS S3 demo EC2 S3 Prashant file name. Okay, let's copy the public IP and give a try in incognito. Continue to site. Image seems corrupted. Let's add a new image to S3 and see if it is works. Which one we can add? Let's add the simple one. Click open. Click on this.
download it directly. Downloads, shoot panda zip file image, cut this, paste it directly here and rename it to AWS demo. Come back to our S3 bucket, click upload, add files, select this one, click open, click upload. Now delete our previous one. Yes, it has been deleted successfully. Click close. Access this one via browser. Copy S3 URI. Yeah, it seems it's working. Now click on this. Copy object URL. We have copied our object URL, right? Have we pasted it here? I don't think so. Copy object URL. Go back to Notepad. No, try to save. Copy this thing. Go to EC2 instance and we need to replace this thing. Let's save it. Verify if it is saved properly or not. Yeah. Restart our HTTP service. Cool. Again, copy the public IP. Go to incognito. Close this tab. Browse it now. Did we miss anything here? Just give me a moment. This is our bucket name. It might be true. Our extension is JPG. What or yeah, it is JPG only. There are no possible reasons for it to get corrupted. Access denied. Okay. Okay, our object URL state is saying access denied. Let's go to our S3 again. Permissions and bucket policy. Click edit. Let's keep it as public read and effect is allow. Principal is star for everyone. Principal is star and action is S3. S3 dot get object and resource We can give it as ARN, ARN colon, then AWS, which one we are going, S3 colon colon, and then our bucket name. Let's duplicate for a while. What it is our bucket name? This is our bucket name. Our bucket name, inval resource of ARN. Just paste this ARN as it is and see what happens. Save now, it should work. Now go to object. We can simply refresh this one. Cool. We are getting object URL. Yeah. So you should be able to see the public IP now. Refresh this page, the issue will resolve. You know why it is getting this much larger? Just go back to our EC2 where it is. Yeah, here. Nano. Here we can mention the size, what it was, colon 300, I believe. Width is equal to after JPG. Paste it. Take some space here. Wonderful. Save this. Let's restart service. Now refresh this browser. See, this is how we will connect to S3 objects from EC2 instance. You can just simply try this here itself. Copy this public IP, browse in this web page, you should see the same. Okay, hope you understood. And this is how you connect to any S3 object using EC2 instance. Here we used public access. In production environment we will be blocking public access, and we'll be using different policies which may include CloudFront or content delivery network, something like. Okay, hope you enjoyed the session, and that's it from my end for today. I hope you all understood our two-tier architecture demo, and I would like to recommend you all to do a three-tier demo on your own, because we created two-tier, right? You just need to create a load balancer and attach this EC2 instance to those load balancer. That will be a three-tier architecture. You can explain that in an interview, but not exactly the three-tier, but it can be considered. You can explain that in an interview, and if not, you can also create an RDS server and install the MySQL in EC2 instance, and make configuration between RDS and EC2 instance, and that will also be a three-tier architecture, and you can represent that as well in our interviews. If you are not aware of how to creating EC2 instance with load balancer or RDS servers, I request you all to watch our previous AWS sessions where we clearly discussed about how to create load balancer and how to create RDS server and all those things. Hope this makes sense. By this, I conclude we completed our AWS Masterclass series, and I request you all to subscribe to our channel for more DevOps related content, and share this to your friends or colleagues or someone who is interested in learning DevOps courses. I hope the complete AWS Masterclass series will help you to understand AWS services in deep, and it will provide you guidance in AWS services. If you have any questions or any doubts, please mention those in the comments so that I can explain you back again. Thanks for watching. Have a great day. Bye bye.